I request all the delegates to please walk into the auditorium and take your seats, please. We will commence the Day 2 program in a few minutes' time from now. The sooner you come, the more we'll be on schedule. Thank you. Can we have some volunteers requesting the delegates to please walk into the auditorium, please?
Possible to do it. I think when you not duplicate, extend the screen or something, that works.
Sorry?
Mirroring of the screen.
They have to enable that.
Correct.
Who wants this?
We only, ARS.
Oh, you want it.
But can't you do it with the pointer?
Because see, he needs to see the PPT.
Slide changer.
Or I can keep my laptop here
No,
and then I can
see,
change it. I can.
No, see, this is connected to that and from there it is coming here.
Oh, okay. So then here if we have a PPT,
It's
then
mine,
we will
it's
just
mine,
PPT.
it's
Request the audio desk to please give us a slide changer. Audio desk, please. Slide changer and the pointer. Pointer? Go, sorry. So good morning, ladies and gentlemen. Please settle down in your seats. And we are now going to take off into the day 2 of this Asian conference, an international conference, the congregation of the best-in-class minds in the world of concrete and materials of construction. As we begin, I extend a warm welcome to those of you who could not make it yesterday. But yes, you have missed substantially, but today I am sure you will be able to not miss as substantially. And with this, we begin the day with a presentation from our sponsor, ARS Steel. I request Mr. Sumit Bhatia, the Vice President of ARS Steel, to please come out to the podium to make his business development pitch, please. Mr. Sumit Bhatia. Can we connect the laptop here? Laptop? You are not comfortable.
I'm not comfortable looking at back and talking. Yeah, so good morning, everyone. First of all, I would like to thank ICI for giving us this opportunity. Special thanks to Vinay Gupta ji and Venkateshwara Rao Garu for encouraging us to participate in this event. So today the subject of my presentation is low carbon emission steel for net zero buildings, and a subject which is very, very close to my heart and I'm very passionate about. But before I begin with my presentation, I want to remind all of us a very simple thing. Recycling is not new to us Indians, and we grew up in homes where recycling was our daily part and parcel. Old clothes were converted into quilts, glass bottles were used for kitchen containers, and metal utensils were melted and made new again. So this is our legacy and a culture where every resource was respected and given a second life. Today we are simply continuing that same on a very big scale, on a industrial scale, by producing high quality steel with very low CO2 emissions using recycled steel scrap, enabling net zero buildings for a sustainable future. So, but before we talk about industry and sustainability, let's take a moment to face the reality of the climate crisis. We are the first generation to feel the climate change and the last that can stop it. If we don't change how we build, the planet will change how we live. 2024 was the hottest year ever recorded, and 8 out of last 10 years have been the warmest in human history. The world aims to limit warming to 1.5 degrees Celsius. India contributes roughly around 7% of the global CO2 emissions. The message is very, very clear over here. Fighting climate change starts with transforming the industries that fuel it. So now when we talk about carbon emissions in a built environment, there are two types of carbon emissions. One is embodied carbon and another one is operational carbon. The construction sector alone accounts for nearly 40% of the global CO2 emissions, and that is massive. When we talk about building emissions, the most important is embodied carbon. Embodied emissions are the total greenhouse gas emissions generated during the production and delivery of a product before it is even used. So to have in simple context, when a steel is produced through a conventional route, the major raw materials are iron ore and coal. The iron ore and coal is mined, it is transported to the steel plants where it is used in blast furnace BOF. From there it is converted into steel, and steel is then transported to the actual consumer. So the total CO2 emissions generated in the total process, starting from mining until the delivery of the final product, is called embodied carbon. And second carbon is operational carbon, which refers to the greenhouse gas emissions produced during the daily use of the building. For example, lighting, cooling, running appliances. So when electricity is consumed to run a building, that is called operational carbon. So if we are serious about climate goals, we can't just make buildings more energy efficient. We have to also tackle the carbon footprint embedded in the materials that is used to construct the buildings. And that's where the conversation starts in our industry. So why net zero? If we want to have net zero building, we think about net zero carbon building. Why net zero starts before construction? Embodied carbon is the total carbon footprint logged into a building before anyone moves in. And embodied carbon is released instantly in the atmosphere right now and stays in the atmosphere for decades. In India's building sector today, operational carbon makes about 85% of the total life cycle emissions, and while embodied carbon is around 15%. By 2050, operational carbon will fall sharply because of lot of renewable coming in. Buildings are by renewable power, LED lightings, energy efficient appliances, air conditioning. But still embodied carbon is not factored. By if we want to have net zero buildings, we must tackle embodied carbon from day one, because once it is emitted and we cannot take that embodied carbon back. And net zero starts when we think about constructing a building, not after we enter inside a building. So let's look at the steel's share in building emissions. When we look at a building's life cycle carbon emissions, around 72% of all emissions happen before the building is even operational. That is during the production stage and construction stage. So if you look at the slide, the product stage is around 65% and construction stage is around 7%. So around 72% of carbon is generated during the building is even designed. Looking closer at the construction material emissions, steel is the largest contributor at 45%. This means steel alone is responsible for around 40% of all project phase emissions. And this is why steel is the single biggest lever to decarbonize built environment to reduce the embodied carbon. A change here can transform the entire carbon profile of the building. So I'll start my presentation with a quick overview about ARS. ARS, our vision is to become the most trusted and reliable brand committed to sustainability, carbon neutrality, and enduring stakeholders' delight. Our plant is located in Gumdipundi, and we operate one of the largest integrated steel plants in South India. We have over 46 years of experience and expertise in steel industry, particularly in procurement of premium quality recycled steel scrap. Around 33 years, we have been producing semi-finished, which is billets, a major raw material to produce finished steel, and now 20 years in TMT rebar manufacturing. The current installed capacity to produce TMT rebars is 276,000 tons per annum. Our future aim is to produce 500,000 tons of steel by early 2027 and produce 1 million tons of green steel by 2030. So here are our key performers. We produce 100% D quality. So D stands for ductility, where steel is produced with sulfur less than 0.04%, phosphorus less than 0.04%, and sulfur and phosphorus put together less than 0.075. We do not produce non-D quality. We are consistently, and we are pioneers in production of 100% D quality steel. If today a customer, a developer, a builder comes and asks me if you can supply me 5,000 tons of non-D quality, we say no, we do not do that. Only single quality, which is D quality. Now we also produced D quality with corrosion resistant steel, where steel is produced by adding copper and chrome and maintaining moly and nickel. We add these the corrosion resistance properties. So this product we launched in 2024, early 2024. When we launched this product, we did a detailed study across Tamil Nadu, and we found that water quality was very, very bad. The TDS was somewhere from starting from 100 ppm and went as high as 2500 ppm. So construction with poor groundwater quality should not be done with the normal rebar. Corrosion resistant steel is mandatory, is required if the water quality is above 300-400 ppm. Our corrosion resistant steel is certified by SCRC, which is a leading central government research institute, which confirms performance enhancement of 20 to 50% in building compared to a normal rebar. Another unique value proposition what we have is that we have world's #1 SGS, which is a testing and certification agency available at production point in our plant 24/7, 365 days in a year. Every batch which is being produced at our factory is tested, verified and certified by SGS. We also have a unique value which bring for the customer is we have around 12 mobile tech vans, and each van is equipped with a German-made spectrometer which is capable of analyzing 32 key elements, chemical elements in steel. And this facility is absolutely free of cost for the customer, irrespective customer is buying ARS steel or not buying ARS steel. Customer can call our customer care, the tech van will reach at its site, they will pick up the TMT rebar sample from the site and test it before the customer. And this idea also came out of our self-consciousness that we want to give extremely high quality to the customer. So if someone asks me who is my customer, my customers are people sitting around in this hall, individual home buyers who are constructing their dream houses. So the quality which will go to an individual house buyer, the same quality will go to a developer. Irrespective it is a DLF or any top developer, the quality is absolutely same. There is no disparity between an individual house customer or a top developer. So again, the campaign was called Know the Truth and Don't Buy Steel Blindly. We came out of this campaign, and for this campaign we have invested around 7 crore rupees in these tech vans and further expanding our tech vans across entire Tamil Nadu. So now what makes us truly green steel? We use over 98% premium quality recycled steel scrap and around just 2% of sponge iron. This input mix, this charge mix for producing steel is the most sustainable mix in the industry. We have a very, very impressive material yield of around 95%, meaning if we add 100 kgs of scrap inside the furnace, we get 95 kgs of high quality billet outside our furnace. Why this is? Because number one, the yield of the scrap is very, very high. Second, we have also invested in advanced scrap processing equipments. Each and every scrap which is coming inside our plant is processed in our scrap processing machines. Rust, dust, everything is eliminated and clean scrap goes inside the furnace. Second, very important. Now, what is benefit of scrap? It is not only quality, it is also the electricity consumption. So when we use high quality scrap with high material efficiency, our electricity consumption becomes best in class. We consume just 725 units of electricity to produce every ton of steel. The breakup is around 650 units to produce billets and 75 units which comes from auxiliary. So roughly around 725 units. We are still working, we are enhancing our equipments to reduce our electricity consumption to less than 700 units per ton. We have invested in captive renewable power projects. At present, we have signed 25 years long-term power purchase agreements where we have made equity investment. The total capex is around 350 crores for 70 megawatt. Our power plants are located in Tuticorin, where we have a wind and solar hybrid power plant. We also have captive solar power plant from where electricity is coming for our consumption. So now, with a combination of 98% recycled steel and renewable power, we have the lowest carbon footprint in the country today. Our CO2 per ton is at 592 kgs of CO2 for every ton of steel, which is around 4.3 times lower than the Indian steel emission intensity, which is at 2.55 tons of CO2 for every ton of steel. And global average is around 1.85 tons of CO2 for every ton of steel. We have been very blessed and fortunate that India is the first country globally to have released definition of green steel. So Ministry of Steel last year has introduced green steel taxonomy, where the green component of steel is determined by the emissions of the steel plant based on the star rating. So they have given star rating to the steel emission intensity, where 5-star rating is of steel emission 1.6 tons of CO2 for every ton of steel. 4-star rated steel is between 1.6 tons to 2 tons of CO2 for every ton of steel. And 3-star rating is from 2 tons to 2.2 tons of CO2 for every ton of steel. And above 2.2 tons, there is no star rating. So this is our green steel certificate, and we have been blessed that ARES is first recipient of this green steel certificate in the country to have received this certificate from Honorable Minister of Steel. Our CO2 emission intensity for last financial year is at 643 kgs of CO2 for every ton of steel, which is 2.5 times better than the best 5-star rating by Ministry of Steel. So now what is the best formula to make to use recycled steel, high recycled steel, renewable energy, and no fossil fuels? We are proud to say that in the entire manufacturing process, we do not burn even a single kg of fossil fuel. So this is the best formula to produce high quality green steel. So now, this subject is very, I'm passionate about this subject, where one of the biggest myths and perception in the industry is secondary steel is inferior and primary steel is good. But the reality is very different. Steel quality depends on the input raw material, not whether the steel is called primary or secondary. According to Ministry of Steel has stopped classifying any steel producers as primary or secondary. The only factor that matters whether the steel is produced in compliance to IS 1786 or not. So if you can see on the screen, the CRC sheet scrap which we are buying, this scrap is coming from automobile industry. So the phosphorus level is just 0.0065 in the scrap, whereas IS 1786 limits for finished steel is at 0.04%. So it is just 16% of what IS 1786 prescribes. Again, this is our chemical composition for finished steel along with our mechanical properties. This is Ministry of Steel which says that no steel producer shall be classified as primary or secondary. Quality assurance, again, all our test reports are available on cloud on our digital platform, providing complete transparency to the end customer. Transparency is a non-negotiable commitment for ARS, and that defines how we operate our business. Our labs are NABL certified lab, and we do real-time optimization in our labs. We have provided, to maintain complete transparency and trust to the end consumer, we have implemented a digital QR code where every batch of steel which is being dispatched to the end customer will go with a QR code, and QR code will contain real-time chemical specs, physical specs, and real-time CO2 data, providing complete transparency to the end customer. No asking ARS to give certificates. Everything is available on the QR code, digital platform. ARS Steels is the only company in India which assures my TMT rebar samples collected anywhere from my dealer. We have around 700 plus dealers across Tamil Nadu. Customer can go to my dealer, pick up the sample from the dealer and export it to any country. They can test it in any lab across the world, and the quality is assured to pass with flying colors. So this is our roadmap to net zero. By 2028, ARS will become net zero company. Ministry of Steel target is to reduce CO2 emissions to 2.2 tons by 2030. Our steel has been tested and verified by IIT Madras as well. Okay, now a global perspective quickly, that how steel is produced globally. So when we talk about Singapore, Singapore has committed to net zero by 2050, and the Singapore Green Building Master Plan aims to ensure 80% of the buildings to be classified as green by 2030. And Singapore's only rebar manufacturer is Nat Steel, which produces steel with 100% recycled content. There is no talk about quality, whether primary or secondary. This primary secondary is only in India, not globally. Japan is sitting on the most seismic active region, and its building codes require extremely high ductility, toughness, and performance. Japan relies heavily on rebars produced from recycled steel, using around 29 to 30 million tons of scrap annually. Again, across Europe, recycled steel is not a choice. People produce steel through recycled steel content. In fact, Tata Steel has closed down all its blast furnace operations in UK, and they are producing steel to recycled steel. So this is our product, which is 3-in-1 DCG product, a steel which is produced with ductility, corrosion resistance, and green steel, all together in a single product. Yeah. Thank you very much.
Mr. Bhatia, just a quick question while they are winding up the laptop, is that you said 725 units per ton.
Yeah.
What is the conventional production?
Sir, see, in conventional production, basically, the steel which is produced through iron ore and coal, there is no requirement for electricity. But in the same process, how we are doing through electric induction furnace, people are using DRI and sponge iron.
Okay.
There, the electricity consumption is somewhere around 900 to 1100 units per ton.
Thank you.
Thank you.
Hey,
Sir,
Sumit
we'll take the Q&A later,
Sure,
please,
sir.
because it's a sponsor presentation. Yes.
I don't have any question. A small request is there. We will ask many questions when we will visit your plant. We are having, we planned our governing council meeting in the month of March. Can we plan a visit to your plant? Huh? I will confirm you the dates. Thank you.
Thank you. Thank you so much, Mr. Sumit Bhatia, for the gesture. We appreciate that. Now we request Sri Cement representatives, Mr. Uday Singh, the zonal head technical, to please come over and make the business pitch. Thank you.
Good morning. Good morning to all the ACECON members, Chairman, President of ICI, patron members, and respected delegates and industry professionals. It's a great honor to present here among eminent experts who are shaping the future of mines of India's construction ecosystem. So it's my pleasure to introduce you to Sri Cement, one of the India's leading and most trusted cement manufacturers. Can you run the PPT, please?
Ina Sri Cement antunde sir. ఎంత టైం ఇవ్వాలి ఈయన 10 నిమిషాలు ఎంత టైం
Yeah. Our journey and mission, the company was incorporated and dream was born by our chairman H.M. Bangar in 1979, and in 1985 we started with the first integrated plant of 0.6 million ton capacity. If you look to the journey now, we are having an capacity of 66.4 million ton right now, and we are ambitious vision to reach around 80 million ton per annum in 2028. Our vision to be blue chip greenest building material solution company in India with industry leading performance benchmarks and leading innovation and best class in people. Let me introduce some of the pride of our company. It is one of the top 3 cement companies in India with a capacity of 66.4 million ton. One of the interesting things of our Sri Cement is the largest capacity of waste heat recovery based power plants, and it is 245 megawatt in the world cement industry. We are having largest kiln in India, and it is at Navalgarh, and it produces around 11,500 ton clinker per day. We have world highest production, that is the UCC, which is based at UAE. Our UCC achieved world highest production of clinker by single kiln, that is 14,500 metric ton per day. And second highest number of kilns in single location, that is the 8 kilns we are having in Rajasthan. And it is the highest number of kilns which is located in the world. The best part of it that the 1 gigawatt power generation is been generated, and around 56 to 58% is of green energy. And the interesting part is that we have supplied cement to Burj Khalifa, one of the tallest buildings in the world, through our UCC plant. These are some of the views of our RAS cement. If you look to our vertical business, we are dealing with cement, we are dealing with PPC, we are dealing with PCC, we are dealing with PSC and all types of cement. And soon in coming days, we will be coming with 53S also. And if you look to another vertical, that is the RMC. Right now, we entered last year, and we are having our 23 plants in Pan-India, and we are having an aspiration of more than 100 plants across Pan-India in 2026. And power generation, more than 1,000 megawatt power generation has been done, and as I told you that 56% of green power is being generated through the green power. And we deal with the ACC blocks too. Our footprint, you can see, we are committed to quality and sustainability, and Shree Cement today stand as a benchmark for operational excellence with a capacity of 66.4 million ton. And we have 6 integrated plants, 12 grinding units, and more than 30,700 dealers. And if you look to our UAE presence also, 4 million ton cement capacity with 3.3 million ton clinker capacity. Our operational excellence, innovation, and customer-centric growth in the cement industry. Now, this is something interesting that whatever we take, we give 8 times. That is the way we call it as a water positive plus 8. We have zero liquid discharge. And if you look to the carbon emission, by using of green energy, 9.4 lakh tons CO2 has been avoided using green 324. So we lost 75.13 out of carbon weight. This is something interesting one, and it is the Ministry of Defense, and Shree Cement's tribute to the brave hearts, and Naman is the project name, and it's our endeavor to honor the life of the soldiers who made the supreme sacrifice for our nation, the ones who will always command our highest respect and continue to live in our memories. Those, however, the martyrs who have lost their life for our country, Shree Cement is committed to give them free cement with FOR destination to their houses. And I feel that Shree Cement respects the brave soldiers who gave their life for the country. And this is a small help, our way of saying thank you and keeping their memory alive by building a stronger nation. I salute to the soldiers who have lost their life for us, for our country. Then looking to the Shree Connect actively engage with the professionals to share the right knowledge and bust on common construction myths. Every Monday, we used to give mythbusters on LinkedIn, and most of the engineers and professionals appreciated it. We provide valuable content like Monday Mythbusters, and there is also a Build Smart newsletter to promote scientific and quality-based construction. Recently, last month, we are having one dignitary here, Mr. Dr. Jagdish Vengala from Vijayawada, and he has given his letter in this newsletter. And we used to publish across Pan-India, sharing the knowledge and thoughts with them. Our responsibility towards the society, we deal with the education program, we deal with the infrastructure development, that is the CSSIR activities. We have product basket portfolio, as I told you, we have OPC, we have PPC, we have PCC, and soon we are coming with new types of cement, and which will be adding feathers to our cap of Shree Cement. Our products, very unique products. As yesterday, I heard one lecture about cash gel, that is CHS gel. And we are having one product here, Bangar Magna, which is very innovative cash gel formulation, which gives one day higher strength. We are having Roofon. It is having very unique features, as nano-sized particles plays very active role in concrete gaining strength and enhancing the high density concrete. This is a PSC cement, that is a marble cement. We produce in North India. In coming days, we will be coming in here in South India also. These are some of the technical services where we provide services to the small customers, that is the individual house builders, where we promote for quality construction practices. So a lot of consultation, cube tests use we are doing with this mobile testing van. Modern equipment, as I told you, that we are having RoboLab, XRF machine, XRD, and these are some of the equipments which makes Shree Cement the quality cement producer in Pan India. So the VRM technology, which is very much helpful for nanoparticles, we are having 4 patents. We are having DSIR lab at 4 locations, and in coming days we are coming with the new digitalization of our plants. The state-of-art QC lab and testing facilities. So let me tell you that producing a standard consistency of cement using varying quality of ingredient every day is a challenge. And the cement coming from the crusher to the packing, it needs around 184 checks, and we are doing it for making the, for producing the standard consistency of cement with varying different materials. It's a challenge. Our prestigious projects, you can see the Jayaberi, Aparna, we are supplying this to in Hyderabad. And we are approved brand in government, CPWD, NTPC, Power Grid, everywhere we are approved. So these are awards and accolades. I'll just run through it. Rewards and recognition. Our products are green products and certified products. All the products from all the plants are green certified products. So thank you so much for giving me a valuable time and presenting Shree Cement in front of you. Thank you so much.
Thanks, Mr. Uday Singh. Thanks to your team at Shree Cement for supporting us for ACECON 2025. And now we have a very interesting 3-minute video coming up from ARS Steel. Can we have the volume, please?
It's setting a bold new benchmark for net zero buildings. Not just a promise, it's now real, and it's happening. Stronger, cleaner, smarter. Build the future without the footprint.
So we create that brand, quality, which is unmatched till today.
We at ARS believe definition of green steel is not only sustainability, but ultra low emissions, high quality and ultimate transparency.
We were the first to do hard charging in South India in 2012 December.
जब मैं 8 साल का था तो मैं तीसरी क्लास पढ़ता था और मेरे को फादर ज़बरदस्ती साथ में ले जाते थे ऑफिस में जहाँ पर ट्रेडिंग हाउस था। 1978 में आई वाज इन कॉलेज, दिल्ली यूनिवर्सिटी कॉलेज में था, तो फादर एक्सपायर्ड और मैंने आके ये पूरा बिजनेस टेक ओवर किया, खुद चलाया। आई वाज जस्ट 18 साल पूरे करने थे, पर स्टिल एक बहुत जुनून था अंदर जो कि हमारे डीएनए में, हमारी फैमिली में डीएनए में है कि जो भी करना बड़ा बोल्ड तरीके से, कॉन्फिडेंस से, विदाउट फियर, टेक रिस्क। तो शुरू के 5 से 7 साल में जो हमारा बिजनेस था वो उसको हम लोगों ने प्रीमियम रिसाइकल स्टील प्रोक्योरमेंट एंड प्रोसेसिंग एज फार एज सप्लाइंग टू द इंडक्शन फर्नेस इन नॉर्थ इंडिया। एंड अगेन 1990 में एक चांस मिला कि आपको दिल्ली में है और आप लोग चेन्नई में आके प्लांट लगाना चाहते हैं। 30 साल की एज में कोई एक्सपीरियंस नहीं था, सिर्फ ट्रेडिंग का एक्सपीरियंस था, इंडस्ट्री का नहीं था। वी गॉट ए चांस इन 92 वी स्टार्टेड दिस ARS विद 3 टन की इंडक्शन फर्नेस स्टार्ट किया।
At ARS, sustainability is nothing new. We are doing this thing for decades. We use over 99% premium quality recycled steel such as CRC, Newton plate, HMS, blue turnings, coming inherently with lower embedded carbon, delivering clean, consistent quality. We use less than
0.5% sponge iron. As a result, our total emissions are just 590 kgs of CO2 per ton, which is 4 times lower than the Indian emission average and 3 times lower than the global average.
और आज ये ग्रीन स्टील की हम बात कर रहे हैं 92 और आज 33 साल हो गए। हम 33 साल से एक्चुअल में ग्रीन स्टील ही बना रहे हैं क्योंकि हम रिसाइकल प्रीमियम स्टील यूज़ करते हैं इसमें।
But we didn't stop here. We have implemented a digital, real-time, third-party online CO2 tracking tool, which is integrated with our internal data systems, so that the carbon footprint we measure is 100% automated, accurate, authentic, and audit ready.
ग्रीन स्टील रीबार एक प्रोडक्ट नहीं है, एक प्रॉमिस है जो हम लोग लेगेसी क्रिएट कर रहे हैं नेक्स्ट जनरेशन के लिए।
In financial year 26, with increased usage of renewable power, we will bring down our CO2 emissions to 300 kgs per ton or less.
भारत का जो मेक इन इंडिया सपना है उसमें एयरएस 1 मिलियन टन ग्रीन स्टील बना के एक अच्छा कंट्रीब्यूशन करेगा।
We provide ultimate transparency on quality, sustainability, and customer service.
ARS is known for and always will be known for trust and value creation through quality and transparency.
Thanks to ARS Steel for this wonderful support that we have received, and therefore, ladies and gentlemen, as we set out for the first plenary session of the day, may I tell you that ICI believes in continuous engagement with its stakeholders across the construction infrastructure sector, and therefore the next event of ICI coming up in February is the Deminar. So this Deminar is a biennial event which is going to be held at Bangalore on the 25th and 26th of February, a very unique event of its kind in the country where the demonstrations and the presentations go simultaneously side by side. These are the previous Deminar versions that has happened, and as we do that, we invite all the stakeholders of the construction industry. This year the theme is COMET. COMET stands for Construction Materials, Equipment, Technology and Systems. Therefore, we invite the sponsors, the presenters, the demonstrators, the exhibitors, and all the professionals who would like to upskill and get to know the latest in the world of construction and infrastructure. Therefore, we welcome you to Deminar. It is there available on our website, www.indianconcreteinstitute.org. Please visit there, and you've got a separate tab where you can download the entire brochure. And the venue is Niman's Convention Center, a world-class convention center, and we have the layout for the exhibition stalls as well. So we welcome you to Deminar in the month of February at Bangalore. We begin the first plenary session, which is chaired by Professor KVL Subramaniam, IIT Hyderabad. Before I request him to take over the stage, may I give you a very quick glimpse of his distinguished records that he has achieved in his career and continues to achieve. Professor KVL Subramaniam is from IIT Hyderabad. He was the Dean Planning and Development at IIT Hyderabad, and he is the main undergirder of the pillar, we can say, who oversaw the entire construction of the new campus of IIT Hyderabad. He was the founder and head of the Department of Civil Engineering at IIT Hyderabad, and before joining that institution, he was a professor and Kettle Research Fellow in the Department of Civil Engineering at the Grove School of Engineering, the City College of New York. Dr. Subramaniam obtained a BTech in Civil Engineering from the IIT Delhi and a PhD in Structural Engineering and Materials from the Northwestern University, Evanston. Dr. Subramaniam was awarded the Early Career Award from the National Science Foundation of the USA for investigating the early age changes in the cementitious materials. He also received the James Instrument Award from the American Concrete Institute in the year 1999 for his research in the world of concrete. He was elected a fellow of the American Concrete Institute in 2009, and he is an associate editor of the Journal of Materials and Civil Engineering and has served as an associate editor of the Journal of Bridge Engineering of ASE. Ladies and gentlemen, please give a big hand to Professor KVL Subramaniam. Over to you, sir.
Thank you.
Thank you, Girish. Let me get the next plenary session going. I'm sure a lot of you are waiting to hear from our distinguished speakers in the second plenary session. We've lined up some wonderful speakers for this. To start off the plenary session, I do not want to take up much time. I'd like to call on stage Professor Keijin Shi from Hunan University. A quick introduction. He's well known for his research in cement, concrete, geopolymers, and also UHPC. But what I was told yesterday is that he's been elected a fellow of the Chinese Academy of Engineering, which I'm told is a very high accolade, one of the very toughest academies to get into. Professor Shi is also the president of the Asian Concrete Federation. So we're actually fortunate to have you here. Professor Shi, the stage is all yours.
Okay, thank you, Soba, for your kind introduction, and good morning, everybody. And yeah, my name is Keijin Shi, and today I'm going to talk about what are the challenges during the design and applications of UHPC. And I'll give you some introduction where I'm from. And okay, well, actually here, Changsha, and that's where I'm from, and Beijing and Guangzhou is here. So it's about 2 hours of high-speed tram from Guangzhou, and then 5 hours of high-speed tram to Beijing. And well, our Hunan University was founded in 1976 AD. So next year we are going to celebrate 2000 something, no, 150th anniversary. So we have a 30th college department and have about 36,000 students. Well, based on the US news, and Hunan University ranks number 11th in China and about number 119 worldwide. And well, actually, our civil engineering program ranks number 13 in the worldwide, and also number 16 in the University for Civil Engineering, yeah. And so that. Well, as the president of Asia Concrete Federation, and also, have given an introduction to the ICI board yesterday, and I also would like to give a brief introduction about ACF. And well, if we look at those basic numbers, the Asia Pacific region has about 1/3 of the world's land, 61% of population, and 28% of GDP, but we produce and consume about 81% of cement. And well, actually this bottom line from the Constitution, and that was written 20 years ago, said although Asian countries have different cultural, technical, and environmental backgrounds, but we share the same roots, which are very different from Western Hemisphere. And so, especially during past 30, 40 years, Asian countries have been developing very fast, and we should, work together and share information and learn from each other. And I think that's the foundation for the setting up of the Asian ACF. Well, before ACF was formally established, actually JCI, KCI, and ACI had 3 Asia Concrete Forum, and then in 2004, and they organized the first ACF International Conference in Chiang Mai, and they decided to officially set up an Asia Concrete Federation. So since its beginning, what JCI, KCI, JCI, KCI, JCI, KCI, was the president of the federation until 2023. I became the president, and well, also you can see usually, and JCI got 2 terms and KCI got 1 term. Well, actually this year is my first year of the 2nd term. And well, at the moment we have 13 representative members, and including in ICI, and well, many other countries are also planning to join. Well, before the objective of ACF was to promote the understanding of a concrete structure because ACF was also evolved from Asian Concrete Model Code Committee. And so after I became the president with discussion with all the EC members, we decided to change the objective to promote the understanding and applications of sustainable concrete materials and structure, and then to provide a service to the Asian societies. And more specifically, at the moment, we mainly focus on the development and the promotion of guidelines, recommendation, and methods related to emerging concrete materials, structure, technology, and processes, because, as I said, during past 30, 40 years, a lot of construction happened, and also a lot of new technology and products have been developed. I think we should try to really standardize them and promote them for other countries to share with other countries. Because for many small countries, it's very difficult for them own to develop some larger standard or construction practices. And so during past 2 years, and we have approved 18 technical committees, and which include artificial intelligence for concrete industry, and nano-engineered composite material, and CO2 utilization, recycled concrete structure, and etc. And also, we will continue the Asian Concrete Model Code Technical Committee. So ACF now not just has technical committees, but we are continue to update the Asian Concrete Model Code. And actually in July of this year, we had a 20th anniversary celebration workshop held in Changsha, and you can see 13 out of 18 technical committee had their technical committee meetings there, and you can see, many technical committees had a lot of members attended the meeting, and so it was very good. And ACF also has one symposium and one conference in November, and we had a 5th symposium in Singapore, and the next year in October, we will have 11th international conference in Taiwan. Well, actually, if you look at the first international symposium was held in Calcutta, which was also combined with ACECON. Right? I think Sulu was there, and I was also there, and for that event. And so last year we had an international conference in Mongolia, and it's their first time to organize the international conferences there in civil engineering. And so you can see I invited Tony Nani, the ACI president, also Ryland president Nelly DeBelli, and also FIB president Stephen Foster to give the keynote presentation there. And we also signed the international partnership agreement with ACI and with Ryland. And this is ACF symposium I had 2 years ago in China, and we also organize 2 webinars per year, and this actually is an activity during the 20th anniversary, and Maria Younger, as our president, original plan to come, but due to political reason, she couldn't, but send us a congratulatory message, and we had a FIB president, and also had a representative from Raleigh, and we had, I think, 9 representatives out of 13 representative member countries or regions attended this event. And we also have launched a lot of honors and awards, including ACI Fellow, Distinguished Research Award, Young Research Award, Lifetime Achievements, Excellent Service, Honor Member, etc. So, Yeah, and we also have a ACF journal, and well, it was launched in 2015. It was doing not well. So from this year, I also took over the editing chief, position for this journal. And well, if you have a chance, please look at, take time to look at the Asian Country Federation website, and we have spent 1 year to develop this website. You can basically register for your membership and get your receipt invoice, and also submit your papers through the website. And yes, please join ACF, and especially I would like strongly encourage technical people here to launch, to chair some technical committees and share your knowledge. And of course, you can also learn from other countries and other people, as well. And at the moment, the individual membership fee is very low, only $60 per year. And okay, now let me back to the technical aspect. And well, this is the outline of my introduction, and well, actually, name is also here. We co-authored a book, Ultra High Performance Concrete. It was published at CRC Prize last year, and if you are interested, I think you can buy it from the internet. Well, if you look at the history, and initially, and in the early 80s, and some scientists in UK published a work on, called MDF cement. I still remember when I was a student, it was also become very hot, in China, because that material gives very high flexural strength. But on the other hand, it has to use a lot of organic additive, and which is not water resistant. And I think later on also, until 1993, and some French scientists published work on reactive powder concrete called RPC, and at the same time they gave the name called ultra high performance concrete, or UHPC. Now when you look at the publications, probably you seldom see RPC, but now people always use UHPC. And recently also some work continue to try to improve the toughness of the material, so they call the ultra high performance and also ultra toughness concrete. And also come to definition, and originally for RPC, they propose a compressive strength of 180 megapascal, and but on the other hand, come to structure design and application, and once the strength is over 120 megapascal, the determining factor is not a strength, but a stability. So after many, research and experiment, and the structure people think, 120 megapascal should be enough for structure application. So now, like ASTM and also Asia Concrete Federation define a minimum strength of 120 megapascal, and for tensile strengths, some standard require 5 megapascal, and some standard requires 8 megapascal. And also, as for the corrosion migration coefficient, and because it contains steel, so we tested the matrix. We found, the matrix actually gives the corrosion migration coefficient of less than 10 minus 14 meter per second. And we all know, concrete is very porous material, and basically, all those 4 equations are often used to describe the relationship between porosity and the strength. But on the other hand, if the porosity is between 10 to 35%, all those 4 equations can describe the relationship very well. But on the other hand, once the porosity less than 10 or larger than 35%, you have to decide, which equation to use. And that's actually first theory proposed for the design of UHPC, or closing parking, or people use modified Anderson equation to calculate the composition, and so basically you can see we got a cement slag silica film, and so through this equation we can calculate the targeted mixture proportions. Well, but on the other hand, when we mix concrete, we also have to use cement aggregators and water. And so in order to reach high strength or to reach low porosity, so we also have to use superplasticize, so to reduce water cement ratio from even high performance concrete for like a 0.3, 0.4 down to 0.15 or 0.2 like this. And then the other thing is the modified Anderson equation was based on the particle size of dry raw material. But on the other hand, in concrete mixture, we should consider the closer packing of wet particles. So here, in order to reduce the porosity, we should consider closer packed particles and lowest water cement ratio or water bind ratio. We also have to ensure it has adequate rheological properties. So in that way, we can do good construction. And also, we have to control the autogenous shrinkage, because once the water cement ratio is down to 0.2%, 0.2, the autogenous shrinkage will be very, very high. And finally, of course, we have to choose proper fiber to get the toughness we desire. And if we compare the characteristic of UHPC with conventional concrete and the final column you can see the compressive strength ratio is about 2 to 6, but on the other hand, for the elastic modulus ratio, is only about 1.5 to 2. So, the increase difference between the strength and the elastic modulus are quite different. And so as I said, modified Anderson equation calculation was based on the uniform distribution of solid particles, and but on the other hand, then we found in reality, especially for the main component, silica film, and our silica film has 3 states. One is original bulk silica film. The other type is medium densified and also highly densified, because if we do not densify it, it's very bulky and it's very difficult for packing, transportation, and storage. So actually, if we look at this one, and so this is the particle size distribution of silica film in alcohol solution with ultrasonic agitation. And this is cement particle size distribution. But on the other hand, this is rough, bulky silica film even in 1% of PC solution. You could see this is a particle size is 12.2 micrometer instead of 0.6 micrometer. And for highly densified silica film, the D50 is about 117 micrometer. And okay, so in laboratory, we use the different mixer, try to disperse the silica film, but on the other hand, based on all these results here, you can see, doesn't matter we use different mixer and with the PC solution and also even steel fiber, and also even with coarse aggregator, all this mixing procedure do not really change the dispersion of silica film. And so in this way, and so basically, these solid particles are not really uniformed, distributed, or dispersed in UHPC mixture. And so if we use the particle size distribution in different conditions, and then use modified Anderson equation to do calculation. And so then you will see, actually here, this is target curve, and which for this mixture, this is target cable, which are very, very different from the calculation of solid particles in dry state. And well, so then also different states, different form of silica film, they also have very different effects on the facial properties. This is original bulk silica film, this is medium densified, this is highly densified. And well, you can see even after 3 days, and all those silica films actually replacement or addition, they decrease strength. But on the other hand, after 28 days, and they increase strength. But on the other hand, for the highly densified silica film, they do not increase strength much. And well, but the bulk silica film shows the best results here. And well, this abrasion resistance and this control, and so this highly densified silica film, you can see, it does not also reduce much, and but for the medium densified and above silica film, of course, they show the best results. This is the section of polished section, and well, on the other hand, well, in the microscope, and we could see for the highly densified silica film, and even for the medium densified silica film, and also bulk silica film, we could see a lot of agglomerated particles. I think, a lot of previous research have indicated those agglomerated silica film even could cause alkali silica reaction expansion or even cracking of concrete. And well, after 3 days, you can still see some big particles, and after 28 days, and well, so even for highly densified silica film, and even at 28 days, we still could see, 200 micrometer size agglomerate silica film particles. So, yeah, so in that way, we have to be very careful, use this equation. But on the other hand, we propose a factory design method and use this design method. Okay, if we have 4 ingredients, fly ash, silica film, slag, cement, and so use this method, we could establish the mathematical relationship between the components and the quantitative property or even the microstructure parameters. So if it's a quaternary system, we could plot the counter plan, but for the counter plan, it's not easy to visually observe. And so, well, but on the other hand, we also did some laboratory experiment to show how it works. And so then, if we fix one component, then we got a ternary system. And so we can see here, we got the correlation for the composition and strength, porosity, calcium hydroxide content, even for heat of hydration. So then we plot the counter curve, it's ternary, and so you can obviously see here, especially for 56-day strength, this composition, give you the highest strength. And well, for this calcium hydroxide content, it varies, with the composition. But on the other hand, this approach really gives us a very accurate determination of a composition and the property as well. And one second issue is high viscosity, because UHPC uses very low water-to-band ratio and also high, silica film content. So also, high PCE dosage. So in that way, it's very viscous. So initially, we started from, PCE. Okay. So this is normal PCE, and this is super, PCE, and so actually based on the structure, we try to add some, the groups that can really enhance the adsorption capacity of a PCE. And well, actually, this is a structure we designed, and so here we add this group here and also this group here to enhance its adsorption capacity onto both particle and silica film particles. And so you can see, and here this can really enhance the flowability of the mixture. And well, if we look at the mechanism, so basically, because we added some, adsorption group here, so you can see the main bond of PCE adsorb onto cement or silica film particles, very strongly, and so that's how it works. And also during our experiment, we found that when we change the silica film content, and it also changes the viscosity and the yield stress very significantly. But on the other hand, with 15% silica film, it helps the distribution and the alignment of silica film very well. And that's it. Okay, the other thing is autogenous shrinkage, and well, during the early hydration for cement, and especially for UHPC, because water cement ratio is very low, and so this hydration happens very quickly, sucks a lot of water, and so inside of the concrete or paste, it has a negative pressure, it will suck the paste, and then cause the very large shrinkage. Well, in the literature, people before define autogenous shrinkage from the initial setting or even final setting. But on the other hand, if we look at the UHPC, you can see here, this is a conventional or high performance concrete with 0.4 water cement ratio. The autogenous shrinkage is almost zero. But on the other hand, for UHPC with a 0.18 water binder ratio, the autogenous shrinkage reaches about 3,000 microstrand. It's huge, right? Like from the effective water binder ratio on the autogenous shrinkage, you can see if we decrease the water binder ratio from 0.14 to 0.2, and or even decrease from 0.22 down to 0.14, it's almost, increase autogenous shrinkage to about 4,000 microstrand. It's very huge, and it will cause that large shrink or deformation of the precast product. So based on all those mechanisms, we classified the factors into 5 categories. First, how to control the hydration, and second is internal restraint, and the third is reduction for surface tension, and then compensation for a shrinkage by expansion, and finally is internal curing. And what you can see, if we use more cement, slag or fly here, slag to replace cement, it decreases actually autogenous shrinkage very significantly, and for the, that one should be the fly ash, it shows, even better effects. And we have to pay attention more on actually rust husk ash. You can see, it even gives a negative autogenous shrinkage, because rust husk ash has very porous structure. It has internal curing effects here. And also some, different PCE, and some of them retard the hydration and also reduce. And of course, the PCE dosage also a factor, and the temperature and the same. And here the work we did were mainly focused on SAP and SRA. And so you can see, especially, this is show the separate effect. This is reference. This is with 0.3 SAP and 0.6 SAP and SI. SI actually give better results than SAP. But on the other hand, here we combined SAP and SRA. This one actually, here 0.3% SAP plus 2% shrinkage reduce engine. It reduce autogenous shrinkage from 3,300 down to about 600, and so it could decrease almost 70-80% of autogenous shrinkage here. And the other work is the porous lightweight aggregate. And so you can see here, this is effect on autogenous shrinkage. It decreases from 2000 psi up microstrand down to about 400. It also decreases a lot. And especially if we look at the strands, you can see if we replace even up to 20%, it does not really decrease the strands significantly. So this is a benefit for lightweight aggregate. But on the other hand, we have to be very careful about porosity and also pore size, because if it's too big pores and too much porosity, and it will have some negative effects here. And so finally, okay, about module for elasticity here. Well, my student collected hundreds of data from the literature, and you can see, well, if over strength over 100 megapascal, they show very different trend. And well, so then if we look at the microstructure level, the hardness cement paste or UHPC consists of quartz powder, cement clinker, low density, high density, CSH steel fiber, and this actually this indentation modulus. And so we collect those information from the literature and summarize them here. Okay, for low density CSH basically has a modulus of about 20 GPa, and high density CSH about 30 GPa. And so based on this results, we regress the equation, and for low density CSH is related to water to cement ratio, silica film to cement ratio as well. And so then we propose a 3-level model, and from micro and meso and macro level, and based on Tori Tanaka model theory, and so then we come up with a relationship between the modulus elasticity and the composition and the property of these components. And so based on the cement paste, and we got the results from the literature, and so you can see the difference between calculated and measured results are very, very, almost zero. And so then we also calculate the results for the mortar, and the difference also very small, and also some results for UHPC with cost aggregator. And so here finally, based on all those results, we get this equation between the modulus of elasticity and water band ratio and the composition of the material. So in that way, we could design the modulus of elasticity of for UHPC with whatever your targets want. Okay, so this is actually the experimental results we verified in the lab. You can see the difference between the predicted results and test results is less than 2%. Okay, well, we also did some seawater and UHPC, and basically finally shows even after 3 years, we put a steel bar in seawater, sea sand, UHPC, it does not show any closing indication. So, so my colleagues in bridge and structure engineering, they have using UHPC for come up with lots of new different structure design, and for a variety of bridge and structure applications. Even Thang Long Bridge in Vietnam, they learn UHPC design from us, and so it worked very well. Before, it can carry only like 10,000 trucks per day. Now, it can carry 100,000 trucks through per day, so increase the capacity 10 times. So anyway, so UHPC is a very nice material, but on the other hand, in order to get good quality performance, we have to be very careful about the composition design, and also, especially the fiber, and also, if you want to get high modulus for elasticity, and you have to pay much more attention about cost aggregates here. Okay, this is a journal, and I launched it 2012. I received a lot of manuscripts submission from India, and yeah. Also, we are going to have the second ACI for CO2 mineralization conference, actually, in Lisbon, Portugal. Okay. See, ACF now become very international. Well, actually, our committee members also from US and Europe as well. And so you are welcome to, for the conference. Finally, I would like to thank the financial support from the Ministry of Science and Technology of China and to my students for their great efforts. So usually I cook for them once a year, and 18 dishes per table, and 4 tables. Yeah. Okay, thank you.
Thank you, Professor Shi. Any questions on his cooking prowess? Any recipes they made?
Okay.
Okay. Yeah, I guess we do have technical questions. A lot of interest in UHPC in India.
Yeah.
So, Mr. Hegde. Can someone check the mic, please?
Hello. A very nice presentation. I can see a lot of research has been done, and also I can see that 200 bridges have been constructed in China, what I can see from your presentation.
Yeah.
The last...
Well, actually, more than 200, even from our university only.
Oh, yeah. More
Okay.
than 200.
There are many.
Fantastic. That's very good. I'm really, interested in your last slide, in the conclusion slide,
okay,
where you have mentioned the replacement of the steel fibers will help in the energy dissipation. Like basically the carbon dioxide emission you're talking about, right?
Yeah.
That is. Is there any research going on for replacing the steel fiber in the UHPC in China with the other fibers?
Yes, well, actually, there are lots of research still going on in China, and as I said, even in seawater, sea sand, concrete, and UHPC, the rebar did not show any corrosion indication after 3 years. Well, actually, now one of my PhD is working on the critical oxygen and moisture content within UHPC for corrosion to initiate, because UHPC is very dense, and so the moisture or relative humidity inside and also the oxygen content inside is very, very low. So it's impossible for steel fiber or even rebar inside to initiate corrosion.
No, the question is not that. You see, the thing is, are you doing any research for replacement of the steel fiber with, say, for example, glass fibers or carbon fibers?
Yes.
In the UHPC?
Well, yes, and especially for decorative panel. Okay, I did not. Well, we have done lots of work on this, and for decorative panels, it's also being very widely used in China now. And for those panels, they use organic or even carbon fibers, because for steel fiber, you get always some exposure on the surface, and this surface could start to have some rusty points. So, yes.
Okay, thank you. Just one more question.
Can I ask one
question?
Actually, I am from National Council for Cement and Building Material, and we have also worked a lot on the UHPC. And we, at the Bureau of Indian Standard, we are about to draft a guideline for concrete mix proportioning of UHPC.
Yeah.
So my question is, most of the time it is the factory-made environment this product can be used. And for that, the curing regime is very, very important.
Yeah.
For the development of a strength and other mechanical property. But you have not touched the curing regime particularly in this UHPC area. So what is your opinion on this curing regime for the UHPC?
Well, so for, different application, yes, for the panel applications, decorative panels, and basically they use, high quality white cement. And, but on the other hand, yes, for HPC, you have to choose right raw materials to get good performance. And I think, especially for HPC, the raw materials are more critical, are more sensitive than, conventional high-performance concrete. Yeah.
Okay, just one quick question. Yes, please.
Okay.
Excellent presentation. Just in this ultra high performance concrete, just 2-3 main challenges that you're facing to make the concrete durable, and how we can reduce the carbon footprint.
Yes. Well, if you calculate the carbon footprint based on per cubic meters of concrete, it's higher. But on the other hand, if you calculate or consider from life cycle analysis, it could be much lower. And first, because of the high strength and toughness, the size of the element will be, greatly reduced. That's one aspect. The other thing, that's why, so many projects, especially those bridges in China, now all switch to HPC, because the bridge deck system give much longer service of fatigue resistance. And my colleague did some testing with a composite bridge deck of UHPC and steel. You know what? After certain fatigue testing, the steel broke. The concrete is still good. So
Durability part.
yes,
Durability part. Durability.
during fatigue testing, bending fatigue testing, and after certain number, and the steel plate broken, and the concrete is still in good shape. Yeah. So initially they said it is a bridge will never broke, or the bridge deck will never deteriorate. But now they said, during your 120 years of service life, you do not need to replace or, repair your bridge deck. So, but for those conventional bridges, usually after 5, 8, or 10 years, right, you have to replace the concrete layer. That was 20 centimeter. But on the other hand, for UHPC bridge deck, UHPC thickness is only 5 centimeter thick. Yeah, the first bridge in China actually used 4.5. The bridge deck in Hanoi, and used 6 centimeter thick instead of a conventional 20 centimeter thickness. Yeah.
Thank you.
Okay.
Thank you, Professor Shi.
Okay, yeah, okay.
Thank you. So, to set the ball rolling, I think I'd like to invite the next plenary speaker, Professor Bhattacharjee. Professor Bhattacharjee is a professor at IIT Delhi. He has a long career, and his research is focused primarily in corrosion of rebar in concrete, microstructure modeling. He's done a lot of work on porosity measurement with MIP. He's a member of several boards and academies. He's on the editorial board of the Magazine of Concrete Research, and of course a life member of the Indian Concrete Institute. So with that, Professor Bhattacharjee, the floor is yours.
कॉलर माइक जरा कॉलर माइक ठीक है चलो कोई बात नहीं ठीक है वो ऐसे ही चल जाएगा गुड मॉर्निंग
Okay, so thank you very much, ICI Hyderabad Center for calling me here. Am I audible there? You can take this mic. I'm not a singer or standing comedian. I can't do that. If you have a collar mic, fine. But am I audible? I'll do that, but then my mobility reduces down. I'll try to do that. Huh? Collar mic is a better one. Anyway, I'll try to do that. If you have a collar mic, fine. Otherwise, not a problem. I'll manage it. Don't worry. So let's see. So this is what this is my photograph, not the other one. And I'm going to talk on something like this. My experiences, actually, part of it. You know, India is slightly a different country than climatically. Then many of the, obviously it is tropical first of all, and then we have Himalayas. So when it comes to tropical countries, there are other tropical countries, but Himalayas makes it different. So our climatic situation is different. Oh, ठीक है, thank you. Pockets. डाल दीजिए. ठीक है, okay. So if you look at climatic zones of India, that's what it looks like. I mean, this comes from General Wright. First time, of course, it came from energy efficient building design related. Köppen's classification, and they modified, and this has been acceptable. Indian code has this. And the red one, as you can see here, red one that you can see here is called hot, dry desert climate, along the line of Sahara and all that. You know, latitude-wise. Why is changing automatically? Please don't change, I am changing it. Do not do that. I'll do it. Don't change it automatically. No, I am not changing. Okay, let's see. So, this zone is called warm humid climate, lot of rainfall, longer period. This is composite monsoon, and the top one is cold, dry, and that's what it is. And if you see the rainfall, there's a match, of course. These are the extreme high rainfall areas. The cold desert and the hot desert, they are dry, and coastal area, extreme rainfall. Now, why I am talking of that? Durability of concrete is related to moisture. You have any reaction occurring, because it's a chemical reaction, you know, that happens only in presence of moisture. And precipitation zone by hydrologists, that also has a role. Dry zone, intermediate zone to wet zone and all that. All this put together, the climate has a role in performance of constructed structures as well. So some cases I am going to talk about. First one is some early defects. It's a recent one, but many cases I have come across where early defects were because of more climate, but then we couldn't possibly look into this climate properly, particularly precast elements. So this is one, a double T-beam slab elements for track systems. Railway track system, 180 km/h, and they used M55 grade of concrete, membrane curing, sprayed curing compound. I was not very sure what it was because it was not given to me. And the thickness of the slab, as you can see, is 165 mm. And this beam is, these two beams, they are called rail guards there. These are the, you know, where the track will come finally. These are all precast elements and 203 mm beam. Then they encountered, after they lifted it, put it onto the stackyard for some period of time, they encountered cracks spacing at 300 mm. This is where these cracked beams, these beams showed cracks, and pattern I'll show you a little bit wide. So these were all cast in composite monsoon climate of northern India. I am not mentioning the place, then you will automatically know which project it is. I don't want to tell them because that's not the right thing to do for my client, but it has been rectified anyway. So in dry summer, May, June, in May, June, Delhi and NCR and the composite monsoon climate area, you have humidity 10 to 40%. And temperature 40. The cracks are like this. Cracks came at 300 mm spacing at the stack yard after some time. So the question was, what is the cause of those cracks? And cracks were large at the top. They were relatively, they were going down thin at the bottom and didn't penetrate through and through. No, not necessarily. Strength of the concrete was not a problem. All the, the tests they have done, NDTs, it was found that it was all okay. So the general feeling amongst the structural engineering people was that, structural designer and all that lifting it must have cracked. And they did not notice it, and therefore when it went to the stack, the cracks were then it became visible. So this was actually initially demolding and then lifting. So if you see this is available in almost all books, the typical types of cracks. I started looking at that, what is the possibility? Obviously it can't be plastic settlement cracks because it appeared much later. Normally plastic settlement cracks come within 48 hours. This cracks. These are plastic settlement cracks. I had the chance to see at least one of them. Plastic shrinkage cracks, DEF, they come random like this. So they couldn't be this. Obviously there is no question of rebar corrosion coming in. Alkali aggregate reaction was not a possibility. That's called map cracking. That's not there. Thermal normally occurs in massive structure where heat of hydration is the cause. So only thing left was drying shrinkage. Crazing, who cares about them? They are very fine. And this is what it is. So then I had to really verify this, and otherwise people will not get convinced. They were trying to put in that while you were lifting, the cracks were coming. But then they did not see it, they saw it later. So this is demolding, just release it with a 4 hooks and things like that. There was no issue of crack at that point of time. So demolding is basically detachment. Then this was the lifting procedure. They were lifting with a tackle and actual stress was coming somewhere there, mainly. So lifting and shifting, possible bending and cracks, I thought would have looked like this. These cracks were not like that. They were in the beam. So this was. Then I thought that let's calculate out the shrinkage, and this formula I have used. Somebody yesterday was just talking to me. Many cases, because I have come across such cases earlier also, particularly precast elements. And this is an empirical formula, obviously. There are different coefficients. K1 is the number of days of conventional moist curing, 1 for 7 days, less it will be, higher shrinkage. And this is ultimate shrinkage. K2 depends upon relative humidity, K3 depends upon volume to surface area ratio. Where surface area is large, the evaporation rate is higher. Therefore, the cracks start to increase. There is details available in, of course, any book, Neville and Brooke, Professor P. Kumar Mehta, and all those books that would be available. So fight aggregate to coarse aggregate ratio, and then the cement content. Obviously, they were using OPC 53 because they wanted to get strength RD. And air content, which is not an issue in India, of course. Then the shrinkage at any point of time can be calculated using this equation. S infinity stands for ultimate shrinkage. This is for moist curing. For steam curing, this 35 replaces by 55. So 40% in our location. Curing, they did spray curing. First, just after, first they will do it before demolding, they will do one spray, leave it for some time. Once it is shifted to stack, again they will spray the curing compound again, membrane curing or whatever it is. So this is what it is. So in hot dry condition, this essentially this curing strain, then we calculated it out. Our humidity was 10 to 40% is relative humidity during those period of time in the northern Indian. scenario, the composite monsoon climate. Hot dry desert in Jodhpur, Jaisalmer, it will be even worse. But then, this is simply one for our case. The volume to surface area ratio we did calculate out, and slump is also related to slump K4, and we did calculate out according to aggregate cement was 439 kg per meter cube, and when we did calculate out the ultimate shrinkage, obviously the air content is not there, we don't use air entering agent. It came out to be 857.2 microstrains, and then shrinkage at a time of T days measured from this is the formula, we calculated out the shrinkage strains that is likely to come. And I believe that it was coming 300 microstrains or something like that based on those calculations. With the curing, we took one because, not 300, sorry, it was coming first initially 1.01 microstrain, epsilon, something like that it was coming anyway for curing this condition one spray. So we are saying that it is not even equivalent to 7 days curing. Strength was not a problem. If their cube strength and otherwise it was fine, then you use this formula of Indian Standard Code modulus of elasticity is that that's at 28 days age, and that again same formula, SCI formula gives me tensile modulus of elasticity at any age. So at our age we started calculating it out, we did calculate 1 hour after exposure, we find this, and then shrinkage of the derailment guard beam between the, between those, there are some openings, 2 openings as you would have seen, there are 2 openings actually. So there are the derailment guard beam and the slab, and there are 2 openings. So shrinkage in the whole system, and between the, this openings, because in between the openings this will also shrink. So we just hypothesized that this is perhaps due to this, and then did the calculation. Finally, what we found out, it was perhaps the curing compound they used was not good. Perhaps it's an wax-based compound. There are others acrylic-based. That also may not be sufficient here because of the 40% relative humidity and all that. So this is the scenario. This we try to model it first for visualization. These are the openings. These are the openings. Everywhere it is shrinking, and we did several case lifting load plus shrinkage, because shrinkage will be there right from the beginning. That's what we are assuming. There are no other loads, shifting, transporting load, various kind of load combination we looked into, and when we simulated the shrinkage only in ANSYS, I mean, it was my student who did it. These are the maximum stresses where the cracks were there. So we could confirm that it is shrinkage. I mean, which I had the notion because I had similar cases handled earlier, and it shows that. So this is what it is. Obviously, the designers were not very happy. They said, we have used this shrinkage elsewhere in the world. Well, you might have used it elsewhere in the world, but somewhere in the northern India, where it is composite monsoon climate, and you are casting in May, June, when rainfall has not started, monsoon has not started, then you have to really be careful about this. So this is what the first case that I talked about, wanted to talk about. There are several other simulations we did, but I don't want to show them for the paucity of time, of course. The full case is not this one only. So one thing one must remember, that in Indian scenario of that temperature, if it is 45-degree temperature and it is exposed outside, you are stacking it outside, solar radiation will directly come onto it. If the absorption coefficient is alpha, H0 is convective heat transfer, or what you call surface conductance, effectively another 15 degree will come into picture. So top temperature was 60 when you are actually, you exposed it, while perhaps, they would have been shaded or something they would have done, things would have been better. Fortunately, these cracks, I thought that they were not very wide. So they will possibly, autogeneous healing would occur because hydration has not occurred. So I asked them to do spray water for next 7 days and measure continuously the crack width. It did work. They closed down because the unhydrated cement, they use so much of cement. If you see, and the strength of, the planned for 55 grade. So obviously, so when you spray water, unhydrated cement actually blocks those cracks which are relatively small. But being a very important project, they didn't want to even take that crack as well. So that's what the scenario. Another one of the similar kind, same case, that was wax backed as told. Curing compound, precast tunnel lining. That was few years earlier, some beginning of this millennium. Shrinkage cracks again. Again we analyzed everything, strength was fine, everything was fine. And I'm not going to go into calculations and things like that, but we used, this is what it looked like. So we did grid mapping, did a thorough exercise, again an important project. And you can see the blue lines, they are thinner cracks, red lines, they are thicker cracks. Red lines, they are thicker cracks, I think I have something like that. Red lines, they are thicker cracks. And then we found out estimated the crack depth also through ultrasonic pulse. They were not through and through most of the cases. But then here they didn't want to take any risk because it was in a potential place where there might be even chloride. Underground, and groundwater is contaminated. And although they calculated the cover with the wrong design, because wetting drying would be the situation there, but they used it as it is submerged all the time. But doesn't matter, that's separate. So we put a coating. I don't remember exactly. Zentrifix was one of those options, because one of the constructor people were also from Europe, so including Indian companies, so the consortium. So, but that's what it is. We diagnose this also as the problem. Second type of case one can find is rather I came across was actually a underpass. Again in composite monsoon climate. This is traffic is like that. There is an underpass, and there are some structural problems. That time we were not involved, and then they strengthen it they put in some additional column and the beam. Initially the span was larger, they reduced out the span because there were some cracks. And I don't know exactly the story about it, and it was the procedurally went all right. These are the earth support around the abutment. And again the effective temperature, environmental temperature as I call it, would be something like absorption is 1 minus, so basically it would be something of this order, same solar temperature, calculate, it will come out to be with absorption of, I think I've not 1 minus A, it should be A itself, absorption, I think it's wrongly written. This is wrongly written, this should be A. This reflection, 1 minus R it should have been, and this A is 0.84, so A absorption alpha divided by H naught, it turns out to be about 55 degrees centigrade at the top. But this is a thick section. And this also the crack came after several months. Box culvert, 600 mm thick slab. So that's what it is. After they repaired, the cracks again came. And then what they did, they put carbon fiber reinforced. So diurnal variation, daily variation, normal was 14 to 15 degree. Plus another additional because of the radiation would come to 25 to 26 degree at the top. So top temperature early in the morning to the peak time is much difference, summer months. And the average coefficient of thermal expansion of concrete and steel we know is fine because it's normally 4 to 20 depending upon moisture content, take around 12. And then thermal strain cracks were there, strain reversals were happening 26 degree. To 14, so there are around 26 degrees temperature differential can occur. Bottom was nearly constant, it couldn't be much because there is ventilation available, movement of air is available, and it's far away, it doesn't receive radiation. So there is a difference, stress reversal. So if I look at it with the earth here, if the top temperature is high, daytime it will be something like this. Potential locations of crack they found out, were observed, and night time the blue colored, that's what the temperature would be. So again the cracks that was there coming, I think, did I miss the crack? no, it's not here. So the crack that was there matched with our ideas. This is the kind of cracks they got cracks down below also, and they put carbon fiber CFRP strips. Now, one thing about carbon fiber is, Professor Bantia is here, is fiber concrete, and he'll be knowing more about it, or maybe he'll clear my doubt. What I observed was, I'll come back to the slides later on. Thermal coefficient of expansion, I'll come back to this. It has got a negative coefficient of expansion along the fiber directions, the fiber themselves. So therefore, it will actually restrain. Other things are trying to expand, it has got negative, right? And then this is what we found. The cracks were there between the strips they have put in, right? The new cracks came, and that time we came and we came forward and looked into it, and we diagnosed it as possibly a thermal problem. Well, this was it, and then we modeled it, as you normally do these days. It's pretty easy, and we modeled it. The model showed possible location of cracks, which matches with whatever we have found out. And as if you actually reduce down the spacing, then the cracks would go away. I mean, will not come. That kind of thing. Complete analysis was that. This is one of the. My point is, actually, when we are constructing things in our climate, one should be cautious about the climatic scenario very much, because this is not same, particularly with subtropical climate, it simply doesn't match. So this is another case that I wanted to highlight. Now, next case again is climate related, but these were much more practical problem, and this is also what I am going to talk about is practical problem, but that trying to solve it somewhat through some of our research students' research work. Now, this was a set of buildings in Caribbean sea coast, 1 kilometer away from sea, and we choose this for our project because I thought that the aerosol, chloride aerosol, actually travels with wind between 5 to 10 kilometers. So I wanted to know whether there's a kind of aerosol is causing the corrosion in somewhere in the Arabian coast, the particular set of buildings I was talking about. Somewhere 19 years, somewhere 27, somewhere 11 years old. We selected all those buildings deliberately so that we can actually study what is the chloride scenario. So sea facing, opposite sea facing, we selected those surface, measured the chloride. A lot of chloride concentration was measured, and I was expecting the chloride profile will vary high at the surface to low inside, because it was close to particularly the one which is facing the sea. To my surprise, it was not the case always. Many cases, it was other way around, which means that chloride would have come right from the beginning, from somewhere else, not necessarily from the sea coast. There are many of them, but not, some of them were showing, of course, decreasing chloride values, both acid soluble and water soluble, what you call free chloride. Red colored one is the threshold chloride, free chloride, that we took from literature. Actually, literature also it varies from low level to a high level, there is a mean level. So generally I have been using 0.25% of chloride by mass of concrete, because that's what you can measure. And actually many cases, I have only picked up those cases where I am not finding that there is a kind of chloride going from outside to inside. So this is what is. Some cases, yes, it was like this. Many cases it was not like this. Some cases it was showing that it perhaps comes from outside. So I was confused. But didn't quite finish this project because the gentleman, the master's project student who was working, he passed away in, during COVID. But gave me a solid set of data. And, but beyond that we couldn't analyze further because we wanted to do a little bit more, but anyway. So this is what it is, one case. So what I am trying to point out is this Indian scenario not only in other places where I think over right from 1990 onwards, when I was kind of initiated into some consultancy work with my senior professor colleague, Professor K.K. Nair, who used to teach me RC design, taught both of us RC design, and I still remember his classes, Hogdested block and all. Involved me in some, out of majority of the thing I have handled is corrosion, initiated, problem in buildings in India. I mean, northern India, some in eastern India, and few possibly in the central Indian, but in almost all climates. But the point is that they were almost all of them were away from seashore, continental India. Rajasthan High Court now facing problem. A number of buildings have been demolished in Delhi and NCR of chlorides coming from India. So something wrong with us as academician, practicing people, that we possibly don't check our chloride during the time of construction. We take it for granted. Groundwater people have been using, and this is, I'm not sure what, where for many places groundwater, sometimes the sand. Unwashed Badarpur sand in Delhi was a major problem, because anywhere in hot arid climate, surface rainfall is not much. So chloride do not get washed away as you go down below into the groundwater. Sodium chloride is abundant in the universe, I mean earth basically, not universe. So this is what it is. I asked them to test all those, free chloride, relative moisture, etc., etc. They did, and this is a free chloride content present. This is a height-wise, 35-story building, several of them, and the chloride content you can see somewhere it goes to threshold chloride, some of them much higher than threshold chloride level that one can use, free chloride level, water soluble chloride. Histogram wise you can see many of them are not, but many of them are chloride. So this is this is what it is, class intervals if you see, because this is a histogram plot for this class interval. Class interval 2 onwards, somewhere from the 2 onwards, there are a number of them where chloride was much higher than what is acceptable, which can initiate corrosion. That means right through the first day you have depassivated the steel. Right from the first day you have depassivated, and this is the case in India very much. And I always highlight this whenever I talk, especially on durability. This is one of the problems we should be answering. We cannot leave it aside. Bridges, it doesn't happen. Bridges people are much more cautious, and it's all civil engineers' job, not architect, civil engineer, all complexities, civil mechanical, electromechanical, all this doesn't come in, but in this it comes in. Now fortunately for this particular case, they already did repair. They already did repair. After that they involved, they already called some consultant, he did structural design, all that they do. Some companies they called, they did repair, patch repair. And the area repaired was available to me. I said, can you give me the area repaired? So there are a number of towers. Some towers have obviously basement at very high. Some towers had very high area already repaired. That means they were most affected. And I had the chloride result. So those towers, the nomenclature is slightly different because they too use different nomenclatures. If you see the tower number 1, there were 1 out of 31 samples, 30 samples I ensured that you do statistically right. So everywhere, every building, every tower we measured 30 chlorides randomly, and it was only 1 out of 31 was above threshold. So probability of depassivation at that point of time, I call it 0.03, and this is how I calculated, and these are the probability of depassivation, 18 divided by 32 or so on and so forth. And then what I did was I plotted this probability of depassivation, probability of depassivation against repair areas. So where the probability of depassivation were high, right, chlorides were higher. I'll just take 2 minutes, not 5, even 2-3 minutes maybe. So this is what it was. And somebody, so many cases actually, 25 to 30 cases I have handled similar, all are with buildings. Because bridges, the problems was not happening and people wouldn't have come to buildings. So there are other people to do that. So buildings were coming, and this was the scenario. Obviously other problems were there, So I'd like to highlight this august body, people, Indian Concrete Institute, to look into this issue seriously, that we don't see that internal chloride is there in the concrete, and that's a major problem. Carbonation, many buildings I did. There are some buildings where nothing happened, but they invited us because of doing the regular inspection. 50 years, 40 years, but just I'll take 2 minutes. Okay. Socio-chloride, fresh concrete, chloride contaminated aggregate. Admixtures, no, I don't think they are. There are too small quantity and nobody uses chloride admixed concrete. Mixing water, hardened concrete, application of de-icing salt is not in India. And what all model we are using, error function and all, it's actually meant for that kind of scenario, where you have a constant boundary condition. This is not applicable to India. So one should be careful about that. Seawater, marine structure, soil groundwater, these are the other possibilities. Major concern, of course, in building is internal concrete chloride. Okay, so chloride ingress can occur in contact with contaminated mortar and plaster also. I have come across such a case, right? So, because you don't care about the plaster, don't care about the finishing that you are doing, but 2 minutes. I'll finish saying 2 minutes for last 3 minutes. So I'll finish it off anyway. This is what happens in Indian scenario. There is a conducive relative humidity condition within concrete where depassivation can occur or also corrosion can occur. So these are the degradation period. It doesn't happen continuously, particularly in composite monsoon climate, even in warm humid climate. So wetting and drying is very important. We modeled it actually, right? So for corrosion, conducive moisture, humidity condition is 90 to 95%. And I think one should look into Indian climatic scenario in durability issues in this manner. Marine zone, continental zone, hot dry desert climate. The case I was talking about, red I am showing is warm humid. Composite, very high precipitation zone and all that. This is the only place where you can use error function solution, submerged concrete. Because I have the derivation also, but I don't think I am going to give that. Because this for a heat diffusion equation, Karlsruhe and Jaeger 1950s, this solution is available. People have just adopted it, but this is not de-icing salt. There permanently chloride remains for quite some time. The de-icing salt remains for quite some time. So that model can be used, perhaps. But Indian subcontinent, that model can only be used. So this is the kind of zones that I said. I'll just stop here quickly because he's trying to push me out. Obviously, I understand he's in a tough job. And what we did was, we did wetting and drying modeling. Data we collected from IMD for 15 years. Data was available to us, rainfall and all that. We tried to find out what is the rainfall, intensity and duration. Both are important in the model. Don't get scared. You don't have to do that, can't do that also, because it will need cloud computation for several days to come out to this Richard's equation, which is nonlinear diffusion equation. As you can see, wetting and drying is different. And I'll just go out of this quick fast. I'm not going here. And boundary condition for rain is, this is given by Lesis on empirical equation, wind driven rain. This is the kind of thing we did, but I think again I'm going fast. So we could, if you have some question, I can answer later on also. Kelvin's equation to find out what will be the moisture content at a given point. And we used our own equation of porosity and pore size distribution of concrete. We had these results available. Now just half a minute now. This number of days we could calculate out using these models. Number of days when corrosion would occur in a year. Design condition, taking design data for rainfall and all that. And this is for warm humid climate, 25 mm cover, 50 mm cover, number of days you can find out with an assumption, different water cement ratio and assumption of 40 to 60 degree temperature, 40 degree temperature, 60% humidity during dry and so on. So actually this is far more complex. We did it for 6 stations, but I think I'm not showing it. Corrosion rate is available from one of my students' work, Professor Bulu Pradhan, his work for added concrete. We use this, both ICOR to calculate out ICOR and then use another model of our joint student Kamal Jain. I mean, he did some work and we could find out the cracks by using again finite element modeling. Last slide. because that concludes it. I'm not going to go into these expressions. So what we did was, we could find out for this corrosion rate that, 72 point, that's from some measurements by Liu and another Andreas model, but Liu experimental work. And our one was showing, model showing 72, and if we do that, then 260 days in a year, we could estimate that cracking would occur. So, sometimes, therefore, that's what it is. I definitely must mention, give me half a second time.
Okay.
Yes, no, I'd like to mention this, don't close it out. I'd like to mention this is important. This is a sentimental affair. Last slide, thank you slide. Thank you slide. Okay, I'm going. Late Chandrasekhar Prasad, he is the one who gave me all those data from somewhere in the Arabian coast. Died out of COVID. So it's also, I would like to pay tribute to this gentleman. That's why I wanted. This is a set of my people who worked with it. Some of them are retired professors also. Thank you very much. Sorry. Oh, I can take a little bit of liberty with him because I have taught him a course or two.
Yeah, but not with the next speaker. So thank you, Professor Bhattacharya. Yeah. In the interest of time, I'm going to hold questions. You're welcome to discuss all the wonderful detail that is presented perhaps during the coffee break. Yeah, so can somebody take the lapel mic? At this time, I'd like to invite our next plenary speaker. It's an honor, privilege to introduce my friend, Nemi Bantia. I guess Name Kumar Bantia is a Killam professor, which I hear is the high accolade at the University of British Columbia, or maybe in Canada. He's the founding director of a center called IC Impacts. They've done wonderful work across India. And of course, I can go over his research accomplishments. They would read for days. So with that, I would like to invite Professor Bantia to take over the stage, please. Thanks. Would you write the lapel mic? Sure. Yeah.
Professor Bhattacharya, it's difficult to displace your previous professor, so apologies.
It's actually due for my time. Although I can take a little bit of liberty with you.
Can you hear me back there? Okay, that's great. Thank you very much, and thanks to Subbu for accommodating me and for all the woes of indigo that we are going through right now. But anyways, wonderful to be here today. So thanks for being here. So my talk is in fact a bit of a smorgasbord of things that we're doing. But the idea here is, I think, strategies for reducing life cycle carbon emissions in our built environment. And in fact, it follows from some of the questions that Kaizen got, I think, in terms of really what we're doing. But I want to go contrary to intuition now, I think, so want to go to sort of an area where we normally do not think about. You know all this. In fact, if you look at this was a heading very recently in Washington Post, on Bloomberg, it said cement produces more pollution than all the trucks in the world. And clearly that's a really, it's a wake-up call, clearly. And that's the kind of emissions that we're producing. We really have a huge issue with respect to what we need to do, I think, with respect to this particular material. But now I come to the bigger picture. If you're looking at the bigger picture now, if you look at, say, 80 gigatons of GHG or CO2 we produce, almost 40 gigatons of that comes from our built environment. So when you're talking about the built environment, we're talking about just the roads and bridges and buildings, etc. Out of that 51%, our operations, I think something was mentioned very recently, if you're looking at the building operations, you're sort of accounting for about 28%. And I think that's what we need to really control. And when you're talking about building operations, we're also looking at repair and rehabilitation. We're looking at services, we're looking at heating, lighting, HVAC, and things like that. Of course, we already know when you're talking about building materials, and the construction, typically referred to as embodied carbon, it's about 23%. And we have been all fixated on that 23% ad nauseum. And I think I need to sort of now start looking at how we can actually reduce that 28% that's coming from our built environment. Concrete, I mean, we all know it's about 11.1%, but key is to sort of have this holistic view. And I would like to actually talk about is really how we can actually look at this 51% of global emission and not just be focused on that embodied carbon that we all worry about all the time. The other problem, I think, which is really creating that massive issue is that just as much as we have this problem of cement creating carbon dioxide and actually polluting the environment, increasing temperature, the climate change is also affecting our structures. In fact, we have 2 PhD theses lately. What is happening is that our greatest source of emission now, in terms of carbon, is also our deteriorating environment. So it's essentially a double whammy. You have a problem with climate change, but you also have the structures which are going to last shorter and shorter span. We ran some scenarios for a number of cities around the world that if you were to have a full-blown carbon what you call AF1, F1 scenario, which is by the IPCC, full-blown, climate change, CO2 approaching almost 1,000 ppm. What you will notice is that in some of these cities, and we did scenarios for New Delhi, we did scenarios for Mumbai, we did scenarios for Vancouver. I'm showing the scenario for for Singapore. If you look at Singapore particularly, which is really not too different from Vancouver, for example, you will notice that the actual life expectancy of a structure because of climate change will drop from 56.6 to 43.8. So you're going to start to see increase in corrosion in these buildings 9 years sooner. And that's a real problem because that it goes into that 51% that I'm talking about in carbon emissions, because now I have to replace this structure faster and faster, which is really another problem that we need to deal with. So I'm going to talk about some sort of non-traditional ways of looking at this particular problem, which is really the holistic view of really what we want to look at. Climate change in its concrete curse, I call it. Strategies for carbon neutrality, which we'll talk about ultra-high performance concrete. I know Kaijan did a wonderful job of setting up the stage for me, but I will argue with you that in terms of our global approach towards reducing our carbon emissions, ultra-high performance concrete actually appears as a very good solution. Now everybody talks about its high impact, high carbon emissions, etc. But what we are doing is we are actually reducing the carbon footprint of ultra-high performance concrete while we are getting basically better durability from the material itself, which reduces, at Kaijan's, your life cycle carbon emissions as well. And we're going to bring some nanomaterials in there. The idea is, and you will argue with me that, well, nanomaterials cause a great deal of carbon emissions. They do, but for a very small quantity of carbon for nanomaterials, I can increase the durability enormously, which means that if you look at the cost and benefit analysis, it makes a lot of sense to bring nanomaterials into a very high performance material like ultra high performance concrete. There's always some work on cement-free matrices, so we're doing basically activating or alkali-activated slags along with a whole ton of crumb rubber in it, and I'll show you that it can reduce the carbon emission by almost 62%. I will then gather a little bit into CCUS, carbon sequestration and use of nanobubble water. So if we are all looking at basically spewing carbon dioxide into concrete, you've got these trucks that are carrying these carbon dioxide cylinders at the back now. That's actually a hoax. Trust me, there is a big problem with amount of CO2 that we can sequester in concrete as a result of this adding through mineralization and carbonation that comes from CO2. It's a very carbon positive system. That's what I would argue. So we really need to do something in terms of innovation. Yes, we can put CO2 into concrete, but the way we are doing it right now is completely wrong, I would say. So we'll talk about a bit of the work we're doing on nanobubble water. Sensors and AI, that really what actually draws it now. I think we need sensors and artificial intelligence in order to maintain these structures, because if I'm looking at, in fact, more than 25% a quarter of my emissions from services, then I really need to actually put some sensors into the structure in order to make sure that I'm monitoring them properly. and then we'll look at resilience and strengthening as well. Now, this has been the global strategies. I think you're looking at emission reduction and net zero. This comes from, in fact, cement associations. 28% in CCUS, efficiency concerns. I don't think you're ever going to get that. UHPC and nanotechnology, 24%. That's what I'm going to argue about. Binders, again, we have come to a very large sort of an asymptote there. Sensors and infrastructure, I believe, are very useful. And finally, clinker improvements and carbon uptake, I think we have absolutely reached the limits. So here is the bigger picture that we are dealing with here. And I know Professor Shah talked about it quite a bit. Cement, removing all cement from concrete using geopolymers, recycled tires and fibers, aggregates, which have been 100% aggregate with sequestered carbon, water changes, what has come about a lot as well. But I'm going to focus on the non-traditional side now. This has been, done ad nauseum. We have done a lot about embedded cement systems. I will talk about CO2 curing, coming up with new methods of CO2 curing. We'll talk about ultra-high performance concrete, bit on sensors, and then finally on strengthening, which will reduce in a holistic way what our infrastructure is actually emitting at the moment. So ultra-high performance concrete, I know Kaizen has done a very good job. There's been a great deal of work done on ultra-high performance concrete. We have got a lot of structures out there. And as Kaizen just showed, this is a book that Kaizen and I just wrote together. It's available. It has got quite a bit of data from everywhere now. But here is what ultra-high performance concrete is. So if you have an ultra-high performance concrete, what you're loading it in tension, you get a tensile strain and stress curve. You will get this initial cracking point, and now compare this to normal concrete. At this particular point, your normal concrete would fail. Basically, you would have this linear elastic failure, and then it would actually collapse. Whereas for this material, what you will see is that you get a great deal of strain softening, sort of first a strain hardening. So it's almost like a material like steel. So you get this strain hardening in the system, and then when you have finally a strain softening, and at the strain softening regime, what you'll see is a lot of multiple cracking. And this multiple cracking is the one that gives you energy absorption. So this is a wonderful material basically for your blast, impact, retrofit, seismic loading, earthquakes, flood control, where you require a great deal of ductility in the material. So this ductility is the one that we are going after, but at the same time, we are also going at high strengths. So if you look at the strengths that I can get from this material, you can get up to 220 MPa easily. And in fact, we have a material now that we have created in my lab where we can go up to 300 megapascal compressor strength, along with 5% strain capacity. So you're looking at an elastoplastic material at 300 MPa, 5% strain capacity, that's just like steel. Now, where are we going to put the nanomaterial now? So if you look at the particle size distribution in your ultra-high performance concrete, you have on the left side is the superplasticizer, water, glass, fume, cement, and two types of sand. What I'm going to do is, if I am really looking for the packing density increases, I'm going to start putting the nanomaterial on the left of the scale, where it's actually interacting with water, basically. So I want to actually do the packing density basically at the left of the scale. And here, I think if I do that, what you'll notice is that by really working towards controlling what the crack pattern is, if you look at actually a DIC plot where I'm looking at this material under tension, you will notice that it starts to crack vertically as the load is increasing, which is exactly what we call multiple cracking. And that multiple cracking is dependent on not just the matrix, but also on the fiber matrix bond. So when I'm trying to increase now any performance, and if I want to add nanomaterials to my system, what I would do is I would change completely the responsiveness to the matrix, but also the fiber, which has got this coating of a nanomaterial on it. Lots of applications. Kaizen already talked about more than 200 bridges, but we have a lot of architectural concrete that has been using ultra-high performance concrete now. And coming back to durability, there was a question related to durability. If you look at the ultra-high performance concrete compared to high performance concrete and normal concrete, on every durability front, you will see a benefit. It's either on diffusion coefficients, it's on chloride ingress, in terms of water permeability, in terms of everything else. What that means is now UHPC that we are working with will have a span of 200 years or more. And that's exactly where I'm going, that we are looking at non-traditional ways of reducing carbon emission. This is the way to go. If your structure lasts 200 years, you clearly do not have to replace the structure for 200 years, which is what reduces, again, the complete use of all these other new materials that we have to bring in order to replace the structure. So if you can last it for 200 years, that's going to be really wonderful. So I have a nanomaterials, a lot of nanomaterials out there. There's nanosilica, there's nanocalcium carbonate, etc. Where will I put it in ultra-high performance concrete? And what we have decided is that we can put this nanomaterial at 2 levels. It's a nano system, it's a highly fine system. So what I can do is, I can do it in 2 things. I have ultra-high performance material, very high strength. So I can take this nanomaterial and add it to the concrete in 2 different ways. One, I could do direct add. I could just throw it into the mixer and actually create an ultra-high performance concrete with a lot of nanomaterials in it. Secondly, I could use it as a fiber coating. Don't forget, ultra-high performance concrete is a fiber reinforced concrete. So I can use the nanomaterial on the surface of the fiber itself. What that means is I can change its characteristics quite enormously, particularly the energy absorption capacity. Now again, there is a smorgasbord and amazing amount of nanomaterials that are available out there. You have, of course, the nanofiber, nanoferrous, nanoalumina, carbon nanofiber, of course, the graphite nanoplatelets, carbon nanotubes. There's a whole series of nanosystems that are available out there, used by the automotive side, used by the aerospace side, but they are all available now for concrete. So here are some of the things. So we have 3 types or 4 types of nanomaterials that we can add. One is, of course, the zero-dimensional, which is what we call nanoparticles. So your nanoparticles could be zinc oxide, which is a biocide, as you know. There's a number of other ones that are available as well. Then you go into the one-dimensional nanomaterials. These are such as, for example, carbon nanotube, which is a one-dimensional system. Then you can keep moving into graphene, which is a 2-dimensional system. And then finally a 3-dimensional nanosystem, which is actually micron in range, but it has got the individual dimensions in nano, and which is what we call polycrystals as well, actually, which are also available for our system, for our materials. So I'll go, these are sort of the transmission electron microscopy of the nanomaterials we're using in UHPC. Nanosilica, nanotitanium, ferrous, nanocarbonate, and then of course in the 2-dimensional systems we have the graphene nanoplatelets, graphene oxide, and unfortunately we haven't used the 3D materials yet in UHPC, but there is an opportunity, I think, to use the 3D polycrystals as well in concrete to produce ultra-high performance concrete with enormous capabilities as well. Now what happens? I'm putting this nanomaterial directly as a material in ultra-high performance concrete. Now this is already a highly dense material. So as Kaijan talked about, in fact, it's already a very dense material because we're using density equations. If the moment I add some kind of a nanomaterial in it, I can increase the density or the virtual packing density of ultra-high performance concrete, which is at about 82%, all the way up to 84%. And that's an enormous change. And the moment that I'm able to do that, you will notice that my strength goes up almost by a factor of 20%. So even small dosage of nanomaterials added to ultra-high performance concrete can increase your strength enormously. And don't forget, some of these nanomaterials are also active. They're not just inert fillers. So if I added, for example, nanosilica or nanocalcium carbonate, you will notice that because the heat evolve curve actually moves to the left. What that means is I'm actually creating a lot more internal or changes in the internal rate of hydration, and because of that I get nucleation sites, which actually gives me even an added strength as we're going on. Here is a overall data that we have seen in the literature. These are about 100 studies that we looked at the use of nanomaterials in ultra-high performance concrete, both as an inert filler and both as an active filler. And what you will need to notice is that in the ultra-high performance concrete system, I can increase the compressive strength by about 30%, which is enormous given that I'm adding only 0.01% of nanomaterial in the system itself. On the compressions, or on the flexural side, the results are even better. On the flexural side, through adding very small amount of nanoparticles, which is 0.01% sometimes, I can increase the flexural strength by up to 70%, which is quite enormous for a given this small amount of nanomaterial I'm using. So we should stop asking the question, what about the carbon footprint of nanomaterial? Because very small dosage of nanomaterial can also increase your compressive and flexural strengths enormously. These are the active or the contents that I'm putting. I don't have a time to go through that. But here is, I think, coming back to durability now. If you're essentially looking at the corrosion currents, you can see that the moment I add nanomaterials into UHPC, you have a great material which can control corrosion. So this becomes a great material for repair in itself. Second thing we want to do, I added directly the nanomaterial to my ultra-high performance matrix, just added it to the mixture with some sonication, of course. Here, I want to take that nanomaterial and add it as a coating on the fiber, which means that I am now working with a system which has got a nano-coated steel fiber in it. And that changes the characteristics completely. So here, I'm looking at, this is the response that I want to now change. You can immediately see that if I have a strain hardening capacity, if I add some nanomaterial or nano coating on the fiber itself, I can expand that zone quite enormously, which means that I can not only get much greater strain hardening, I can also get much greater strain softening, which means that I can actually mimic steel now by adding this nanomaterial on the steel surface itself. So we did two different types of nano coatings on the fiber. This is a nano calcium carbonate coating, which is what was essentially a process that we developed. And the moment you look at these systems, here is the nano calcium carbonate coating on the fiber itself. And you can see that this particular coating is very stable. It actually is attached to the fiber itself, and you can immediately see it changes the roughness characteristics of the fiber. It increases basically what we call fractal on the fiber. So if you did an atomic force microscopy on it, you will see the actual change in the characteristics. So this is a typical fiber which has got a nanocarbonate coating on it, and these are two types based on the temperature. And here is the response. What you will notice is that the moment I have that kind of a coating, focus on the right side, what you will notice is that I can increase the energy absorption capacity by almost a factor of 2.5 times. So I can double it by 250% by simply adding a small amount of nano-coated fiber to the mix itself. Now we did some further work on adding nanosilica as a coating on the fiber itself. Here is using basically the TUs and the chelating process. And there is the one on the left which is uncoated. On the right, it's a silicon-coated fiber, which is a wonderful material now, because don't forget, silica is a pozzolan. And the moment I have a silica as a pozzolan, what you'll notice it right at the surface of the fiber, you start seeing pozzolanic reaction, because I have now nanosilica on the surface, and that nanosilica completely covers up, reduces the porosity at the interface between the fiber and the matrix, and it is a wonderful material, both from durability as well as from strengthening characteristics. So here, by simply adding 0.1% of nanosilica, I'm able to completely change the load deflection curve from these things. Now, I'm going to go back into traditional mode after the nano technology being added. So there's a fair bit of work being done basically activating slag with lime. I think there were some other papers also on this, but I believe doing this kind of a work by optimizing the system, we can come up with a completely very ductile system. And at this ductile system with up to 60% crumb rubber, we are able to actually get up to 62% reduction in CO2 and almost 26% reduction in embodied energy. So there's a lot of work that's been published on this. But again, this is going back into the traditional systems that we're dealing with. Now, on bringing CO2 into your mix. I know there's been a lot of work done on it. There is an X prize that was given recently to a Canadian company that was injecting CO2 into the concrete. I know India is doing quite a bit of work as well in that range of putting CO2 back into the concrete. Unfortunately, what happens is, of course, you put CO2, it reacts with calcium hydroxide, produces calcium carbonate, etc. Unfortunately, at the moment, what you can do is you can add less than 1 kilogram of carbon dioxide into 1 meter cube of concrete. Now think about that. You're adding effectively adding less than 1 kilogram of carbon dioxide into 1 meter cube of concrete. So at this rate, transporting your CO2, carrying it on the back of your truck, it becomes an extremely carbon positive process. Doesn't work at all, actually. And this is really something we need to stop, because that's actually creating more carbon emission for concrete than you need to. So what is needed? What we started to do was to start adding nanobubble water now. Now, what is nanobubble water? Nanobubble water is injected under pressure into your concrete system. So you can create nanobubble water separately, and that particular nanobubble water has these nanobubbles which tend to be negatively charged, because I'm actually putting them under pressure. Now imagine you have negatively charged air, which is in concrete. It is going through van der Waals forces, start attracting CO2 towards itself, and the calcium particles, which are calcium ions, which are positively charged, will all be attracted to your nanobubbles. And the moment they come closer to nanobubbles, what can I do? I can increase the amount of CO2 going into concrete by a factor of 8. What that means is, while I was not able to inject more than 1 kilogram of CO2 into concrete per meter cube of concrete, now I can add up to 8 kilograms of carbon dioxide straight into my concrete, and that becomes a highly carbon negative system. And in fact, what we're looking at is, if you look at the sort of NMR data, etc., I'm not losing any porosity problems. In fact, I'm producing a carbon with this concrete with this nanobubble mortar, which is in fact highly, I would say, dense. It has a much lower porosity, and you're looking at some of the pores here. That's your CNBW is actually with the nanobubble water, and you can see that the gel porosity is increasing, the total porosity is actually reducing. So what I'm saying is, I think in order to actually utilize CO2 back into the system, let's not just do it kind of an ad hoc manner. Let's develop innovations which can actually increase the amount of CO2 that we can sequester. So there's a whole series of projects that we are running right now. We're trying to increase how we can actually put some more CO2 sequestration into concrete itself. A little bit now on management, which is on sensors and AI. So I truly believe that I think all of these structures that we are dealing with are deaf and mute. They're not talking back to you. And the structure which is talking back to you can be managed properly. And what we are doing is we are looking at basically sensors. So these sensors, for example, ultra-high performance concrete itself is a sensor. And what you will notice on the right side is that as the load changes, its electrical response changes. Every sensor should have an electrical response. And here on the right side, you will notice is that as the load changes, my fractional change in resistance changes as well. And what that means is I can use this material as a smart material in the concrete, which is able to tell me exactly what's going on in the system itself. There's been a fair bit of work done already on piezoresistivity. As you know, these are piezoresistive concretes, which have got carbon fiber, carbon nanotubes in it, running them at a very high frequency. And what you will notice is that if I look at basically the load up on the top, and if I look at the sensor response, what you can notice is that I can exactly measure with my resistance measurement on the sensor, from the sensor signal or sensor data itself, exactly what the load on the structure is. And in fact, what we're using it is even for chemoresistivity. So as a smart patch on an oil pipeline, the moment you have a leakage, you will get a signal. So these cement-based patches can actually detect leakage in oil pipelines or any other pipeline because their resistance changes and their signal changes. So they can tell you exactly where the leakage is in a specific pipeline. Again, these are some of the things we're doing at the moment. Number of sensors that are out there. Some of these sensors we're using, currently utilizing on Indian Railways for detecting basically tracks or monitoring tracks against scour, against bridge fatigue. So there's a number of corrosion, medium sensors. These are some of the medium recognition sensors. And I would strongly recommend that I think if you're really monitoring structures, start using some of these sensors, which will allow you to detect what's exactly going on. These can detect scour, these can detect mudslides, these can detect a number of things. If you remember that Fukushima Daiichi earthquake that occurred, and this particular nuclear reactor its basement was completely underwater, which is what caused the massive meltdown. Now, if you had sensors which told me that there is actually water in the basement, you would not conduct you would not carry on with producing charge or producing power from such a reactor. So I think these medium recognition sensors can be very useful in terms of detecting what's going on in the structure itself. Now, we have a number of monitoring projects. For example, this is the Confederation Bridge, which we are monitoring very close to Prince Edward Island and New Brunswick. This is a 14-kilometer long bridge, and we are monitoring right between the pier 30 and 36. The reason was that we thought all these ice sheets that actually come there, they will be impinging at the bottom of the pier, and that will create a very high impact. So we put a lot of sensors at the bottom of these piers, but then when we measured them, the ice forces were not that large, which means that otherwise we would not have known that unless there are sensors. So if you're designing a structure which actually has conditions that you're not aware of, sensors can be extremely useful in that particular design. Well, we are using basically a number of sensors. So these are analog data, and we are using what we call the LARAWAN network now, which is basically a long-range wide area network. Using cellular data is extremely expensive, and it doesn't produce the right kind of response. So we are basically using this LARAWAN network for a number of bridges and sensors that we are monitoring right now. In the end, what my hope is that you would end up having an app for every structure which has got a certain number of sensors on it, and you can monitor basically everything that will allow you to create what we call a digital twin. If you can create a digital twin for the structure, you know exactly how the structure is behaving because you know what the sensors are basically telling you. Finally, I want to talk about resilience and strengthening. This is something which is critical. We need to monitor our structures and make them resistant and strengthening. So one particular area we're working is on microbial corrosion. Under your feet, these sewer pipes are deteriorating very rapidly. It's a $100 billion problem just in India. And what is happening is that you have this Theobacillus bacteria that is chewing away concrete. So what we are doing is we are looking at, well, this is exactly what happens. You have the sort of sulfate-resisting bacteria, and then you have basically the sulfurous oxidizing bacteria. And what we're looking at is basically coatings. These coatings can actually work as a biocidal coating on your sewer pipes, which can control entirely the corrosion in these systems. And what we are also doing is bringing in sensors. So we have sensors in these sewer lines now. And these sensors, which are microgel-based optical sensors, they can detect a DNA of a bacteria. So for example, if I have the growth of Theobacillus in my sewer system, it will send me a signal that the bacterial growth or bacterial biofilm has started forming, which would be the exact time to send our crawler to start basically putting what we call a biocidal coating on the system itself. So again, we are integrating in a closed loop format these sensors, which can then send you the signal that the biocorrosion has started, biofilm has been formed, and then it can start actually working on controlling the system itself completely. I don't know if I have the time, maybe somebody can play the video for me. I think I want to answer one of the questions you had about steel fibers. So this is EDCC, which is ultra high performance concrete, which doesn't have steel fiber in it. We are combining polyvinyl alcohol with PET, polyester fiber. So if somebody can play. It's not playing? It's okay. Anyway, no problem. So we are actually using it for seismic strengthening. So this has got a very thin coating, and this is the one which has got this 4% strain without any steel fibers in it, actually. So anyway, I'm going to stop here. Thank you very much. Sorry, I didn't see that.
Aptly put, au revoir.
Thank you.
So we have time for one or two quick questions. Mike, please come here. Yeah, do we have a question here?
Here.
Oh, here. Okay. Let me get a mic here. Yeah, it's on.
It was excellent, like the research which has been going on, especially the unconventional way of, mitigating sort of carbon footprint. It's fantastic. I have a couple of questions about that. You see that using the nanomaterials, nanotechnology, are you reducing the cement content itself? Are you reducing the fiber, steel fiber content itself in the concrete? Because you are increasing the strength of the concrete. In terms of the strength as well as the flexural strength is increasing, but the cement content remains same. One of the problems of the carbon footprint in the UHPC is your cement content is very high. It's as high as 600 kg per cubic meter of concrete. Like that's how it works out to be. And also the steel fiber is around 2%. These are the two components in the UHPC which is responsible for the carbon footprint, to say that. Are you reducing by use of the nanotechnology what you are saying? It's fantastic. You are increasing the strength of the concrete, flexural as well as the compressive strength of the concrete, by which it becomes almost like a steel. That's what you mentioned. So it becomes, in terms of the mass, quantum, it becomes less. Indirectly, it's reducing the carbon footprint. That's what you are saying. Is it possible to reduce the cement content itself by use of this nanotechnology? That's one thing. Another question is, these bubbles, like that nano bubbles for the carbon sequestration in the concrete itself. But some people talk about, like it is already entrapped in the concrete. The carbon is already entrapped in the concrete. When the concrete is going to be demolished, again it is going to be released into the environment, So the sequestration is not an answer within the concrete. And also, what is the effect on the carbonation? I'm just
Mr. Hegde,
asking,
I think, you're almost giving a talk here, so I think we'll let...
I think you're asking a very good questions. To the first one, I think the key is to, first of all, not use 600 kilograms of cement in UHPC. We're dealing with less than 200 now. There's been a lot of work done already on reducing cement. That's one thing. Second thing is I'm looking for a reference point here. So by adding nanomaterials like nanosilica or nanotubes, if I'm able to increase the capacity, or if I'm able to increase the strain capacity and strength, and if my reference point is at a lower level, I would then go ahead and reduce the amount of steel fiber in it. So if I can get the same reference with nanomaterials, I can get the same characteristics by using a lot less steel fiber in it. So again, that's the purpose, which is really why I argue for nanomaterials, because if you look at the cost and benefit analysis, the small amount of nanomaterial I'm using can dramatically reduce the amount of steel fiber I need. So given, that's the purpose, no doubt about that. Second thing about your CO2 sequestration, this is completely mineralized. This CO2 is completely mineralized. With nanobubble water, what we're doing is in fact even promoting the whole process of mineralization. So there is no CO2 left in the system. It's completely mineralized. So it's not going to be released at the point of demonstration. Okay?
Okay, in the interest of time, I'm going to stop questions here. I'd like to thank Professor Bandia for a wonderful presentation. I've always admired the ease with which he presents difficult concepts. So I'll hand over the floor to Mr. Girish, who will now take over the proceedings.
Thank you, Professor KVL Subramaniam. I would like to mention that ACECON is definitely about concrete, but it is much beyond that as well. we have lined up some of the most interesting materials that go on to constitute concrete and play a very critical role, just not in its manufacture, but also in its performance. So coming up, a series of excellent best-in-class materials are being lined up immediately after this particular brief moment where we honor the esteemed speakers. I request all of you to be seated so that we take you on a wonderful but a very brief journey of the various excellent materials that were lined up for you. May I now request Dr. Venkateshwar Rao to please come onto the stage. I also request Dr. V. Ramchandran, Engineer Manoj Kavalkarji, Dr. Kantarao also to please come onto the stage. Professor Subramanian sir, we request you to please grace the stage, and we really commend and we are thankful to you for the excellent way you have moderated this session. Thank you so very much. I request Dr. V. Ramchandra to honor Professor KVL Subramaniam. Thank you. May I request now Professor Kaijin Shi to please come out to the dais. We thank you for coming all the way here and sharing your very erudite views. May I request Dr. Venkat to honor Professor Kaijin Shi with a shawl, a memento and a bouquet. Thank you all. Ladies and gentlemen, let's give a big round of applause for the erudite scholars here. Now may I request Professor P. Bhattacharya ji to please grace the dais and receive the honors. I request Engineer Manoj Kavalkar ji to do the honors on behalf of the Indian Concrete Institute. Quickly, Kantarao Garu. Our audience would like to partake in the excellent lineup of construction materials that we are lined up for them. Yeah. Thank you all for your loud applause. May I request Professor Nimi Bhantia ji to please grace the dais. Professor Nimi Bhantia. Okay. He has just gone out, I think. Is he out there? Can somebody just, Maulura Gauru, can you quickly see? He has gone somewhere. Okay, we will do the honors on his behalf. Now for a very quick photo op, sir. You can please face the camera. Yeah. Thank you all so much. Thank you, and audience, please give them once again a loud applause. Thank you so very much. Now let's know a bit of the cutting edge technology that goes into manufacture of cement, and for doing that may I require the Adani Cements to quickly come out to the dais and make the pitch here. Adani Cements. Please come. I request all of you to be seated.
Hello. So, very good afternoon, all the delegates and distinguished guests. Now I am presenting Adani Cements here. So, we are cementing our commitment to nation building. if you see, Adani Cement is present in every part and every corner of the India's cement. And if you see, every part in every day-to-day life, we are working with Adani Cement products, and all things are present. So if we talk about cement, we have two products, major ACC and Ambuja, two brands together. We are working under the umbrella of Adani Cements. We have 107 metric ton capacity placed at place, and by 2026 we are planning to another 10 to 12 million ton added in this capacity, and we have 120 plus ready mix plants. And if we talk about 24 integrated plant, we have all the corners in the country, and 22 integration plants. And if we talk about the professionals, influencer, we have 6 lakh plus influencers added with me, with our company, and 1.2 lakh channel partners, from which we are working, and we are supplying cement to the your doorsteps. If we talk about our products, all the products of ACC and Ambuja now Griha approved. So, and if we talk about our two special products, premium product, Ambuja Kavach and ACC Gold, both are solar impulse approved and efficient solution for the construction. So all the products we have, all the product mentioned under the umbrella of Adani Cement, ACC and Ambuja, all are approved by the Griha. Recently, last year, we have launched our campaign, one initiative, Adani Certified Technology for the IHB customers who is building our own house. How can we help? How can we help to promote sustainable construction, low carbon, zero water curing through our modular curing seats? What services we are providing to the customers that helps them to sustain and retain their house for the long life. So, in Adani Cement technology under ACT, we have completed 1,80,000 homes through this technology, where we are reducing water utilization, zero carbon emulsion through our green products. So, till now, 1,80,000 IHB houses completed through Adani certified technology. If we are talking about promoting low carbon solution to B2B customer, our B2B customer, we are giving them the ready-made solutions. How can we reduce our carbon, low carbon? Even if we talk about ICJ General, Indian Concrete General, oldest construction general, consistently we are published every monthly basis. If you talk since 1927, we are publishing the ICJ. Reimagining the Adani role, now cement to nation building. We are providing largest cement company to market innovation leader, building a material supplier to partner to in nation building. Net zero oath, we have also take the net zero oath, and net zero target by 2050. Target ahead of country target to be net zero by 2070. We have taken the target to 2050 by the net zero, which is validated by SBTi. If we talk about the sustainable integration initiative in manufacturing, so we have done lots of initiative. We have already taken on the cement manufacturing. How can we reduce the carbon initiative? How can we capitalize water uses? Everything, lots of initiative taken care in the manufacturing process, which we are presenting here, if we can see. Adani Concrete, if we talk about Adani Concrete, we have 120 plus plants everywhere, all the country, every part of the country, where we are providing services, sustainable concrete, mainly focus on low carbon concrete, and EPD, our new structure, we are providing that. Recently, we have casted largest raft, if you see, Umia Dham at Ahmedabad, where we have 54 hour, we have regular concreting, we have done regular concreting, 24,000 cubic meter concrete placed, and M45 degree, if you see 28 degree temperature maintains by the year, it comes under Golden Book of Records also. So recently we have casted this raft at Ahmedabad, where Umia Dham will be placed, world largest raft casting, we can see. Award recognition, if we talk about awards, so we are getting lots of awards in every field, you can see like this. we want to play just one video. हम करके दिखाते what is the tagline of the Adani Cements. Voice can we? Okay, no issue. Voice is not coming. No. So as time is up, I am seeing this. So just I want to finish this. Our chairman always talk one thing: walking alone, speed is possible, but walking together, greatness is inevitable. So that is the tagline of the Adani Group, and we are working with together with this tagline. So thank you so much. Thank you. Thank you.
We have a surprise, and I request Mr. Edukondlu to immediately take out the draw, and let's see who is the lucky winner. They have come up with a special scheme of the lucky delegate concept. Very quickly, on to the center stage.
Sir, this initiative we started with Anchuri sir. So we will take draw with Anchuri sir. Go there. Front. Yeah, we are there. Here. First. Tandan sir. Ikkada. Seven. Ikkada. Ikkadche. Sir, announce.
Please announce the name and if the delegate
the
is
lucky person is Mujib Rahman.
Is he there, Mr. Rahman? Quickly, please come on.
Tell me your phone number, please.
Please come on.
Check the phone number.
Who is the lucky person, sir? Please read it out.
We have 5, sir. Andar disko. Announce.
So the next lucky person is Mr. Akamma Rao. Mr. T. Ankamma Rao.
Yeah, please come. Please come.
Please come fast. Let's see who is the third winner. Here. The
Sir,
third
please come on to the
winner
dais
is
very quickly.
The third winner is Mr. Shailendra Karle from Nagpur. Mr. Shailendra Karle from Nagpur.
Brand. Please come in. Please come.
The fourth winner is Mr. Milind Joshi with the number ending 470. Mr. Milind Joshi. Yeah, there he is. And then the fifth winner is Mr. S.S. Sivareddy. Mr. S.S. Sivareddy.
Please welcome, sir.
All of you, please come on the double, please. So this lucky draw will continue through the sessions. At the end of every session, we'll aim to have one. Therefore, those of you who got coupons here, please bring it and drop it in the portal. We have just kept it next to the podium. Thank you. May I request Mr. Edukondlu and the team to quickly distribute the surprise gifts. Ladies and gentlemen, please give a big hand to these lucky delegates. So the lucky delegates are Mr. T. Ankamma Rao, Mr. Shailendra Karle of Nagpur, Mr. Mujib Rahman, Mr. S.S. Sivareddy, and Mr. Milind Joshi. Thanks to all. May I request Dr. Venkateshwar Rao and Engineer Manoj Kavalkarji to please come out to the stage to convey our gratitude and thanks to the Adani Group. I request the Adani team to please be on the stage. I request Mr. Venkateshwar Rao, Dr. Venkateshwar Rao, to please do the honors along with Engineer Manoj Kavalkarji. Thanks to ACC Adani Group, they have been a tremendous support to the Indian Concrete Institute, not just at Hyderabad, but across various centers such as Bangalore, Mumbai, and so on. And we look forward to a continued patronage. Thank you. Thank you, sir. Now may I request the President of A1 Steel Group Companies, Mr. N.M. Rajendran, President Steel and Coal Trading, to please come over and present his business development pitch. I'll tell you.
Good afternoon to you all, dignitaries of the dais and people who have assembled here. And thank you very much for accommodating me in this conference, Indian Concrete and Asia Conference and ECTASI. So I will just briefly talk about our company, A1 Steels India Limited. It's a company which started in 2008, 2009 during the recession period. We just started our production to the tune of 4,000 metric tons. Now the cheap power what was available in Indupur, we made use of the power as a source of raw material to manufacture TMT bars. With a volume of 4,000 metric tons in Indupur and Gauri Budanur, we just kept on moving to develop other range of products. So from Indupur, we went to Bellary. With Bellary, we manufacture billets, blooms, and billets, blooms, and then we manufacture MS pipes and GP pipes using non-coking coal and iron ore. This coal and iron ore we import from South Africa, from different mines, from Anglo Total, and then as the other primary manufacturers, we produce from the sponge iron prime virgin material, and then coils. From coils we manufacture MS pipes and GP pipes to the tune of 15,000 to 20,000 tons. And then we also have another plant in Chikbalapur where we manufacture ferrosilicon using coking coal. Coking coal we import from South Africa. So totally we manufacture. So we have waste heat recovery, we have a power plant, and we have in-house consumption to use that power also to manufacture all the steels. So totally we have a production of 1 million tons, which we have achieved in 15-16 years. I'll just display all the slides, and which you will get to know where we are located and what are the products we are manufacturers in different areas, and what are the approvals which we have received in the government sectors, which has really helped us to make inroads and made footprints into this various sectors, and we sold good volumes, and the presence has been felt not only in Karnataka, in all the other places also. Where's the slide? The slides. So basically A1 Gold is present in Gauri Budanur, Hindupur, where we have rolling mills. We manufacture 30,000 metric tons. And Banya Steels, we have producing MS pipes and GP pipes using non-coking coal and iron ore. We manufacturing sponge iron. We have a rotary kilns of 10 into 100 TPD, which means we manufacture 30,000 tons of sponge iron. So sponge iron, we have a metallurgy of 84%. With that 84%, we put in the induction furnace. Induction furnace, we have 25 metric ton into 4 in Bellary as well as in Gauri Budanur. So, the metallurgy and the chemistry has been maintained right from the beginning, which helps us to maintain the quality. So there is lots of checks and balance in different areas. So, right from the heat number what we produce, so the quality is being maintained, and it's also been maintained by the good NABL labs, which has been accredited in Gauri Budanur. And in Chikbalapur, of course, we're manufacturing ferrosilicon and metallurgical coke using coking coal, which we import from Australia, and non-coking coal we import from Anglo Mines, Total, Extrata, Glencoe, 55NR we are importing, and iron ore we importing from Kumbha mines, Asma mines, and whenever it is workable, we also import pellets from Iran. And then till July we were importing, it was workable. But now the local raw metal which is available in NMDC, it is workable, so we make the product more competitive. Yeah. Okay, as I already explained to you, this Gauri Budanur is a rolling mill where we manufacture 30,000 tons of TMT bar. And in Indupur also we manufacture 8,000 metric tons of rebars. We have a trade license agreement signed with the major manufacturer where we emboss Jindal on the TMT bar. So we manufacture all grades like Fe500, Fe550, Fe500D, CR as corrosion resistant steels, and Fe500D. D is the ductibility, where we have the low sulfur, low phosphorus, which we control. And These are, it finds wide use in NHAI and the water desalination plants, corrosion resistant steels, where we have a separate approval which were in par with primary, which we have worked out for more than 7 years. So it has been accepted, and we are supplying to major customers. And Bellary, we have right from coal iron ore, we manufacture sponge iron, and we have the coal beneficiation and sponge iron, as already said. Then we have the waste heat recovery, which has been derived by the sponge iron, and we have 22 megawatt power also. Partly we use it for in-house consumption for manufacturers of MS pipes and GP pipes. MS pipes and GP pipes, we manufacture all sizes, thickness range from 1.2 mm to 6 mm. And coming back to Koppal also, as I said, that we have 100 TPD into 10. So in 100 TPD, we manufacture 3,000 tons of sponge iron using coal and iron ore, which is approximately 30,000 tons, which is a major prime virgin metal which we use it for manufacture of all products. That's a basic raw material to manufacture billets and blooms. These are the products what we manufacture: sponge iron, then MS billets and blooms. That's the in-house product, where we don't outsource any billets and blooms from other companies. It's all manufactured in our own primary integrated steel plant in Bellary. And of course, the TMT bar is manufactured from in Gauribidanur. The sponge iron, major raw metal, what we produce in Gauribidanur, in Bellary as well as in Koppal. We take it to Gauribidanur plant, and then we manufacture TMT. There also we manufacture 15,000 tons. So I think I already explained about these
Make it a high
functions.
tea. I don't think there will be time for lunch.
As I said, it was in 2008, 2009, our great leaders, Mr. Sunil Kumar Jalan and Sandeep Kumar Jalan, and the younger generation, Dev Jalan, the director of the company, they all started the recession period with a volume of 4,000 metric tons. The thirst is not quenched. And they started with a volume of 4,000 tons, and now they're doing a volume of 1 million tons. Within 16, 17 years, which is something great. And, it is their constant, ability, integrity, sincerity towards the jobs and conviction. What they do, they kept on moving, and the thirst is not quenched at all. They all want to reinvent, rediscovery, and that really made up them to reach this level. Now it's a company doing approximately $500 million, and DRHP is also fine, and then we are going to get into the initial public offer very soon.
This may be the right time to go if you are going. Geez, that side, right? Huh? Geez, that side. How do you say this thing?
It's not possible to sit there. You can play the video in between while you debug the PPTs.
I'll just talk about the approvals and then. Yeah, with constant efforts being made, though we were only into retail and supplying the material to the distributor. So what we thought that our presence should also be into various projects, government projects. We have received n number of approvals, which includes Chennai Metro Rail, and for water desalination plants and roadways and highways. So I'll just quickly go through the slides of the approvals what we have received. This is one Chennai Metro Rail, and the GC consultants are Nippon Koi RV Associates. These are this is the major units in Bellary, Gauribudanur, and Hindupur. And then we also manufacture this metallurgical coke. Okay. We'll just run a small video of a company. Can you just run it?
I request the team from A1 Steel to please come on to the dais. Please come on. May I request Dr. Venkateshwar Rao.
I came to Bangalore in 2004 along with my brother Sandeep. We saw that there was a huge construction activities going on
I
in and
request
around
Dr.
Silicon
Vishal
City.
Tombre to please join
As a
us on this.
curiosity, we visited and observed that there is a lack of quality steel. Hence, the idea began to making the steel.
Can you play it at 2x the speed video?
No, it was our chairman and managing director, Mr. Sunil Kumar Jalan, the co-founder of A1 Steels India Limited, who made a presentation. He was just talking how we came down to Bangalore, and then he found out what is the requirement of good quality of TMT bars. So what we, as I already explained to you, that we are manufacturing in 5 manufacturing units, and with the cheap availability of power what was available in Hindupur, which made us to made inroads from 4,000 tons to around when we manufacture 70,000 tons. And Mr. Sandeep Kumar Jalan was again talking about this Hindu power plant and the capex, the investments what was being made in different units, 5 manufacturing units, where we kept on improving from billets, blooms, and then rebars and MS pipes and coils, and now with the metallurgical coke using coking coal. And we have the CEO, and who was appraising about all the product facilities and other functions. It was me who were talking about the approvals which we have received in different areas like water desalination plant, then NHA, roadways, highways, then CRS we are very strong, and we make, we supply to various government companies. Anyway, we are running short of time. In fact, we have to condense, and we are not very elaborate also. Okay.
I request Dr. Vishal Tombre and Dr. Nagendra to please join us on the stage to do the honors on behalf of the Indian Concrete Institute. We are deeply indebted to the esteemed corporate, A1 Steel, for everything that you have done for us. Manoj ji, aap aaiye please. Thank you so very much to the A1 Steel team. Ladies and gentlemen, please applaud our sponsors. And we cherish all your support and encouragement for the conduct of ACECON 2025. Now may I request the Chairman and Managing Director of RDC Concrete, Sri Anil Vanchorji, to please come over to present his corporate achievements. Thank you.
Sir, small request, please let us support sponsors. They are very important persons for any event. So I request all of you, please sit down for just another 15-20 minutes, 15 minutes maximum. We'll finish it and all of us will go to have coffee, tea or lunch, whatever you like. Please support. Please bear with us, please.
Good afternoon, everyone. We are already late by schedule. I'll not take much time, but I'll focus on key things which we are doing. Okay. RDC Concrete is the largest independent ready-mix concrete company in India. It's non-cement based, and since 1993 we are here. The first commercial plant in India was started by us in Mumbai. Okay. At present, we have got 142 plants, 6 cities, 21 states, growing at the rate of 25 CAGR. We have 2 subsidiaries called Ultrafine Materials, and second is the RoboSilicon, which is also a very old company, particularly in Hyderabad. Everybody is aware. And this RDC group has got the Best Managed Company Award in a competition organized by the Deloitte, right? And this ex-chairman of SEBI, Mr. Harish Bijur, and Tata Capital MD was the jury. And we are certified by the Great Place to Work since 5 years. And also we have got a distinction of having the best among 5 brand in the cement and building materials in last 2 years. And also the best great mid-size company in top 50, we are there. This is the Economic Times Award and the best brand. And we are doing around 5 lakh plus cubic meter concrete out of 140 plants. And we are present in so many, cities. Earlier, the name of this company was Unitech Prefab Limited. And the later on, when the equity went to Singapore, name changed to RDC Concrete India Private Limited. So we are having distinction of IT-enabled processes, right from the raw material receiving, from the unmanned way bridges to delivery challans, and all trucks are monitored with the GPS system, and the customers can see where is the location of the truck, and also it also indicates whether the unloading has been started at the site or not on the truck, and what is the total unloading duration. So customer can control the quality at the site, and he can check what are the critical issues happening at the site, why the delay in unloading of concrete is happening. And all these data is there in the RDC track, which is forever in the cloud. And customers, whenever they want to see a particular issue with the particular truck, they can see the details in that particular track, RDC track. Okay, these are our value system, and which we represent, I deposit, integrity, positivity, safety, with the pictorial representation. And this is the map where we are present, and we are growing at around 38% CAGR in last 4 years' time. These are our customers, very unique, routine things. And this is our team, which is managing the, concrete business as well as the robo business. And all raw materials, which is very, very important, feature, because unless we control the quality of the raw material, quality of concrete will not be good. So we have focus on the raw material quality. And we have got Center of Excellence in Mumbai, where all innovative products are there in the display. And R&D center is also in Mumbai, which is developing new products. One of the product is the pothole repair solution, which you can lay in the road in the pothole, and within 5 seconds it will set. That kind of product we have. Quality assurance, which is routine, and these are the unique products we have for special products for each special applications. And we also develop, apart from this, based on the customer needs, we keep on developing new products. These are our product list. These are ultrafine materials, ultrafine slag, ultrafine flash, microsilica, and pothole repair solution. These are products from this. Okay, and the robo aggregates, plaster sand, which is available in Hyderabad, plus other Bangalore, Chennai, and other cities as well. This is, I would like to highlight this part. We are talking about the skill development, but very few companies are taking action on this. This academy we are building in Karjat in 2-acre land, where we are going to train people and we are also going to give them a stipend for the training during the training period. It is a free residential program for 6 months for the field technicians and other batches. And these people, once they are trained, it will be absorbed by the industry. This is our PUS, which is our CSR program. So RDC is doing CSR only in the underprivileged school children. This is one of the program in the school where RDC is doing that. This is the National Cube Test competition which we started with the ICI. This is to give hands-on experience to the students and also to give opportunity to construction professionals or who are working in the field of concrete. Here M30 grade concrete was to be made by the student category, and the 4 regions we have got awards. 1 lakh rupees award for the winner team, 50,000 for the runner-up. And the expert category is the M100 grade, professional category they have to make M60 grade of concrete. So recently we had done this program in the SRM University. The award function was there. That's all from my side. I think I am in the time. Thank you very much.
Thank you, Dr. Anil Panchordi. May I require Dr. honors on behalf of the Indian Concrete Institute. Thank you, Dr. Anil Panchordi, for supporting us at ACECON 2025. And he also happens to be our GC member and a very active member at that. Ladies and gentlemen, please give a loud applause to our sponsor in RDC Concrete. Thank you. May I request the team from Maha Cement to please come out to the dais and make your pitch. Thank you. Thank you, sir. This is forward, this is back.
Just forward only, forward, right.
Respected speakers, distinguished delegates, and organizers, good evening to everyone. On behalf of Maha Cements, it has been our privilege to be associated with ACECON 2025, the event that stands at the forefront of innovations in concrete, in the field of concrete, and also excellence in concrete. I am not going to talk about the properties of cement and all those things because you are all well familiar with the cement because day in and day out you are working with the cement. So I don't want to touch upon that. I wanted to just present to you about the group and its capabilities and what is its intentions to grow further. Our group was started in the year 1981 by a homeopathic doctor. It is very peculiar. A practicing homeopathic doctor has entered into the construction, and within a short span of time, he earned the reputation of a good builder and reached one of the top positions in the construction landscape in the residential segment and commercial segment here in the city of Hyderabad. On earning the reputation as a builder, he got into the cement industry in 1998 with a tiny plant. The capacity of the plant at that time was 0.2 million anything. Now the capacity has reached to 12.5 million tons. All this has become possible within a span of 27 years. It indicates the trust reposed by the discerning users in the brand. We are operating in 6 diversified businesses, which have been shown below. And our chairman has been awarded a Lifetime Achievement Award for the contributions he has made to the real estate segment in the state of Telangana. It was awarded by the then Governor of Telangana, Tamilisai Sundararajan. He is not only a businessman, he is fond of spirituality and also health and education. Here in Hyderabad, one of the landmark projects, Statue of Equality, is the project wherein our chairman has associated, and he was the backbone of that project, I can say. Now, the group is being run by young and dynamic leader, Mr. Ranjit Rao, who is the son of our chairman, and we are also now growing across the geographies. These are the different segments, these are the different businesses we are operating in, starting from real estate, cement, power consultancy, logistics, education, media and entertainment. For all those Indians who are here, TV9 is very familiar. The TV9 is owned by our group. And also the OTT platform AHA also belongs to us. These are some of the statistics about our group. So we have 15,000 plus employees and 40 years of rich legacy, revenue of $1 billion and operating in 6 segments. As I said, the cement business was started in 1998. We are operating 3 plants, 1 in Telangana and 2 in Andhra Pradesh. By the end of next year, we are coming out with 1 more plant in Orissa with 3 million ton capacity. My Home is a trusted brand which has been contributed to many of the construction landscape in India across the states, across south, central and eastern regions of India. These are the plants and also the area being operated by My Home Industries, and Maha Cement is available across all these locations. We have more than 80,000 dealers through which we are supplying the cement to discerning users. As I told, we have 12.5 million ton capacity coming from 3 plants. We have a wide range of products starting from OPC, 43, 53, PPC, PSC, and also GGBS. These products cater to the diverse needs of the construction industry, starting from high-rise buildings to the infrastructural projects and to the structures that has to face the harsh environment in the coastal climates. We have state-of-the-art manufacturing facilities and also testing facilities. All our labs are NABL accredited. We understand the cement better than others because we ourselves are the builders. So we know what should be the characteristics of the cement to produce different grades of concretes, different types of concretes. We have completed 25 projects, all skyscrapers, almost 40 million square feet of the construction was completed by us. So another 10 projects are going on at this point in time. Just before concluding, I would like you to watch a small video of just 2 minutes. Please pardon me, this has been shot in Telugu.
త్వరగా కానివ్వండి. ఏంటి సార్, ఏం ఆలోచిస్తున్నారు?
సిమెంటు టాప్ క్వాలిటీదేగా.
నాతో రండి సార్.
ఇదే సిమెంట్తో కట్టారు సార్?
మహాతో సార్.
ఓ,
ఇదిగో ఇటువంటి మెట్రో స్టేషన్లు కూడా
మహాతోనేనా సార్?
ఈ పెద్ద బిల్డింగ్స్ కూడా మహాతోనే సార్. చూడండి సార్.
వావ్,
మొత్తం మహాతోనే.
పెద్ద పెద్ద ఎయిర్పోర్ట్లు కూడా మహాతోనేనా?
అవును సార్, పదండి మీకు ఇంకా చూపిస్తాను.
వద్దు, అర్థమైంది. దేశం ఏ సిమెంటుతో నిర్మించబడుతుందో అదే సిమెంటుతో మన ఇల్లు నిర్మించుకోవాలి. ఇది నిజం.
మహా సిమెంట్ మంచి నాణ్యత కలిగిన లైమ్ స్టోన్ తో తయారు చేయబడింది. మహా సిమెంట్, మహా ప్రతిష్ట, మహా పనితనం.
Yeah, it says that Maha Cement was used in the prestigious projects like highways, airports, seaports, etc. We are honored to sponsor this ACECON 2025, and I sincerely thank the organizers for giving this opportunity to us. Thank you very much. Looking forward to grow the construction together. Thank you.
Thanks to Maha Cements team for that Maha support to us, sir. And we really cherish that. To do the honors, may I request Dr. K. Jagannath Rao Garu and Engineer DVS Raju Garu to quickly come out to the stage to do the honors and convey our gratitude on behalf of the Indian Concrete Institute.
Sir, small request, Dr. Ramachandra, President ICA, please join with our team, Prasad, of course. Hey, in good one. Idi. No.
Thank you once again to Maha team and to the audience for that good applause. Now, may I request the representatives of Newtech Equipments to please come out to the stage. Newtech and Mr. Daniel Aldred, the Associate Director of Cemented Newtech Equipments. Request you to please make the business development pitch. Thank you.
Come.
This is forward, this is backward, this is... Okay.
Introduce yourself.
Very good, yes.
For 3/4 of a century, one company has been dedicated to resolving...
Hello everyone, very nice to be back in India, and it's nice to see some familiar faces from the last time I was here at a concrete event. So my name is Daniel. I represent Cemented, which is a company founded by my grandfather in Australia more than 70 years ago. And he created a product which hasn't changed in 70 years, and we have a track record of waterproof and durable concrete that still exists today throughout Australia and now throughout the world. So we've expanded globally, and we've been in India for over 10 years with our distribution partner here, Newtech, represented by Mr. Vijay Naidu, who is over here, and he's at booth number 1 if you'd like to learn more about our products. I'm also here with Mr. Anthony Sung, who's over here in the back of the crowd, who's doing a presentation later this afternoon on HPI technology, which is the foundation of our business, which is hydrophobic pore blocking ingredient. It's an admixture that you put into the concrete that makes it completely waterproof, essentially forever. We've had it in concrete for 70 years, and so we're hoping it lasts another 7 years, but we've certainly got the case studies that it lasts at least that long. So 2 things I wanted to say is, 1, we are not a crystallization product. We're the opposite of crystallization. And I know a lot of you have challenges with crystallization and you don't think it works, and you're right, it doesn't work. And so our product is very different to that. And it actually coats the inside of the capillaries in the concrete with a physical pore blocking ingredient that makes the concrete completely waterproof. So important to note, it's not crystallization. You can use completely membrane-free concrete without crystallization with a product that actually blocks the capillaries, and be confident that the product will work. And the second point is a lot of people think our product is very expensive, but we do have 5 different grades of our HPI technology. So no matter the project, we've got a solution that may fit the budget for the project. So I might hand over to Vijay, who's going to play this video, which gives you an introduction to our business and what we do. Thank you.
A singular, massive challenge within the construction industry. In this overview, we explore Cementate and its mission to fundamentally re-engineer concrete, the world's most common building material, from the inside out. This journey began with a simple yet powerful realization from our founder, Peter Aldred. He saw that concrete is absolutely essential, but it is also deeply flawed. His primary objective, right from the start, was not just to sell a product, it was to build reliability into the very stuff we use to construct our world. Cementate first began its work way back in 1946, down in Australia. Today, that same system is backed by more than 50 years of proven real-world performance. The fundamental problem driving this innovation is simple. Concrete is inherently absorptive. This natural flaw, technically termed porosity, lets water and damaging salts just seep deep inside the structure. Porosity leads to corroding rebar, disintegration from salt and chemical attacks, and forces the use of temporary membranes that often fail. If the problem starts inside the concrete, the real solution must also work from the inside. The Everdur Kaltite system fundamentally changes the concrete itself. First, a hydrophobic action makes the concrete matrix repel water. Second, a pore-blocking action uses tiny polymer globules to physically and permanently plug those capillaries. Kaltite concrete is non-absorptive, an integral solution, and is corrosion-proof by design. It represents a fundamentally different class of material. For any architect or engineer, the ultimate benchmark is evidence. Over 50 years isn't merely a statistic, it signifies a substantial track record of achievement. This durability stands strong against the absolute harshest environments. Critically, it is backed by third-party validation like BBA approval. This proven durability translates directly to your projects. For basements, it means no tanking and faster construction. For roofs, it means a trafficable, maintenance-free slab. In marine environments, it provides total immunity to chlorides. The Everdur Kaltite system provides totally effective integral waterproofing and corrosion resistance built into the concrete itself, without membranes or built-up treatments. This results in superior performance with major savings in both time and cost. Our network gives you local expertise on a global scale. This returns us to our founder's credo. It is a promise that has been honored for more than 50 years. By fixing the material's most fundamental weakness, we unlock a whole new level of durability and long-term performance.
So thank you very much for having us, everyone. I'm here for the next 2 days, so if you wanted to chat about what we do, please come and see me, but also you can come to booth number 1 where Vijay and the team will be. And please come along to Anthony Sung's presentation this afternoon to learn more about HPI and how it compares to crystallization and membranes and other alternatives for waterproofing and durable concrete. Thank you.
Thank you, Mr. Daniel Aldred. We thank you and your team for supporting us. May I request you to please move on to the center stage. May I request Dr. Venkat to please come out to the dais and along with Engineer Manoj Kavalkarji to do the honors and convey our gratitude.
Sir, VP South.
Dr. Nagendra is here? Yeah. Sir, please join us. Mr. Daniel, you can ask your team to join you in case they are here. Mr. Daniel's team can join Mr. Daniel on the stage. Ladies and gentlemen, please give a loud applause to our distinguished sponsors for all your support. Thank you. Thank you so very much. Now may I request ECMAS Construction Chemicals to please come over and please present your deck.
1 minute. Sir, before that, we want to invite Nemi Bhantia, sir. just when we were felicitating them, you went out. Please come, sir, just 2 minutes. Please. I request Professor KVL, sir. Here. Please come on to the desk. And I request Dr. Kalgal, sir, Dr. Ramachandra, and VP South, VP West, all ICA Hyderabad Center, and President-elect Manoj Kavalkar. Please come on to the dais. And there is only one presentation. After that, all we will go to have lunch, Hyderabad biryani. Please bear.
So that's our speaker, Dr. Hamid Bansia, from all the way has come from Canada. And we really convey our deep gratitude and thanks, sir, for sharing that very erudite views that you have been discussing in your papers as well. Thank you so very much. Thanks to our lovely audience also for that loud applause. Thank you, sir. Now may I request the team from ECMAS Construction Chemicals to please come out to the stage.
Good afternoon, everyone. I am glad to introduce ECMAS Group, who originated and started its journey from our own Hyderabad. Then we grew in South India, then nationally, and now we are operating internationally. So, ECMAS started its journey more than 4 decades ago. We offer more than 180 plus solutions to the construction industry and manufacturing industry. And we have more than 1,000 satisfied and regular customers. Almost various type of manufacturing and construction industry partners. We have been working very closely with infrastructure projects, real estate projects, industrial projects, and manufacturing sector. ECMAS is known for its resins. When ECMAS started its journey, it started offering polyester resins and fibers to produce high quality fiber reinforced polymer FRP. And we have been supplying our world-class solutions to various industries that includes railways, defense, space sector, space research organization, shipbuilding, windmill manufacturing, even tank and pipe manufacturing. Other than this, there are hundreds of applications where FRP is being used, and we have been a regular quality supplier of our resins and fibers. Coming to business divisions, we operate under 3 divisions: ECMAS Resins, as I already briefly introduced, ECMAS Construction Chemicals, ECMAS Orange, and we are With You Foundation. Our resins are sold under brand name Acmalon and fibers under brand name AMAC. So it includes unsaturated resins, vinyl ester resins, and biophenolic resins. Coming to construction chemicals, under this division, we hold multiple technical tie-ups and collaborations with partners from various parts of the world. That includes partners from Netherlands, Italy, France, USA, Korea, and Japan. And we offer end-to-end solutions to the construction industry. Some of the cutting-edge technologies we have introduced, some of the very innovative technologies we have introduced to the construction industry, I will be talking about them briefly. But basically, we are a technology-driven company. We invest a lot, we focus a lot on R&D. We have collaborated with multiple scientists and academic institutions and research bodies to support researches and to commercialize upcoming technologies. Some of the technologies, even like self-healing concrete, we were among first who introduced this technology in Indian market. That technology developed by Professor Henk Jonkers, Netherlands. We were among the first. Then other technologies called FRCM, fiber reinforced cementitious matrix for structural strengthening. WBD technology, it's a technology which imparts life to the structures. We will be talking more about this technology in our session in the evening. Coming to overall product range or solution range, we have very wide solution range that covers concrete and cement additives. We offer quality solutions to produce high grade, high performance and ultra high performance concrete. It includes curing compound, it includes deshattering oils. Coming to waterproofing solutions, very wide range of waterproofing solutions starting from very basic cementitious coatings, integral crystalline solutions, liquid applied membranes includes cementitious, acrylic, polyurethane, polyurea, all top high-end technologies, WBD solutions. Then solutions for construction joint treatment, solutions for expansion joint treatment, various kind of protective coatings, thermal insulation systems. Then cement and chemical-free soil stabilizers, synthetic structural fibers. So it's a very wide product range which we are offering to the construction industry. What is our core strength? Although our thrust is on Make in India, but we collaborate with a lot of partners from various parts of the globe. And our one of the key strength is polyurethanes. We have been one of the pioneers who invested in this technology. Polyurethane nowadays is being used in multiple applications that includes waterproofing membranes, polyurethane injections. Even the biggest players have not invested in manufacturing in India. But ACMAS is one of the company who has invested in producing these solutions in India, and we are exporting these solutions to almost 25, 27 countries from India. We have been proud to be associated with some of the signature projects that includes railways, metro rails, airports, real estate projects, dams, highways. These are some of the regular clients who have patronized ACMAS solutions. We have been regularly working, that includes almost all type of real estate developers and construction companies. Talk about the government bodies and institutions, we have been working and we have been approved and specified by various government bodies in multiple projects across India. ACMAS Orange, that is the company recently promoted to cater the retail and distribution market. So far, ACMAS was focusing only on projects, but recently we have started focusing on retail and distribution through our company, ACMAS Orange, under brand name Extra. Then, towards our corporate social responsibility, we have a foundation called We Are With You Foundation that supports underprivileged categories through our program Aksara. They support education of the underprivileged sections of the society, and we help in acquiring good education. Thank you. Thank you so much.
Thanks to ACMAS for your support, sir. May I request Dr. Venkat to do the honors on behalf of the Indian Concrete Institute. Ladies and gentlemen, please give them a big applause. May I request Dr. Kantarao also to please join them on the stage, please. Along with Dr. Kantarao. Ladies and gentlemen, please give them a big hand once again. Thank you so very much. Now may I request Pidilite Industries to please make their business development presentation. Thank you. Pidilite Industries? Yeah.
So, good afternoon, everyone. I think this is the last presentation from the sponsor side. Oh, second last. Yeah, so I'll not take much of a time. Regarding Pidilite Industries, so everyone might have grown up using a product, white glue, which is Fevicol, which many of you might be knowing. So that is one of the product or the brand names of Pidilite. So Pidilite has now also ventured into the construction industry, understanding the needs of the laborers, the workers, as well as the users and the need of the structure. So for waterproofing, we have Dr. Fixit. For flooring solutions, we have Dr. CP, and then we have Roff and Tenax for the tiling and stone solutions. So overall, if you see, Pidilite owns more than 25 brand and is into many countries, and it has got roughly around 70 manufacturing units in India itself. And so in India, Pidilite runs 3 R&D centers, which is owned itself, and also 5 centers which are out of India in Singapore, Dubai, Brazil, Thailand, as well as in USA. So continuous R&D, new product development goes on with Pidilite, and we are into construction solutions. We provide the solutions which is required for the construction industries. We have a small video AV which would say our PPS group, which is the professional solution provider, wherein we have 24/7 help desks, which as per the requirement of the structure, there are BOQs, method statements, drawings, which can be utilized by architect, consultants, or the designers. Everyone knows how to design the concrete. Everyone knows the behavior of the concrete, but leakage and arresting the leakage as well as reducing the crack or making a crack-free concrete is totally difficult, and which is not possible physically because of changing environmental condition as well as the workers and the labor force which applies or which produces the concrete over there at the site. So protection and having a good quality of waterproofing products, that's the need of the hour to prevent the structure from deterioration or damage. So we have a small AV. Please run the AV, which would say
Some design sketches never turn into reality. Not because there was something wrong with the design, but because the imagination did not get the right partner who could turn the sketch into a landmark. Architects dream without limits, yet site compromises often lead to stifled design and creativity. When design is bold and ambitious, Pidilite Professional Solutions steps in as the partner who transforms vision into reality. Backed by 65 years of trust, blending category-leading brands with seamless execution. Our world-class solutions offer you freedom to design without compromising your vision. For hospitality, residential, commercial, infrastructure, and more. From raft to roof, from podium to facade, from construction to interiors. Our expertise has been trusted in high-profile and high-stakes projects across sectors like hospitality, residential, commercial, healthcare, educational institutions, industrial, infrastructure, government, data centers. But systems alone aren't enough. We safeguard your vision through integrated services across the project lifecycle with a dedicated team of experts for all your construction and interior solutions. Customized detailing at design stage by providing specifications including BOQ and tender-ready estimates with 24/7 Tech Help Desk. Aiding superior execution and keeping you informed of project progress. Certified partner applicators across India. Plus, our in-house expert, waterproofing contractor, Nina Percept. And post-handover, we ensure performance lasts a lifetime. With us, you don't just get products. You get confidence from sketch to site, from handover to years beyond. Pidilite Professional Solutions, enabling bold designs,
So thank you. So for more details regarding the products, we have a stall. You can visit. We have few of the samples as well as we have the soft copy of the brochures for the products that we have for construction solution. Thank you.
We really appreciate all your support from Pidilite. ये मजबूत bond है and ये तोड़ेगा नहीं. So we request you to continue your support, sir. Please move on to the center stage. May I request Dr. Venkateshwar Rao and Engineer Manoj Kavalkar ji to convey our gratitude and token of thanks to Team Pidilite.
Sir, we request Vinay Gupta ji and Anil Banchori sir, GC member, please come on to the dais and felicitate your colleague and our great sponsors.
Thank you. Thanks to Vinay Gupta sir and Anil Banchor ji through the Pidilite team. So ladies and gentlemen, please give them a big hand. Thank you very much. And now may I request the team from ACECON to please come over and make their business presentation. Thank you. We have two mobiles here. Probably it belongs to the presenters. Unless they are generous, they can take it back, please. It will be here.
Sir. Sir, one secret I wanted to share with you, sir. Till Sunday evening, we got calls from sponsors. See, Dr. Rao, we are with you. Can you allow us? Like that, they called us. For the last 1.5 years, we worked like anything, me, Manoj, and Vinay Gupta sir, and other team members to mobilize good sponsors. So, we'll have to honor them. Just only 5 minutes, we all will go to dinner, lunch. Thank you. Sir, I too love you. Thank you.
Thank you. Good afternoon, all. So here I am representing ACECON Group. So ACECON is formerly known as Utracon Structural Systems Private Limited. Now ACECON Group having 4 verticals. So ACECON post-tensioning systems and ACECON Geo, which is dealing only diaphragm wall design and execution and ground engineering related things. And we are having ACECON couplers. We are involved in couplers, and we are there in retrofitting related jobs, which is post-tensioning floor plates retrofitting related things, and we are there in execution of infra also there. And I will request to play a video which shows our profile and our credentials and some of the signature jobs. Sir. Video please. Sir. few more are there. So these are some of the structural changes. So after construction in the post-tensioning slabs. We are there all over India actually in building sector and ground engineering and retrofitting related things and execution of infra related things. So thanks for this opportunity. Thank you. And I will request my team to be there.
Now I request Venkat Garu, Chairman, ICI Hyderabad Center, along with HR Girish, Chairman, Indian Concrete Institute, Bangalore Center, and I request Secretary Kantarao Garu, Organizing Committee, ACECON, to join. And I request K. Jagannath Rao Garu to come onto the dais and join them.
Only 2.5. Only 2.5.
May I request the AV desk to play a very quick video about Sagar Cements, please. AV desk, please. AV desk, please. Please play the Sagar Cements video. It's a video about Sagar Cements and Green Vibe Concrete.
Sagar Cement, building dreams, crafting future. Every bridge, every dam, every school, every hospital, every stadium, every runway, every home, built on the unshakable foundation of quality, durability, and trust. For 44 years, Sagar Cement has been the foundation behind India's dreams. Every bag crafted with the finest materials for unmatched strength, durability, and trust. Our cutting-edge Robotech lab ensures 24/7 automated quality checks powered by AI and robotics to deliver consistency in every batch. With an annual capacity of over 10.5 million tons in 6 modern plants across Telangana, Andhra Pradesh, Madhya Pradesh, and Odisha. We serve builders in 10+ Indian states and are expanding. Our mobile technical vans and expert supports teams ensure the right mix, proper advice, and correct results on site every time. But what truly defines us is stability in our product, our service, and our vision. Backed by 2,500+ professionals, we drive innovation with responsibility. Award-winning and sustainable practices trusted across generations. At Sagar Cement, we don't just build structures, we make the future. Sagar Cement, trusted for generations, built for the future. Sagar Cement, solid home.
Next video on concrete sensor, please.
Every year, 18 billion tons of concrete are produced, yet inefficiencies and waste lead to significant costs in time and money, while also increasing carbon emissions. Much of this waste can be eliminated with the right concrete data. Green Vibe technology offers the only direct, multi-sensing, real-time solution for concrete data, enabling faster, smarter, and more sustainable construction. Our IP-protected ultrasound technology and multi-sensing platform revolutionize concrete management by providing real-time strength measurements and long-term monitoring. With Green Vibe, you receive precise, real-time data on concrete strength and quality, eliminating guesswork for engineers, contractors, and developers. 20% reduced carbon emission, 25% shorter concrete cycles, 15% lower concrete costs, on-site concrete quality assurance, damaged concrete alerts within 48 hours of pouring, continuous long-term monitoring for structural health. As the only platform offering continuous monitoring, we ensure structural health throughout the project lifecycle. Operating in the USA, India, and Europe, Green Vibe is ready to elevate your construction journey to new heights. Join us in building a more resilient future.
Good evening, gentlemen. This is concrete sensors, which is being used in US and Israel. Many projects they are already using it. Real-time concrete strength you can see, even temperature also you can monitor. So they are talking about modulus elasticity measurement also and porosity also. That is in a research level. You can visit our stall 58. It's a very detailed oriented, because of the time constraint only video has been played. So you can visit, and there is brochures also which can give more details about that. Especially it is used in PT slabs where time constraints are there. Timing of the strengthening is very important. So these sensors are playing a very crucial now. These are AI based. This works in 5 different principles. Sagar Cement is having a joint venture with them. We are a 45 years old company with, as you saw in the AV, robotic lab, XRF, XRD, very advanced testing equipment facility. Even that also you can see, who are doing any PhD, you are welcome. Our plant is open. You can do that analysis also. So wonderful lab also. To know more about Sagar also, you can visit the same stall, 58. Thank you very much. Thanks a lot.
Thank you to Sagar Cements. Kindly move on to the center stage. May I request Dr. Ramchandra, Dr. Venkat, and Mr. Manoj Kavalkarji, Engineer Edukondalur, and Jagannath Rao, Professor Jagannath Rao, to please join our team on stage to do the honors of Sagar Cement. Thank you, Sagar Cement team, for the support that they have lent us in organizing this particular August event of ACECON 2025. Ladies and gentlemen, please give them a big hand. Thank you so very much. I would like to announce that the sessions that were there in the Golden Mile will be held in this particular auditorium. And before we break for lunch, we have 1-minute video of L3C conference. I request the AV team to
the 17th edition of the prestigious International Congress on the Chemistry of Cement, ICCC 2027, will be held in New Delhi, India. The 17th ICCC is being organized by the National Council for Cement and Building Materials in collaboration with IIT Delhi and IIT Madras. The theme of ICCC 2027 is Achieving Sustainability and Carbon Neutrality in Cement and Concrete. The Congress will take place at the state-of-the-art Yashobhumi Convention Center in New Delhi. The call for papers is now open. Researchers, academicians, and professionals are invited to submit abstracts. The last date for abstract submission is 31st January 2026. Abstracts can be submitted through the official website iccc2027india.org or through the ICCC 2027 mobile app available on the Google Play Store and the Apple iOS Store. We look forward to welcoming you to New Delhi for the 17th ICCC 2027, a landmark global event shaping the future of cement and concrete.
Thank you so very much. I request the speakers of the next session that are here to please give your presentation to the AV desk and please come back within 30 minutes. So ladies and gentlemen, we break for lunch. 30 minutes from now, we will assemble back. And 30 minutes from now, we are at 1:50. We'll be here by 2:20, please. Thank you. The lunch is being served behind the exhibition stalls, the same lunch venue that was there yesterday. Please join us for lunch. Thank you. The gentleman over there in the audience, sir, can you please turn around? The gentleman there, please. Can you please turn around, sir? So that we respect the chair and you can please participate in these particular discussions that will happen. Thank you. Over to you, sir.
Thank you, Mr. Girish. Good afternoon, all of you. Good afternoon. So this session was actually supposed to be before lunch, but since so many activities were there and it was postponed to, post lunch, and we too have a lot of, presentations in this session. Okay, no problem. Thank you. So, actually, before lunch also very difficult to handle the session as a chair, because you will be in between lunch and, session. But after lunch also is very difficult after having biryani, Hyderabad biryani. So, therefore, I'll try to make it, little positive way so that you can all enjoy the session. Okay? We have with us today Professor Prasad Rangaraju. He is from Clemson University, USA. So I invite him onto the dais. He is initially an employee at some other organization, research organization, that is before joining Clemson University. Dr. Rangaraju was a senior research engineer at Office of the Materials and Road Research in Mancina, DOT. And later on he joined in Clemson University. He is a researcher and then, guide, mentor for several research scholars. And he did research in a very good area, concrete microstructural analysis. And today he will be delivering a lecture on performance evaluation and majestic insights into rapid set cementitious repair system for bridge decks, environmental sensitivity, substrate interaction, and then construction methodology. So I invite him for this presentation, keynote presentation, sir. So mic to you. Try to complete your presentation in 25 minutes.
I will do my best to go through. Again, thank you all for inviting me to this conference and giving me an opportunity to present. And it is particularly very heartening to me because I'm a local boy. I'm from Hyderabad. And putti perigi chadukoni. I'm in the US now, but I'm back to give this presentation. I'm very happy to do that. So considering that we don't have a whole lot of time, I will try to go through this presentation a little fast. I'll save some time at the end for some questions. I'm glad to answer any at that time. All right, so today we're going to talk about the performance evaluation and these mechanistic insights into rapid set cementitious materials systems, particularly for bridge decks. And I have to say something at the beginning of this talk, even before I get into the presentation, which is, if you've seen all the presentations so far in this conference, much of it has been sort of very futuristic in dimension, right? We're kind of really doing great things. We're doing stuff that is probably not at full scale at the moment. And again, the emphasis here is all on sustainability, reducing carbon footprint, and all of that. So I'm going to take a little different approach in that all of what has been talked about, the new materials, new systems, it's all great and needed. But we have a lot of infrastructure at the present time. If we can save it from damage and deterioration and preserve it for a longer time, that is the best way to attain sustainability. So I'm going to focus a little bit on existing structures and how to do it right, what we are not doing it right. And I'm going to give you a perspective of what is happening in the United States. And that also gives me another pleasure to kind of always compare US and India because the physical infrastructure in the United States, vast majority of it has been there for a very long time, right? 50, 60, 70 years. India certainly has structures, but there is a lot of new construction that's happening, that is growing. So India will be in the same situation as the US is currently. Probably in the next 30, 40 years, you'll have a lot of bridges, structures, everything that is aging and start deteriorating. What do you do? So I'm going to talk about, share some experience from US. Okay, just to give you a little outline of the presentation, I'm going to quickly talk about some background, why the need for this research, what we are doing, some objectives, some experimental testing, matrix, results discussions, and some conclusions. Again, pardon me if I go through some of these slides very quickly in the interest of time. So first of all, I want to give you a little bit of a statistics in the United States about bridges in particular. I'm going to focus on bridges, although a concrete infrastructure is very wide, right? So this is, we have what is called as a National Bridge Inventory that actually maintains a very beautiful database of all the bridges in the US and a periodic update on the condition of these and how many bridges are in what different states. So here is a little tabulated information of the bridge infrastructure in the US, which basically divides all of the bridge infrastructure. Let's see if I... So there are about close to 615,000 bridges on major highways in the United States, a lot of bridges, right? So let me go back here and tell you what is the condition of these bridges in terms of their performance. The bridges roughly about, 44% are in good condition. The ones that are in fair and poor condition are more than 50% together, right? Because these bridges have been built a long time back and they are gradually deteriorating. So there is a significant interest in preserving and maintaining these. And some of these, about 6.8% of these bridges are structurally deficient bridges. So these are actually quite hazardous in terms of the existing condition, and they need to be fixed immediately. So I want to draw your attention to one statistic in this table here, which is that the average age of good condition bridges is 32 years old. Right? Again, the bridges have been there for at least 60, 70 years and more, but the average age of bridges that are considered in good condition is about 32 years old. The average age of bridges that are deficient, structurally deficient, that need to be repaired is 68 years old, right? Really the old bridges, they need to be fixed. But if you look at the bridges, the vast majority of them that are in the fair condition are 54 years old. So a large number of bridges in the United States are more than 50 years old. And these are the ones that are gradually degrading, deteriorating, and they need to be repaired. And there are about 615,000 bridges at the present time, so that's a lot of infrastructure to be repaired. So, it was interesting to see one of the previous presenters show the climatic region. I want to show you here what it is in the United States. United States is a very large country, very diverse environmental conditions. Everything from, essentially arid regions. This is almost desert-like regions in places like Arizona, Nevada, places like that. You have every combination possible. The Florida, some of you may be more familiar with some of the more known places like Florida. This is hot and humid with a lot of coastline. So a lot of bridge infrastructure that is exposed to marine environment. Earlier presenter, you were talking about the chlorides coming in. A lot of structures in places like Florida, some of the coastal areas, they are subjected to very heavy chloride presence and therefore obvious corrosion issues and other things. I'm going to particularly talk about the infrastructure experience where I am from in the US, and that happens to be in South Carolina. South Carolina is right there. It is a region that has hot, humid summers with rain, mild to cool winters with occasional freezing rain and snow. So it is everything from snow all the way to a really hot summer. So you have to worry about all types of concrete deterioration in infrastructure, right? So what do we do with bridges? Bridges have many different elements to it. So, typically the substructure, you have the superstructure, which is essentially the deck and the parapet wall, and you have the foundations and all of that. So there are many different elements. But of all of these elements, the one that is subject to most damage is actually the superstructure, the deck on the top, because that is what sees a lot of traffic, that's what sees a lot of environmental exposure, and also deck is one concrete element that has a very large surface area to volume ratio, right? We were talking about plastic shrinkage, drying shrinkage, a bunch of things earlier. So deck is something that sees a lot of shrinkage-related issues, exposure to chlorides from de-icing salts to chloride from salt spray, and especially in coastal regions. So I'm going to focus more on the deck aspects of it. And so South Carolina does a review of its infrastructure every so often, and they put out numbers in terms of the condition and so forth. So within South Carolina, this is the typical rating. That is, there is a rating scale. I won't get into the details of it, but anything, just to go back, anything 7, 8, 9, a good rating. 6 and 5 is fair. Below 4 is poor. So we have bridges in South Carolina. If you look at the statistics, these are different types of bridges depending on the level of traffic and whether it's a federal government, state government, counties, cities, who supports these. If you look at the bridge deck area, these are all in millions of square feet of bridge deck area that has to be kept in immaculate condition. So if you look at all of those statistics, I want to draw your attention to particularly the fair and the poor, because those are the ones that are going to be needing repair soon. So across different types of bridge types, typically about half or more than half require some level of repair in near future. About roughly 5-6% are really in a very poor condition. So these are ones that require immediate attention. So again, I don't want to get into the different causes of distress in bridges, but the reason I want to show you this picture is oftentimes the damage and the repair, they happen in such a way that the repairs are done while the traffic is still allowed to continue on an adjacent lane, right? So here you have a number of different scenarios, but you can see the condition of the bridge decks. Again, these are 50, 60, 70-year-old bridges that need repair. And there is also something to be said about workmanship and all of that. I'm not going to get into those details. I'm going to focus on the repair materials themselves. So lots of different types of distresses, and I've done a lot of surveys of bridges, and you see every different types of distress out there. And some of the distresses are a little bit concerning because these are repairs. For example, in this case, the repair was done literally in the cracking showed up in the deck about 2 to 3 years after it was repaired. So it is not a long-term durability issue also. Sometimes construction methodologies, preparation of the substrate surfaces, all of that play a major role with these repair materials. And also repair materials themselves. If you look at the spectrum of repair materials out there for concrete, there are, you think regular Portland cement or limestone cement is complex. Repair materials is a can of worms. It is a complete potpourri of all kinds of chemistries in there. A lot of time these materials are proprietary in nature, so you don't even know exactly what is in it. And yet you have to work with them. So a lot of challenges. Again, more pictures of different types of distresses and so forth, so I won't get into that. But now here is the challenge in the field, which is selection of repair materials, right? So repair materials have to be selected by engineers, typically at the DOT, and they have to go with it. So there is a very wide variety of materials out there, very limited requirements for material implementation. Generally, strength gain is the primary concern because these are all repairs, so it has to be very rapid, get in and get out very quickly, right? You don't have a lot of other considerations. Strength is the most important thing. Unfortunately, strength is not everything. Durability, lots of other parameters are important, but we can't focus on those. Like I said, majority of the materials are proprietary in nature, so you don't exactly know their composition and you have to work with them. And engineers are really forced to make a cost-efficient solution, which means a cheap product that may or may not work, and they may not even know exact performance properly for that desired location, desired environmental conditions, and all of that. So anyway, that's kind of the background behind what I'm trying to get to. Again, repair is a very complex subject. There are lots of factors that will influence durability of repair. Geometry of the section to be repaired, adequate achieving surface texture, and so forth, moisture condition, whether to use a bonding agent or not, all of that. But probably if everything else is perfect, the proper repair material is one that would be compatible with the substrate concrete such that you get a good bond, as well as compatibility of properties such as electrochemical compatibility from a corrosion perspective, modulus of elasticity, coefficient of thermal expansion, shrinkage, all of these need to match as closely with the substrate concrete, right? So the objective of this study is to kind of figure out what are all the materials out there in the market, how do they compare with substrate concretes, and can we provide some guidance to repair DOTs as to how to select a proper material. One of the big factors in this study is to look at what is the performance of these materials at different times of the year, particularly in terms of temperature, because the seasonal temperature variants are significant, and yet we don't have any data on these repair materials as to how they perform at different temperature levels, right? So we selected for this study a bunch of products from 4 different manufacturers. Again, these are all different repair materials, but different chemistries. We don't exactly know what is in it, but a very broad description of what is in the material MSDS or material safety data sheets that is out there. But I will kind of try to identify these materials in the broadly categorize them into 10 different materials that we selected. These are about 5 of these are primarily Portland cement-based material with very specific chemistries and also set accelerators, things like that, to get really fast strength gain, because these are rapid set patching materials. Then there are a couple of materials that are the calcium aluminate cements. A couple of those are calcium sulfoaluminate cements. One is a material that's based on a magnesium oxide cements, and so you can see the chemistries all over the map. And also their water demand in terms of recommended water dosage is listed there. Again, that's what we simply followed what was recommended for the use. We did a number of different studies, and I'll see how much time I have to even walk through all of these. But the main thing I want you to get out of it is really what is listed here on the side. One of the key things we are looking at is the impact of the ambient temperature on the performance of these repair materials. And we selected 3 different temperatures. Incidentally, US still follows English system of units, so I apologize already because the units that I'm going to show in graphs are all in pounds per square inch, and we use temperature in Fahrenheit and so forth. So at least try to kind of follow as much as possible. So the 3 different temperatures we studied these materials are 50, 73, 104 degrees Fahrenheit. These are, you can think of it as a typical winter temperature, average, and summer temperature. The equivalents in centigrade are 10, 23, 40 degrees centigrade. So you can relate to the local conditions here, what I'm talking about. So we did a number of different tests, everything from compressive strengths to setting times to heat of hydration, ultrasonic pulse velocity, restrained shrinkage behaviors, as well as bond strength, coefficient of thermal expansion, resonant frequency to look at the modulus of elasticity, Poisson's ratio, shear modulus, electrical resistivity, bulk resistivity, surface resistivity, also chloride migration coefficient, a whole host of these on 10 different materials. Most of the testing was done at 3 different temperatures, particularly with mechanical properties that I'll share you with. All right, so the results and discussions, again, like I said, I have a lot of slides, I don't have much time, so I'm going to focus really on comparing results at 3 different temperatures rather than individual results. So the first set of results are all individual tests at 73 degrees Fahrenheit, or roughly about your average temperature. One thing I want to point out here is these are the initial and final set times. Imagine these are rapid set patching materials, right? You got to really get in, get out very quickly. So these times are literally in minutes, right? So these initial setting time, final setting time. If you look at the interval of these are only a couple of minutes, 1 minute, maybe max of 14 minutes, initial and final. So it is a really rapidly hardening system. All of this is at 73 degrees centigrade, or rather Fahrenheit. If you look at pulse velocity of all of these, they follow different trends. Every material is different. You can see here the increase in the pulse velocity, literally within a few minutes to an hour, you see a substantial rise. Again, different materials show different trends. These are all the Portland cement-based materials. These are the calcium aluminate, CSA, calcium sulfoaluminate, magnesium oxide cements. Again, I'm going to kind of zip through some of these results and get to the comparison at different temperatures. Again, this is compressive strength across a range of these materials. We tested them as early as 6 hours, 12 hours, all the way to 7 days. Look at the strength gain. Again, you can see the rate of strength gain is very different across different materials. These are also in KSI, or 1,000 PSI units. And you can particularly look at the magnesium oxide cement. This is very different than others. You have a very low strength early on, but it gradually catches. There's a big jump in strength compared to other materials. This is the bond strength, again different. I'll kind of skip through these a little bit. These are pull-off bond strength, especially these are all important properties. This is the restrained shrinkage ring test. Basically, we cast a ring around a steel and we measure the time it takes for it to crack. And you'll see that the time to crack in days is very different across different repair materials. And some of them, literally this calcium aluminate cement, 2.1 days. It is very rapid hardening, very shrinkage prone, so it'll tend to crack very quickly. So depending on what you use in the field, you may have some of these problems. So this coefficient of thermal expansion, generally this is relatively similar across the board. So and the control, the bulk and surface resistivity, they are very different for different repair materials, and this has implication in terms of corrosion related issues. But you can see that some of these materials are very high in the resistivity and some are on the lower end. And so depending on what you're using, what is the existing condition of the steel, the substrate concrete, if corrosion prevention is important, you got to select the right material with the right compatibility issues. If you look at the comparison between the surface or the bulk resistivity, the chloride migration, we could find that in really across a broad range of materials, there is some degree of correlation between the surface resistivity and the chloride migration. Okay. So there is some correlation, but you can see all these repair materials are very, very different. So here is what I want to talk about, the influence of seasonal temperature. So this is, for example, in Charleston, South Carolina. This is a coastal environment that sees temperatures throughout the year. The min and the max temperature, you can see here how different they are in terms of centigrade and Fahrenheit. So on the low end, we can see as little as about 5 degrees centigrade. On the high end, as much as about 35 to sometimes it even gets up to 40 degrees centigrade. So very high seasonal variation in temperature. So we talk about setting time effect on temperature, or rather the effect of temperature on setting time. So 3 different temperatures. If you look at all the Portland cement-based systems, you will see that the temperature, the 50, 73, and 104 are shown in different colors. You'll see that the initial and the final set time are represented here. So the higher the temperature, the faster the set. So the same repair material in summer will behave very differently than when it's used in winter, right? So you got to be very careful with these types of materials. This is for all the calcium aluminate cements and the calcium sulfoaluminates and the magnesium oxides. You can see the big impact of temperature on the setting behavior. Let's see. This is the isothermal calorimetry. Again, a whole bunch of results. Basically, the idea is that the temperature plays a big role, right? I'm not going to talk about it, but believe me, I have the data. If you have questions, you can come talk to me. But generally, temperature has a big influence on all these properties. Compressive strength, and some of the materials, particularly at very high temperatures, this 104 degrees Fahrenheit or 40 degrees, it is so rapid stiffening that even before we could finish mixing and taking it out and cast the specimen, we can't even cast a proper sample. That's how fast it sets up. You can imagine what happens in the field on a hot summer day if you're trying to use these repair materials, right? So you have all of these issues that you have to deal with. Again, one other thing with any repair job is not only material properties, but the preparation of the substrate, how rough you create the texture, and what sort of impact that has on the bond strength. So again, other properties like modulus of elasticity is very important, because when you attach two materials together, they have to be able to flex in a very similar way, right? So the modulus is very important, but you can see here the modulus is very different across different repair materials. So you have to choose the right material that is with the right substrate. Like I said, the one other thing that we are working on right now is that, like I said, typically these repairs are done with adjacent traffic flowing. So for example, that lane, traffic is going to be on. This lane, they're going to be doing repairs. So there are a lot of deck vibrations that come from this part to this part. At the same time, you're doing the repair. So imagine if you have a very fast setting, shaking it at the same time, you're not going to get a good bond between the two materials. So that is a big control you have to put in terms of deck vibrations and what happens to the bond that you develop between these materials. So we're actually developing a new test method. Instead of pull-off or slant shear, we're actually developing a beam test where essentially we cast these precast beams with rebar, and then we put the repair material on there, and then subject it to a tension test or a flexure test. And you can see that in this video here, basically, depending on what type of failure it is, you get different performance metrics. So here are a couple of examples of how these failures happen. Either they're completely debonded, or in this case, it's very well bonded, and you develop a flexure crack right through because the bond is really good. And we are trying to do this with different vibration frequencies and amplitudes to see what impact this has on the bond behavior, right? So that, I kind of want to get to the conclusions. Basically, the point that I've been making is this ambient temperature extremes have significant impact on these properties, something to be, you have to pay attention to, and also the compatibility across different properties. And lastly, I want to say that there is no single repair material that is suitable for all jobs. Every repair material is different. You have to carefully select and use it properly, right? So we're also doing these studies on these vibration influence on these bond performance. And just want to acknowledge a couple of my students and the funding agency, the South Carolina Department of Transportation, as well as James Roberts and Adam Beal, who worked on this project with me. So with that, I'd like to conclude this and take any questions. Thank you.
Thank you. Thank you, Professor Prakash ji, for giving your Prasad Rangaraju ji, for giving a very insightful and wonderful presentation. And definitely our participant will benefit out of it. But now, since the paucity of the time, we have only 2 questions to be asked. Because we have 6 presentations in this session. So I request the participant to limit to the only 2 questions.
My question is, because this has been field of my interest in my research area, existing sectors, in which I did my PhD from IT at the age of 77.
Okay.
So it is subject of my heart. See, the damages with the age is a universal phenomena. And in India, see, the code changes. We are getting more and more forces, dynamic forces. Existing sectors, what would be your recommendation and experience? Because we feel that existing sectors here needs an extra strengthening retrofit. So what type of retrofit mechanism are the methods you are adopting in your North Carolina area?
Well, what kind of retrofit mechanism we are adopting? Is that the question? So the answer really depends on, because the climatic conditions are very different. It is a partial depth, patch repairs. Sometimes it's a full depth, overlay, complete, cover everything up. So it depends on situation to situation. Right, so that's a whole different can of worms. Buildings are a different thing. Here my focus is on bridges. But selecting the right repair material, proper workmanship is extremely important for, we talk about sustainability, long-lasting structures and all that. Like I said, if you do a proper repair with the proper material and the workmanship, you can extend the service life of these structures significantly. That should be your first step in sustainability, carbon footprint, all of those things. Take care of what you already have. Yes, you have to do for new structures, but take care of what you already have and do properly.
Sir, nice presentation. Sir, my question is there any specific design criteria to select the interface bond shear strength? Most of the repair materials will perform better with a good bond strength. That is the universal phenomenon. Is there any specific design criteria to select an appropriate bond strength for the design requirement?
So, appropriate design criteria. So, if you think of what bond strength depends on, it depends on the surface texture of the substrate concrete, if it has been properly prepared, if it has properly, again, depending, I did not get a chance to get into the details, but different repair materials will behave differently both in a SSD condition of the saturated surface dry condition of the substrate or a dry condition of the substrate. So you have to select a material appropriately. You have to have a good surface texture. You have to have a nice geometry of the repair you're doing. It has to be a properly squared section with sufficient depth. There are lots of factors. There is not one design criteria. There is a whole set of things you have to do. Okay?
Thank you.
Okay, thank you.
All right.
Thank you. You can discuss during your tea break.
Yeah. All right.
Okay, thank you.
Thank you.
Yeah, thank you very much for your presentation. Now we have, with this presentation, we have 6 presentations by different authors in this session. To start with, I will tell you just 2 minutes for question answers and 8 minutes for presentation. 8 minutes for presentation and 2 minutes for discussions. Okay, please limit your presentation to 8 minutes only, not more than that. So now the first presentation is by Shravan Kumar B and Prasad D. Shravan Kumar. So the topic is on study on flow of self-compacting concrete under impending in the form of reinforcement. So by 3 authors, Shravan Kumar, Prasad and D. Ramasheshu and D. Rao. One more author is also there. Come and take your presentation.
Good afternoon, all of you. And myself, my name is B. Shravan Kumar. I'm the research scholar of NIT Warangal under the supervision of D. Ravi Prasad sir and Professor Ramasheshu sir. I'm going to present on the topic of a study on the flow of self-compacting concrete under the impediments in the form of reinforcement. We are all... Okay, these are contents of my presentation. we are all know about the self-compacting concrete. We are also all are familiar about those properties of self-compacting concrete. So these are the contents, and this is my introduction. Professor Hisame Okamura was introduced the self-compacting concrete in the late 1980s. So these are the mechanism. These are all comparison. And coming to my objectives. So in this, the normal flow characteristics of self-compacting concrete we are all know. In this study, I am going to experimental study on the constrained flow characteristics of self-compacting concrete. So under the various specific spacing conditions and as well as various bar diameters, the flow should be how it is affected by the presence of bar diameter and as well as the spacing conditions. So these are my methodology. First of all, we get the SEC mix of M40 grade concrete. So batching and mixing according to the specifications. So initially we do with the slump cone test. After the slump cone test, we have the SF1, which is the flow range of 550 mm to 650 mm. And the second one is the SF2, which has the flow range of 650 to 750 mm. And the third one is SF3. So it is the 750 to 850 mm. So in this experimental study, we do the experimental on SF1 range, so which is 550 to 650 mm. So after that, we go with the constrained slump flow test. So whether the one bar, rebar diameters are there, so the concrete is flowing in that direction. So we have to measure both the perpendicular directions. So after that, the bar diameters 8 mm, 10 mm, 12 mm. So we have 15 trials. By the presence of 8 mm, we go with the spacing conditions of 5 spacing conditions are there. Those are standard we are using in the laboratory. So 30, 60, 90, 120 and 150 mm. So after that, these are the materials used in self-compacting concrete. So cement, fly ash, fine aggregate, coarse aggregate and superplasticizer and viscosity modifying agent. So these are the materials used for the meter cube of SAC, and as well as we are using the high grade fly ash which is on the 55%. So these are the mix ratios and fresh and hardened properties of self-compacting concrete. So this is my experimental setup to do with the constrained slump flow test. So the rebar spacing of it is the 30 mm. So these reinforced network diagram is showing with the 12 mm bar diameters. So these are rebar spacing is the 30 mm and 60 mm, 90 mm and 120 mm and 150 mm. So initially we have to take so this is the specially fabricated slump cone. We have designed for so ordinary slump cone nearly accommodates the 6 liters of concrete. So this will be the which has the dimensions of height of 260 mm and as well as diameter of 220 mm, which nearly accommodates the 10 liters of self-compacting concrete. So in this test, it has the more energy compared to the standard slump cone. And the more probably the realistic conditions, we go for this special arrangement of cylinder. So initially we have filled the concrete in the cylindrical mold. So in this bottom one shutter gate is there. After the filling the concrete, so we have to pull it off the shutter gate. The concrete will be flow through these meshes. After the concrete is flowing off these meshes, we can measure the slump flow value. So initially in the 2 perpendicular directions. So these are my experimental studied observed values. So in this we have tested with the 3 bar diameters, 8 mm, 10 mm and 12 mm. So this is the standard slump cone values is also there, and as well as specially fabricated mold, that is the cylindrical mold is also slump cone values are there. So according to these conditions, we have to observe that the initially SF1, which comes under the 550 to 650 mm, it is not performed under the constraints. It is not performed as the SF1. We have to observe that in 30 mm and 60 mm spacing conditions, it has that it is not performed as the 550 mm. So that's why it is not come under the SF1. And in presence of the 90 mm, after that 60 mm, it is reached to the SF1 category. So that's why we have to test it with the either standard slump cone and as well as modified slump cone. So these are the variation of slump cone, and so how the flow diagram will be varying with the 10 liters of that is a cylindrical mold. So these are the variation with the In this, we have tested with the flowability coefficient is also there. Flowability coefficient and critical spacing terms we are using. So flowability coefficient is the ratio of standard, or the ratio of slump flow value of particular spacing to the slump flow value of the free flow. So, and that critical spacing is that it is the minimum clear spacing to pass the concrete without any obstructions or without any blockage. After the 60 mm, so these are the values we are getting with the interpolation. So dia of 8 mm, after the 60 mm distance, the concrete will be flowing freely. So after the 10 mm, because 10 mm bars, after the 68.57 mm spacing, concrete will be going freely, and 12 mm is also 75 is there. So this is the relation between the critical spacing and dia of the reinforcement. So one another term is also we are using, that is a pitch index. It is the pitch index is the term, it is a dimensional, it is a non-dimensional metric called, so it is in the spacing, dia and critical spacing, that is the relationship between the, so all the parameters we are using. So in this relation we have to clearly identify the how the flow profile of concrete will be varying. So how the dimensions are changing with the flow. So these are my conclusions of my experiment. So it is a constrained slump flow test. In the presence of constraints, how the bar, in the presence of bar diameter and spacing conditions, how it will be changing. So these are the slump flow values, and the nearly modified slump cone has the 1.2 times of more flow energy in the ordinary slump cone. That's why we should evaluate the constraint flow condition in the realistic or site-like conditions in the laboratory. Okay. Is there any?
Thank you, Shravan Kumar. You are on time. I have one question to you. What is the minimum reinforcement that is required for a self-compacting concrete?
Minimum spacing, sir.
Spacing, yeah.
Spacing is I think like 3 times of maximum size of aggregate. So we can take the maximum size of aggregate as the 10 mm. So 3 times of maximum, the minimum spacing we are going 30 mm, sir.
30 mm?
Yes, sir.
Okay. So in case of high strength,
okay,
self-compacting concrete,
yes, sir.
Does the same rule remains?
Yes, sir. But in this experiment, we are only, it is my preliminary study, sir. In this experiment, we are only SF1 is there. The SF2, SF3 is also going to be.
Okay. Now it's time to audience for a question. One question, please.
Is there any basis for this modified cone, because as the diameter and volume increases, obviously the spread increases?
Yes, sir. So it should be, sir, basis per means normally we have to increase the volume of the slump, sir. So just for 6 liters, the standard slump cone is there. So we have to test the more realistic evaluation of the site-like conditions, just more than that volume. So that is it. Yes, sir.
Hello. See, there are many have done self-compact concrete.
Yes, sir.
And you're a research scholar.
Yes, sir.
What is the uniqueness that you are bringing out as a research scholar apart from others, which becomes a unique thing?
Yes.
Because many have done on self-compact
Yes, sir.
concrete.
Many of
What
them
is it that your research paper will not be accepted, isn't it?
Yes.
He is in the preliminary stage, sir. So he is investigating for which reinforcement the self-compacting concrete is suitable. That's what he is investigating. He is in the preliminary stage.
Sir, my motto is that in normal, ordinary like conditions, it will be SF1, SF2, SF3 is performing, sir. So constrained conditions, it is not behaving like a SF1. SF2, we go with the higher grade of slump overlay. For we required SF1, we will go with the SF2. That's why SF1 conditions will become. So
we have other types of tests like L-box test and ring test are there.
Yes.
It's better to compare with these results with other type of the standard slump values of the SEC. Second one is once you are modifying the standard the cone, then the slump values prescribed with the code will also change. Yes. Generally 600 mm is the specified value. Yes. That is correspond to the standard slump value.
Yes.
Once you are changing the slump cone, that also the limits has to be also be changed accordingly based upon the energy that was given to the flow conditions.
Yes.
That is to be also adjusted.
Okay. Yes.
Okay, thank you. Thank you, Shravan.
Thank you, sir.
Now, next presenter is Adagatla A and S. Virender and Prakash SS. The topic is on development of near zero slump ultra high performance concrete mixed design for long span pre-stressed hollow core slabs. Okay? Yeah, please take.
Good afternoon, all of you. I'm Virender. I'm from IIT Hyderabad. So today I would like to talk on development of near zero slump UHPC for long span pre-stressed hollow core slabs. So these are the contents of my presentation. I'll be discussing about ultra high performance concrete and pre-stressed hollow core slabs. Then what's the objective of our research, and basic strategy how we optimize the near zero slump UHPC. Then analysis and design of near zero slump UHPC for precast hollow core slabs. And I'll be discussing about results and discussion, then conclusions. So we all know that ultra high performance concrete having excellent mechanical properties and durability and workability. With these exceptional properties, in what way we can get advantage in elemental level. So this is a bridge constructed in Maharashtra. So UHPC bridge which is spanned about two spans compared to conventional concrete bridge which is having 6 spans. So since we have exceptional mechanical properties, we can increase the span length. So this is the advantage that we are going to get with our ultra high performance concrete. But because of superior properties, its applications are limited to special cases. If I would like to extend these applications to residential buildings, so where we can use it? Precast hollow core slabs, which are having high demand in the precast industry, which is occupying 57% of market value in precast industry. And why? Because which is having hollow cores along the length, which will reduce the self-weight of the member. And why do we need zero slump concrete? Because of manufacturing process of hollow core slabs, which requires a zero slump concrete because of we adopt an extrusion process. And considering these are the objectives of our research. Typically, UHPC will be having high flow, about 220 mm. So considering extrusion process, we need to have a near zero slump, which is about 15 to 10 mm. And so we are looking at a precast hollow core slabs for residential and commercial building applications. And mixed design optimization. So this study is still so these are mixed design which we consider for typical UHPC. What we have done, we just changed the superplazar content. So this is how we varied the superplazar content until we get a near zero slump. So we can get a zero with a variation of 0.03%. We are able to get 15 mm. But there is a advantage if you have a 25 mm. Because of that, we will get a high compressive strength, which we will be having a high compressive strength. So these are cube and a cylinder strength. As I mentioned, we all know that the UHPC definition, we need to achieve a compressive strength more than 120 MPa. So we were able to get a cube strength of 142 and a cylinder strength of 138. So these are the stress strain curves of near zero slump UHPC. So at early age, it will behave softer, and as age increases, it becomes a bit stiffer and enhances the strength. So these are the elastic modulus and fracture strength. So after this, what we have done before getting into experimentation, casting big long span hollow core slabs, we have done some analysis. Hollow core slabs act as a equivalent ACECON, considering constant depth and to maintain the same moment of inertia to get the same flexural behavior. So to design that, how much demand which it can take, which is subjected to, at considering self-weight, screed, and live load. So considering all weights, total service moment, we are getting about 73 kilonewton meter. So when we are analyzing it, considering our basic principles of pre-stressed concrete, So we need to check at a transfer stage. When you pre-stress it, when you cut the tendons, it's subjected to upward camber. So it should not crack at the top and it should not crush at the bottom. At the same time, at service level, it should not crush on the top and it should not crack at the bottom. So considering these four categories, four cases, we have done the analysis, and followed by we need to consider, depending upon our material properties, we need to come up with the allowable stresses. These allowable stresses should be more than the demand stresses at the top and bottom of the member. So these are the allowable stresses at 28 days and 28 days at service stage and 1 day at transfer stage. And for considering cracking, allowable stresses 6 MPa at transfer stage and 28 days 14 MPa. Yeah, so as I mentioned, compressive stresses due to demand and tension stresses due to demand, it should be less than allowable stresses in compression and tension. So after that, our major criteria for design criteria for flexion members is deflection. So considering self-weight and pre-stressing and live loads, total deflection comes out to be, that is the expression which we are used, and allowable deflections at transfer stage, we can consider upward camber, it can be minus 33, but we can consider, conservative, we can consider minus 30. At service stage, considering 10 meter span, so we can have a 40 mm. So these are the some results. The slab which is having 150 mm thickness and length of 10 meters. So for this case, we did not find the deflection criteria. Why? Because all the possible bottom reinforcement and top reinforcement, all the in all the cases that deflection criteria are limiting. So that's why what we have done, we increase the depth of the slab. So here we could able to match the deflections at transfer and service stage. And if I increase the length, so what it happens? Again, I went up to 15 meters. Again, here I did not find the solutions. Still the deflections are not meeting the required limits. And I increase the thickness, and here I could able to match and get the limits. And further, I increase the slab length to 20 meters and thickness about 350. So here I am getting higher deflections. For that, what I have done, we increase the depth of the slab. So we are able to satisfy the deflection criteria in transfer stage and service stage. So considering this, there are many factors we can consider to improve. So there is still room for improvement for this technology. We can optimize the mix design, consider material aspects, and we can consider, we can enhance the stiffness of the member. So, but these, from this preliminary study, we were able to develop a zero slump mix design with for UHPC with a characteristic strength of 120 to 125 MPa, and we could able to make a 20 meter slab with a depth of 350 to 400 mm. So in overall, zero slump UHPC is technically viable and structurally efficient material for manufacturing long span pre-stressed hollow core slab through extrusion based production. Yeah. Thank you for the time, and if there are any questions, happy to answer.
Thank you, Virender, for being on time.
Thank you, sir.
We have two questions to ask.
Sir, I have a question for the UHPC, as you said, with a low slump.
Yes, sir.
So, what is the value of the slump, first? And second thing that you have shown, is it an extrusion process or?
Extrusion, sir. Yeah, extrusion process.
So, there you don't feel any sagging of this, because once the fines are high and you are using PC-based admixture,
yeah,
it has a property to it become more fluid, even at low slump.
Sir, for extrusion, basically for extrusion process, we need near zero slump. So as you said, it's typically HPC is self-flowable, but whereas that's why we change the mixer design to have a 0 slump, so that it can extrude through the machine and we can make slabs out of it.
But did you face any problem while I'm doing extrusion?
Sorry, actually,
sagging?
sir, as I mentioned, the study is in preliminary stage. That's why we have done some calculations, and we obtained some mixed design. And next stage is we are going to cast slabs.
Okay, thank you. Last question.
Sir, what is the optimization you get using the both pre-stressing and your ultra high performance concrete? Total optimization, what is the objective of your total optimization?
Sorry, sir. Okay, could you please?
What is the total optimization you are getting using both UPHC and the pre-stressing?
Sir, actually that comparison we need to have in terms of cost and material. So that calculation to do. Why? Because when you are able to do in casting, so after that we thought of doing, we did not do that comparison yet, sir. Yeah. But still, considering its superior mechanical properties, we can go for less depth compared to conventional normal concrete. So we can reduce the depth and, yeah.
We can increase the pre-stressing force.
Yes, sir.
The higher strength materials.
Yes,
We can increase the higher pre-stressing.
Yes, sir. Yeah.
That is the
Okay.
basic advantage.
Virendra, I have a quick question to you.
Yes, sir.
Other than pre-stressed concrete, precast concrete,
Yeah.
if reinforcement is very much congested, then what about the slump?
Sir,
You said zero slump.
Yes. So there is a thing is that typically hollow core slabs will be having longitudinal reinforcement. There won't be any shear reinforcement, and we will be having cores. In that gap, we are going to provide a reinforcement. So typically in a hollow core production, we will not face the congestion of the reinforcement. To say, yeah.
Okay, thank you. Thank you very much for your presentation. We have third presentation by the authors, Prakash, Abhishek, Priyadarshini and Venkateshwar Rao. The topic is on compressive behavior of column with GFRP confinement and steel reinforcement. Your name? Abhishek Prakash. Okay, yeah, please present within.
Good afternoon, everyone. I'm Abhishek Prakash from NIT Warangal, research scholar, working under Dr. Anita Priyadarshini and Professor S. Venkateshwar Rao sir. And my topic for the today presentation is the compressive behavior of column with GFRP confinement and a steel reinforcement. These are the content which I will be addressing today. Following with my introduction, why wrapping is needed in the column. There are many kind of FRP currently. GFRP, that is glass fiber polymer, glass fiber reinforced polymer, CFRP, carbon fiber reinforced polymer, BFRP, basal fiber polymer. But we are choosing the glass fiber reinforced polymer because of its easily availability and because of its ongoing many research project and because of its structural enhancement and its structural deterioration, control over the structural deterioration. And the GFRP is especially valued for its cost effectiveness and resistance towards the corrosion. And the wrapping, why we are focusing is because of the corrosion, our concrete get easily damages. So what can be the protocols to repair or rehabilitate our current concrete by any of the methods by GFRP. These are the following literatures. Coming to the summary of the literatures, the many literatures are focused on the carbon fiber wrapping and the basal fiber wrapping and the glass fiber wrapping over the 1 to 3 layers in the circular column and square columns. But in circular column, the confinement is easy to wrap because of its circular confinement. And where the partially and fully some of the research work was done with improvement with the partial and ununiform wrapping to provide the meaningful gain. And the most of the cases we found that carbon fiber wrapping was suitable than the GFRP and BFRP wrappings. Coming to the aim and the objective of the methods, my aim is to investigate the compressive strength of a column by 3 different methods. First is the internal wrapping of the reinforcement case, and the second is the external wrapping of the column after the demolding, and third is the external wrapping of the column after the curing of the 28 days. And objective is to define which centering method is suitable for my reinforcement column. And following the experiment, three mechanism is followed, and in its method, 3 specimens were cast. Following with the small short column I have taken for my preliminary study, in that 115 to 300 mm height I have taken. with the 12 mm long, 12 mm diameter of 6 numbers of 250 mm height, and with a tiller cover 25 mm, and we have provided 6 mm stirrup of 112 spacing from center to center. These are the three methods which we have focused. First one was the internal wrapping of the reinforcement case, whether we tried to wrap the FRP externally for the confinement, where we can see that the 6 longitudinal steel rod was fabricated reinforcement case, and we have done internal wrapping. In the second and third process, we have roughened the concrete structure after the demolding, and then we have wrapped the 610 GSM rowan mat, and we have taken the LYFFC resin and HY556, sorry, LYFF6 epoxy resin and HY951 hardener with a 10:1 ratio for the wrapping purpose. And we choose the OPC cement for the casting and 10 to 20 mm of the aggregate for the inner and outer for design mixing. And design mixing was targeted for M20 concrete, and with following the IS code 1026/2019, we calculated and found the 1:1.80:3.20 as a mixed ratio with 0.5 water cement ratio. In the result, we found that internal wrapping didn't perform that much better performance, where the second wrapping, which was done after the curing wrapping was done, that also didn't showed 465 kilonewton only as a target strength, and with the wrapping which was done after 28 days of curing showed the maximum compressive strength, means ultimate load. So like following that, because in this internal wrapping, where we found that filling the concrete in and out was one of the biggest challenging. If we choose the same aggregate for that, so like if 2-3 samples was wasted because of improper concreting. So like, and then we filled 10 mm aggregate for outer filling, and 20 mm aggregate was considered for the internal filling. And where we found that the moisture was also present because of the concrete couldn't get the full curing condition 20 years. When after the cracking and testing, we found the water resistance was still contained inside the FRP layers. And the second, which was FRP was wrapped after the immediately after the molding, and then cured for 28 days, we found that concrete break through the jacketing of the FRP layer. So like concrete was completely failed. With the spalling, we can say the spalling of the concrete. In this, we can clearly see that it was vertically, it was ruptured with coming out with the concrete. In the third, we just found the minor cracks in the FRP layers. And then in one test, we found that completely jacketing was coming to the longitudinal phase. And coming to the conclusion point, where we found that from internal to internal wrapping, in the third mechanism, one was one of the best for the FRP wrapping, which was cured after 28 days, and then wrapping, which showed the 45% of increment than the normal curing, and from the first mechanism, and 129% from the second mechanism. Following that, premature brittleness failure was, and the concrete spalling was observed in mechanical one wrapping of the column because of the concrete confinement. And then pre-wrapping also didn't support because of the insufficient bonding between the during the curing condition and the concrete. That means the concrete didn't attain that curing that it has to attain in the 28 days, so that we found that our aggregate was easily coming out with the FRP. Thank you. That is all for presentation.
Thank you for on time presenting your paper. I have one question to you. Yes. What are the Indian standard specifications you have used?
Indian standard for
any standard specifications you have used?
456.
IS 456 is having the repair methodology and the wrapping methodology?
No, sir. For that ACI 440R IR.
Okay.
ACI 440R IR.
Okay. You can see the even European codes also.
Okay, sir.
Okay, and compare the Indian codes.
Yes.
Okay. Thank you. We have 2 questions to be asked.
Like I'm currently working on the different parameters of the bar and different types of the bar for the wrapping of the structures currently. My just preliminary study is going on. This was the one of the preliminary study for mechanism. We found that after 28 days curing, then wrapping was suitable. And similarly, we are trying on the other types of bar also, how the wrapping will done in the other confinement or the design of the columns. So like, what do you want to properly know?
Actually, it was the confinement cells of the compound.
Yeah.
Whereby the iliac set of cells will conform to a triaxial set of cells. That's the main mechanism in the.
Yes. Okay, sir. Thank you, sir.
Okay, thank you. Thank you. You can interact in during tea session if any queries are there, research scholars.
Yes, sir. We took the aspect ratio L by D also for this short column. Yes, sir. Thank you, everyone.
Okay, thank you. We have the fourth presentation by the authors. Shivaramanayakam, Reddy K, Subramaniam KVL. Topic is on influence of fly ash-based aqueous nanosilica on cement hydration and strength. Please present within 7 minutes.
Okay, Professor. Thank you, Professor Vikshma. So, good afternoon, everyone. So, I am Dr. K. Chiranjeev Reddy. We are from IIT Hyderabad, and we are addressed by Professor KVL Subramaniam. So, today I am going to talk about extracting nanosilica from fly ash and using it as a enhancement material for the cement. So, coming to the presentation, so like we all know, like the clinker content is associated with high greenhouse gas emissions, like we need to reduce it somehow. So these are some potential supplementary cementitious materials which we can use. So we are using fly ash, but whenever we try to use fly ash in the mixes, like it will hamper the initial strength, so earlier reactivity might be less. So we want to enhance that by extracting silica from fly ash. So coming to the objective is like we want to effectively utilize the fly ash and to enhance the earlier reactivity. So coming to the materials, we use like the sodium hydroxide. So we used sodium hydroxide to for leaching the fly ash solution initially and then proceeding to OPC cements by adding this leached alkaline solution into the OPC cement. So this was like our idea. So coming to the leaching mechanisms in fly ash, like we can see here, like we took 8 molar sodium hydroxide and we kept fly ash in it and we let it for over like 24 hours. So in this process, it will try to, the silica and alumina which are present in fly ash will leach into the system and it can have silica in the system. And we also added CO2 later on to make carbonates. Like why we did, I will be telling in subsequent slides. So coming to the thing, like we have to do, like carbonation was done like this, like you can see here, like we have bubbled the carbon dioxide into the solution, and this is the pH decrease with the carbonation, and we can see a decrease in pH, like the sodium hydroxide which was initially there gets converted to carbonates and thereby the pH gets reduced. And we also saw some increase in temperature like in the solution. So this is the solution which consists of fly ash in the solution, in sodium hydroxide. We can see our fly ash is there in sodium hydroxide solution. So this is the solution which we have. We can see here after having the solution, we try to analyze the composition like with different techniques. Like in ICPOS, we will get the chemical analysis and we analyze the carbonates and bicarbonates using standard tritirometry. And we also analyze the particle sizes which are present in the solution using transmission electron microscopy. So this is a little bit important to understand the solution composition. So in ICPOES, we can, coming to the carbonation tritirometry, so we were trying to analyze how much sodium equivalents we were there. Like initially we had about 83 grams per liter of sodium equivalent. And when we tried to get the carbonates and bicarbonates from the titration setup and we back calculate the equivalent Na2O. So this is like a check to see whether carbonates and bicarbonates what we have calculated are correct or not, and the value is up almost near, like whatever we have given is 83.67 and whatever we got is 85.24. So that means the solution has carbonates and bicarbonates, and why we are doing carbonation I may be explaining little later when we got into the compressive strength results. So in solution chemical analysis, so from ICPOS we got to see some silica and alumina. This Faban solution is like pure before carbonation. That's called fly ash aqueous based nanosilica, and after carbonation we saw a decrease in silica content, and alumina is almost appeared. Like this we are hypothesizing like because of carbonation the temperature of the solution has increased, so that might have like led to the formation of some geopolymers because of this fly ash system. So this is a TM image of the solution. We can see here these are some nanoparticles. Okay, these are some nanoparticles of silica, and we can see this is the elemental composition. We have some silica and sodium because that's the sodium hydroxide solution. And after carbonation, we can see it's, of course these are some sodium carbonate solution. Here what we have to observe is like the silica particles can be seen as an amorphous form. This is the selected area, electron diffraction. So these rings will tell us about the crystallinity, and we can see here broad diffuse rings. That means it is amorphous in nature. So this is some chemical analysis. Like now let me get into the what mixes we have done. Like we take OPC of 90% and fly ash 10%. Control means without any sodium hydroxide solution. Here this is the alkaline leached fly ash solution, and this is the carbonated solution. Now when we see the compressive strength, our main motive was to improve the early age reactivity. So when in control, the strength is about 12.5 at 1 day. So we think with Faban solution, with sodium hydroxide solution, the strength got decreased because the sodium and the hydroxide has negative impacts, negative effects on strength. But when carbonated, the earliest strength has got increased. Of course, the later age strength has gone down. So, but that we can take on that because our motive was to get the earliest strength. And we took this hydrated product and we did some XRD studies, and what we found is like unreacted C3S in carbonated solution, like unreacted C3S in carbonated thing, as well as in Fabans compared to control. So that means there is a lot of unreacted material which can be potentially make reactive, and there is a decreased amount of CSH, which is the prominent binding gel. Like that means, so it can tell us about why lateral strength is very minimal. And interesting thing to observe here is like we have still a lot of Portlandite. Like whenever we have carbonates in the system, we expect calcium hydroxide to get converted to calcite. So that we haven't observed. Like instead, we have seen very less improvements in calcite content. We thought it will be very high, and we have some thermonitrate and trona type phases as well. These are the sodium carbonate phases. So we are investigating on why these things, and we have an hypothesis like in the presence of sodium hydroxide, the carbonation cannot proceed as it has to. So it can hamper the thing. So we are still working on how exactly to verify this hypothesis, and we'll soon conclude why this thing is not happening, like the full carbonation of Portlandite has not happened. So coming to conclusions, so aqueous silica enhances, and like the earliest strength, of course, the carbonated aqueous silica solution, and C3S is still there. Like we have a lot of unreacted C3S. We can, if somehow we can make it reactive, we can achieve much more lateral strength. So these are some of the like conclusions which I have. So that's it.
Okay, Shivaram Naik, you are on time. I have one question to you. And, cement also.
Yes.
What is the rate of hydration for fly ash and rate of hydration for cement? Did you identify these two?
Rate of hydration, like we haven't done here. In cementary systems, of course, cement, like first cement has to react so that it forms some reaction products, then only the fly ash will kick in, and it will try to participate in pozzolanic reaction. So fly ash rate of reaction in cementary systems will be later. Like
okay, what is the percentage of fly ash that you have replaced?
We are like just started with 10%, and we are trying to improve it actually 30%.
Okay, you have not optimized.
Yes.
Okay, two questions to be asked from audience. If no questions, we are very happy. We are running out of time. Okay, thank you. Thank you, Shivaram. We have next presentation by Dandepalli Harshavardhan and Pallapotu S. presenters, you are there here? So, and topic is on optimizing the dosage of quarterly blended alkali activated mortar. Okay, a blended concrete. It is concrete?
Yeah, mortar.
Mortar. Okay, okay, yeah. Present within 7 minutes, please.
Okay, sir. Thank you. My name is Dandapalli Harshavardhan, PhD scholar from SR University, under the supervision of Dr. P. Swami Nagaratnagiri sir and Rajshekhar sir. My title is Optimizing the Dosage of Quaternary Blended Precursors Used to Develop Alkali Activated Mortar. This is the outline of my presentation. It includes introduction, research gap, methodology, materials, casted cubes, mixed proportion for developing the quaternary blended alkali activated with varying dosages, results and discussion, conclusion and references. When we talk about whenever we talk about concrete, first thing comes into our mind is cement, but day by day by using cement, we are carbon dioxide emissions are increasing day by day. That's why we are looking for alternative ways for producing the concrete, which is alkali activated concrete. To develop alkali activated concrete, first thing comes into our mind is fly ash and GGBS are the primary materials to use to develop alkali activated concrete. But in future there is a chance of reduction in the production of fly ash and GGBS as India is moving towards for the net zero energy by 2040. So for that reason, we are looking forward for alternatives for fly ash and GGBS as thermal power plants are reducing. We are utilizing already the solar energies and tidals for generating power, so that we looking for alternative for fly ash, that is waste glass powder is rich in silica. So we are planning to replace fly ash with waste glass powder, and GGBS is, as we all know that GGBS is rich in calcium. Nowadays, instead of using steel, we are going for to use fiber reinforcement and all. So to replace the GGBS, we choose to do eggshell powder, as eggshell powder is rich in calcium. So we selected eggshell powder and waste glass powder to partially replace fly ash and GGBS. We can get the doubt that how can we get the eggshell powder and waste glass powder. Yearly 65% of the eggshell waste is generating from the poultry farms and egg processing units, and 17.5% of the waste is generating from hostels, hotels and restaurants, and 12.5% is from bakeries and food industries, and 7.5% from households. We took top countries which are producing eggshell waste. In this, India is also there, which is in 2025 it produced 0.54 million metric tons. That's the reason we choose eggshell powder to replace. This is the waste glass powder sources, which comes from 45% from food and beverage industries, and 25% from household waste, 15% from construction industry, 10% from retail and packing, 5% from automotive industry, and 3% from pharmaceutical and medical, and 2% from electronic industry. In this, India is recycling the glass powder up to 45%. And as I discussed, fly ash and GGBS are utilizing to develop the alkali activated concrete, but the availability of fly ash and GGBS may decrease in the future. For that, we are planning to partially replace the waste glass powder and eggshell powder. And when I gone through the literatures, less studies on quaternary blended alkali activated concrete. That's why we are planning to do research on quaternary blended alkali activated concrete. This is the methodology utilized. First, material procurement, determination of physical properties, microstructure analysis for the precursors, prestate properties, mechanical and durability studies. After that, microstructure analysis for the motor cubes. As I said, we used fly ash, GGBS, eggshell powder and waste glass powder. Fly ash is having specific gravity of 2.10. If we observe this same image, the particles are in spherical and smooth particles, so that it improves concrete flow and filling. It helps the mix to dense and less porous. Coming to GGBS, specific gravity of the GGBS is 2.78. If we observe the same image, irregular and rough particles, so with the help of this rough particles and irregular, bond well with other materials. Coming to eggshell powder, specific gravity of the eggshell powder is 2.42. If we observe that same image, irregular and porous particles with flaky morphology, waste glass powder, the specific gravity of the waste glass powder is 2.55. If we observe the same image, it shows angular and sharp-edged particles with smooth surfaces. This is the chemical composition. As I said, fly ash is rich in silica, and if we see here, waste glass powder is rich in silica. It is having 71.1%. GGBS is rich in calcium, 34.56. As in eggshell powder is also 48.77. Here we use E8 molarity and sodium hydroxide and sodium silicate for alkali activation. Alkaline to binder ratio 0.5 and sodium silicate to sodium hydroxide ratio 2.5. These are some of the tests done on fine aggregate. These are some of the cubes casted for 6 different types of the mixes to optimize the best mix. If we see here, this is the mix proportion utilized for 6 types of the mix proportions. This is the compressive strength we have done for 7 days, 28 days and 90 days. If you observe the 7 days strength, 10.53% improvement is there, and for 28 days 10%, and for the 90 days 7.14%. This is the same analysis for the optimized mix, that is fly ash 10%, GGBS 30%, eggshell 20%, and waste glass powder 40%. This is the sorptivity test we have done for the. If we observe here, for 40% waste glass powder, obtaining approximately 24.4% reduction in water absorption. If we observe for compressive strength, we got good strength, and water absorption 24.44%. So that want to tell that utilizing waste like waste glass powder and eggshell powder provides a sustainable alternative to conventional binders, so that we can reduce the carbon footprint and industrial waste.
Okay. I have one question to you.
Sir.
You have used GGBS and fly ash.
Yes, sir.
What is the optimum percentage?
Sir, 10% fly ash, sir. 30% GGBS, eggshell powder 20%.
Use the mic.
10% fly ash, GGBS 30%, eggshell powder 20%, waste glass powder 40%, sir.
Fixed the mixes?
Sir?
Mix proportions fixed?
Yes, sir.
Okay. According to the literature we have done?
Yes, sir.
But again, look into the literature back.
Sure.
So some other variations also there.
Okay, sir.
So therefore, try to look into that and which grade of concrete you are taking up.
Yes, sir.
For that particular grade, whether it is okay or not, test all the mechanical properties, ensure yourself, and then try to proceed.
Okay, sir. Thank you, sir.
Yeah.
Thank you, sir.
2 questions.
A good presentation.
Thank you, sir.
Just because you are a research scholar, my question one is that what will be the durability of your concrete that you are getting? I mean, durability, I mean, what will be the service life of such structures? Your motivation, what will be the utility in the construction industry? Just simple.
Sir, I'm in the preliminary stage, sir. I was not done in the preliminary stage, sir. I am not yet done the durability studies for this. We are looking for it, sir. Only subtivity has been done, sir. Sir. Sure, sir. Thank you. Thank you. Sir.
One question is from my side.
Thank you.
Sir. Thank you, sir.
Yeah. We have last presentation in this session. Okay. That is by Mohanlal Sivachandram R. The topic is on textile reinforced concrete as an alternative to conventional RC beam strengthening methods. Okay. Please present within 7 minutes.
Okay. Actually, my scholar is not here, so I am presenting on behalf. So the title is like TRC as an alternative to conventional RC beam strengthening method. Okay, I will go straight away. So this is a typical observations which we have made in a particular site. So we have experienced a lot of cracks and actually conceptualized image. It's a real image. So that instead of going for FRP, like, because all these beams are associated with, is it audible now? Yeah. So instead of going for conventional FRP, because those problems are associated with some dampness also, so he has started going for TRC. So basically, I'll skip it. TRC in the sense like textile with normal cementitious mortar. So the textiles may be of any like glass, carbon, or basalt. So in this study, this particular presentation, he has used only glass. So later we have used multiple. So with and without fiber reinforced mortar we have attempted. So these are the typical various fibers. So basically TRC layer will be at the tension soffit region for your beams. The thickness may be of 10 mm, 15 mm, depends, and the number of layers also depends on the required capacity as well as deflection. So the main problem in TRC is like this kind of delamination or we can say debonding or delamination. So this will actually reduce the efficiency rate of your strengthening process, as well as you can't attain a better post-peak behavior. So in this study, we have introduced anchors also. So with and without anchors, we have done the study. So we can understand what is the need of the anchors and why it is important. So I will skip this objectives. So yeah, these are the textile, glass textile used in this study. So this is the tensile behavior of the individual, and this is the mixed ratio he has adopted. So this is the tension coupon. This is the mortar samples as per Rylam standard. It has been tested with different type of, different numbers of textile layers. So the tension behavior, you can see this is the 2-layer, 3-layer, and this is again 2 layers. This is the 3-layer. This 2 is 2 layers. But this is without fiber reinforced mortar. This is with fiber reinforced mortar. So you can understand the importance of presence of fiber in the mortar in elevating the tensile performance. And after seeing this, you can understand the importance of number of layers too. So this is the typical failure pattern observed. So multiple tensile cracks in the gauge region we have experienced. So when we go for higher number of layers, the failure will be shifted to, you can see the wedge region. So it is not advisable to that. So as per this, we have to understand the bond between, because we are working with RCC beams. So bonding between the TRC layer and your RCC beam is very, very important. So we are not using any epoxy kind of thing. We are using cement slurry only. So interface treatment is very important thing. So it has been done. So prior to this, to understand, there is a study standard procedure for this. So we have to make RCC member and interface treatment with a different type of bond length. So the bond length and the surface treatment will vary. So we have to apply a tension force like this. So these speckles are nothing but for digital image correlation purpose. So when we go for a smaller length, you can see it is completely peeled off, debonded. Whereas when we go for higher length, it is actually textile is rupturing. So that's why the bond length is very important. This is only applicable for tension. So when you go for bending, this phenomena is completely different. So you can understand the tensile behavior also with reference to the length. So when we go for higher length, you can see, and when you go for higher number of layers, we have to increase even more higher bond length. Otherwise, we can expect debonding of TRC layers. So the same thing will happen if you are going for a very small amount of bonding length as well as treatment. So this is the typical beam considered. Later ways he has gone for a full scale also. This is a small scale beam. So this is the bottommost TRC layer of 10 mm gas straight. So first of all, the surface treatment is very important. So they have we have made the surface preparation and then grooves of a standard size he has made, and then we have applied cementitious slurry. And this is the TRC, this is the mortar which is prepared like a paste kind of thing. It is not going to be flowable mortar. And over that textile reinforcement will be placed and another cement slurry layer, and then we will go for again mortar. So this will be the strengthening layer. This is the strengthening layer, and this is the normal beam. So in order to understand the strain, because we have used strain gauges, but you can't capture the surface strain of entire strengthened region. So we have used digital correlation, digital image correlation. Yeah. So before starting this, we have to calibrate that. So we have used LVDT to understand the deflection. So we have compared the LVDT data along with the DIZ data. So it is correlated. So now we can rely on this. So this is how the DIZ has been done. So they have speckled the beam's surface, including the strengthening layer, and continuously we used to take the photos of particular area until the specimen completely fails. So this will be the output. I will capture it. So this is the conventional beam. You can see we experience a lot of cracks. So the same thing has been observed in DIC also. This is the strengthening beam, and which has with the textiles. You can see. Yeah, this is with textiles. So the bottommost layer, after completing the testing, if you see, we have cracks which is similar to the observed behavior under tension. And then another one is like with 2 layer of textile with fiber reinforced concrete. So if you look at this, comparing this two failure pattern, you can easily understand the importance of fiber in the mortar. So here we have cracks, but whereas here we experience wonderful number of fine, dense cracks. That is very, very important to achieve the post peak behavior. So finally, in both the cases, we experienced failure of textiles. So in another one beam, we have used without any anchor, there the delamination happened. So I will come to this later. So you can see this is with higher number of textiles, 3 layer of textiles. So rupture of textiles, finally failure in this aspect. So because before going into the study, like what we have decided to take the points at middle exactly where this is the LVDT and this is the point we have taken. We have taken one point in RCC, another point in TRC layers to understand the strain like this. So if you look at this particular graph, you can understand this is the strain of RCC beam and this is the strain of TRC layers. So because of absence of anchorage, in this particularly the TRC delamination happened, so there is a sudden drop. So the maximum strain of RCC beam is, even strengthened beam is almost 7,000 microstrain. When you go for TRC layer with proper anchorage, you can understand there is no any delamination, textile rupture is happened clearly, and the RCC beam reached a capacity of more than 30,000 above microstrain. So properly strengthened beam with anchorage, you can attain wonderful amount of strain. That's why what I mentioned is that efficiency of your strengthening scheme can be clearly understood from this particular strain-based images. So both of the beams having a textile layer with additional anchorages. So anchorage plays vital role in attaining higher strain capacity. So this is the strains. So this is the load deflection behavior. This is the control one, and this is the beam without. This is with anchorage only. And here you can see these two beams strengthened with textile reinforced with fiber reinforced mortar. So this is the difference, like stiffness enhancement and post peak enhancement and yielding behavior. So complete change when we use with fiber reinforced mortar. So we can attain 30%. Now it has been further enhanced. So the stiffness behavior. So almost in energy, ductility, as well as controlled failure pattern. In every aspect, the performance has been elevated. And mainly, the damage tolerance capacity, you can see, with anchorage, the damage tolerance is almost like 3 to 4 fold higher than the conventional beam and TRC beam, strengthened beam without anchorage. So that's the importance of anchorage in TRC. Yeah, that's it. And this conclusion is like we can go for a higher ductility and better energy dissipation. When we go for proper strengthening and with anchorages, we can go for even more higher efficient strengthening scheme with better damage tolerance. Thank you.
Okay, your name?
My name is Sivachandran.
Okay, thank you, Sivachandran. On time.
Yeah, thank
But
you.
I have one question to
Yes,
you.
sir.
You said textile reinforcement is having higher ductility.
Yeah.
How it is higher ductile? Because it has a brittle in nature and
This study
it doesn't
we
go, it goes large deformation, so it fails quickly. So how you can say that it is having more ductility?
Yeah, that's why we have added fibers in the mortar that helps you to attain small amount of ductility compared to the normal brittle. So now in this study, what I have presented is we have used only glass textile, which is actually brittle. So now we have added one more textile. It is actually strain-based textiles. So it will provide you 10 to 12% of higher strain incomparable with the glass or carbon, only for strain. So,
but textile reinforcement is having a biodegradability. So how do you ensure that?
no, this is properly coated textiles.
Properly
coated.
coated.
Alkali resistant
So,
coated textile, yes.
okay, okay. Thank you. Okay. Any questions? Yeah.
You use the word DIC.
Yeah, yes, sir.
What do you mean by DIC?
Digital image correlation, sir.
Acha.
So we have to take images continuously till the complete failure, and then we have certain softwares to analyze the speckles. So the speckle movement will give you the surface strain.
Now, after strengthening, have you been able to check what would be this longevity? How much, life it can sustain after your strengthening?
Yeah, we can see the strain. We can see the surface strain. We can get the
see
data.
the strength, but how long? I want that.
Till the collapse. Till the collapse.
Eh?
He's talking of durability.
Durability.
No, durability we can't study through DIC. It's
You
only
are
surface strain we can see.
You have not yet studied the durability part.
No, that is a separate study.
Okay.
We have done.
Last question. If no questions, thank you. Thank you very much for your patient hearing and listening in this session. Afternoon session is very difficult to handle. Even then, you have cooperated well and answered many questions. So in this session, briefly, 1 minute.
Yeah, please.
6 papers were presented and 1 keynote presentation presented by Prasad Rangaraju, and all papers were very good, and all papers are from IITs and NITs, and they are particularly research papers, and micro level studies have been done and then well presented. Thank you all the participants and then presenters for making this session very successful. Thank you. And I thank the organizers of the ICI for giving me this opportunity. Thank you. I am now handing over mic to you.
Thank you. Thank you, Bhikshma. So, dear delegates, let's give them a big round of applause for such very deep dive studies and bringing their studies onto the stage and presenting to us. Sir, may I request Bhikshma Garu to be on the stage, sir? And to do the honors on behalf of the Indian Concrete Institute, I request Pradeep Garg, sir, to kindly come out to the stage, and also Mr. Vijay Totigarji, who is the chairman of ICI Hubli Center, to be present here. And Pradeep Garg, sir, is the chief engineer of the CPWD. And Mr. Jagannath, of course, of the Hyderabad Center, sir. Coffee break? Coffee ready? Thank you, sir. Thank you for that very eloquent handling of the session. Now we have at another session which is very interesting, and that is being handled. The session chair is Dr. GVP Bhagat Singh ji. Sir, Bhagat Singh sir, are you ready, please? Okay, you are here. Just, I will call you, sir. Okay, right. Okay. Just give us 2 minutes. No. We have one more. we need to do honors for Professor Prasad Rangaraju Garu. May I request Professor Prasad Rangaraju Garu to please come on to the stage, sir. Professor Prasad, sir. Is he in the hall? Okay, we will do the honors when he arrives here. So the next session is something which is very interesting, and that is being chaired by GVP Bhagat Singh, sir. Sir, I know that you want like an introduction as elaborate, so I'll keep it very brief. He is assistant professor, grade 1 at the SRM University, Andhra Pradesh, specializing in construction materials, concrete durability, CCS, LCA, and the 3D printed concrete. He has worked extensively on thixotropy, buildability, and interlayer bonding in digital concrete. He previously served as the postdoctoral fellow at the Ohio State University and assistant research professor at the Marwadi University. He has strong publications and project contributions and received SRM's Outstanding Faculty Award in the year 2025. Dr. GVP Bhagat Singh, sir, the session is over to you. Please welcome Dr. GVP Bhagat with an applause, please.
Thank you, sir. And it's a series of presentations are lined up. It's more into the 3D printing of concrete and the other aspects related to the calcined clay and the silica fume, various topics. So I don't want to take much time. We will have a keynote presentation by 20 minutes, followed by we have the 8 presentations pertaining to various topics. And as a part of keynote presentation, we have with us Professor Rajiv from Swinburne University, and he's going to talk about the large-scale 3D concrete printing from the concept to reality. Professor Rajiv, yeah, please, over to you. I don't want to take, he knows very well, most of the people know him. I think there is no point to have an introduction. Yeah, that's what so where's the controls? In this control, yes, over here, and back is this one. Yes. Okay, good.
Thank you. Good evening. Thank you for the invitation to present some of the work we have done on concrete 3D printing. And it's a long day for most of us, and I'm trying to finish early as possible, and just to show some of the real structures we have printed and what's the issues related to those, and how we can mitigate those issues. That's what I'm going to do. So the first question normally comes to us, why we want 3D concrete printing, and what's the issue and what we are trying to solve. So this is, you may have seen already these type of slides with information about efficiency or the productivity of construction industries compared to automotive industry or any other manufacturing industries. Oh, can you hear me now? Okay, so this, if you look at this graph in the slides, you can see the manufacturing industry has grown up the productivity by 100% over the years. But if you look at the construction industry is more or less stagnated, and there's no new technologies has been added to that. So that's the main drawback on the productivity. So then the next question comes, and what's the issue of these? And then you can see what's the effect of these lacking productivity in construction industries. You can see how the from in this graph, and it's showing that how these car prices, for example, grown over the years or increase over the years compared to housing prices, and so this again create an issue on affordability for the people to buy houses. And also it's introduced issues like we can't produce as many houses to provide to the people who can live in comfortably. So that's some of the information you can you can compare and see that what's the impact of less productivity in construction industries. So we have to introduce some new technologies to improve the productivity in construction. So any technology comes into play, and it's normally R&D works need to be supported to introduce those technology. So then the question comes, what other work has been done to integrate this automation in construction effectively? So what you can see from here is the number of publications over the years related to 3D concrete printing, and what are the areas has been focused over the years to adapt this technology. So since most of you know what is 3D concrete printing, which is the free-form construction, so the extrusion, the material is extruded, and then once it's extruded, and it should hold the shape. So we completely eliminate the formwork. So the formwork elimination is reduced nearly 30 to 40% of the construction cost, and also the waste material going into the landfill. So if you look at the initial days, initial years of the research, is mostly focused on the material development and also the process and the technology development of 3D printed concrete. And then if you look at after 2018 and up to now, there are slight increase on the structural application of 3D printed concrete. So that comes into practice. So you can see the trend, how it's going. So this data has been created every 5-year window, and then just I want to highlight how the research is progressing on our 3D concrete printing over the years. And the next one on your right is showing the type of structures has been built using these 3D printed technology. So you can see most of the construction work is related to building, and not on the major structures like bridges or anything. Even if there are some bridges, it's mostly focused on the pedestrian bridges. Here I just put some of the examples. You can see what type of structures has been built using this technology, and all the way from simple structures like furniture to the towers or the building has been focused to adapt these type of technology in their construction practice. So at all these extrusion-based, particularly the extrusion-based printing, the material has to be pumped and then extruded, and then it should hold the shape while printing. So this is the major material side development need to be happen, because if you want to pump the material, it should be flowable, and then when it's extruded, and also you have extrusion pressure should be low, but once it's extruded, and it should hold the shape, okay? So all of these process, we need to have a testing process to test the material. So we are basically controlling the rheology of the concrete. So you are testing the material properties in the laboratory or in the field. If you are going for the real application, then you have to do it in the field. But then if you talk about the quality control while printing, and then you have to have an inline control process to adapt these material testing process. So most of these testers has been developed to measure the rheology in the laboratory scale. So you can see number of testing approaches has been adapted to understand the material rheology, the concrete material, how it's going to behave, and how we can alter those material properties. So you can see starting from direct shear test, simple direct shear test, all the way to the extrusion rheometer, vane shear test, and also the penetrometer test, and so on and so forth. So you can measure the rheological property, but then I don't want to go too deep into those, and there are a lot of variability on each methods. So you have to find the suitable methods which can give a reliable answer for you. So then what I have done here is just compare, because anyhow at the end you have to do the on-site printing. So you have to measure the rheological property at the site. So we want to have a reliable method which has to be sensitive to the material property, and also it should be easy to use in the field. So we compare all those methods, and then trying to find out the better one, at least suitable one, which can give a reliable answer with reliable accuracy. So that's, you can see the green one, the hand vane shear test. It's giving a reasonably reliable answer and easy to use in the field also. So that's some of the comparison of different methods of measuring rheological properties, which one can be used in the field, to get the reliable rheological properties. So as I mentioned before, that's the pumpability and the extrudability and printabilities are the important parameters if we are using the extrusion-based printing approach for 3D concrete printing applications. So when you started to pump, this material is normally stiff compared to the normal concrete because after extrusion it should hold the shape. I'm just repeating again the same thing. Since the material is stiff and your pumping pressure is normally higher, so what we have done in the laboratory is trying to understand how we can control the pumping pressure low, but the material should be relatively stiff, okay? So we have done some experiment on vibration-based rheological control of concrete. So you can see the vibrator here, and we just pump the same material as is mixed and without any vibration, and then we apply the vibration on 3 seconds and 5 second durations. So the duration is affect the rheological properties, agitate the mix, and then it's affect the rheological properties. So you can see the plastic viscosity drops when the vibration duration is increased. And also we have done is soon after mixing, and also the increasing resting time. That means 5 minutes and 10 minutes and 20 minutes we couldn't pump. So just you can see some of the results. So when you apply 5 seconds vibration up to 5 seconds, it drops the plastic viscosity and also the dynamic yield stress. So you can easily pump. Why we analyze only the low duration vibration? Because if you vibrate more, then the segregation might happen, and then that's another issue to control. So we have done some work on around this and the active rheology control of printable mix, and how we can easily pump those mix without using a lot of pump energy. And here I would like to highlight the second one is the buildability. So after you extrude the material, it should hold the shape. So what we have done on the computational side, we have done a lot of experiments to understand in the initial stage, and then we move on to the computational side of it. And we have done the finite difference simulations, and then we did the similar experiments to see whether that where the collapse happen, and it may be compressive failure or the buckling failures depending on the structures. And also we developed the methods just to predict what's the buildability of each different mixes with different rheological properties. So these all about, I'm just put some summary on the pumping and buildability test and all what we have done on the analytical and computational and experimental side. But there's another side on development of technology which can improve the printing process. So as I mentioned that if the mix is stiff, so you have to pump the material or the concrete from far distance. So that's again, you have to control the rheologies and all. So what we have done here, we just trying to look at, okay, let's bring the dry material close to the nozzle, and then we mix it close to the nozzle. So it's all depends on how efficient you can mix the concrete close to the nozzle. So because you have a limited time and you have to extrude after that. So we have developed a concept called short duration near nozzles mixing. So the material all comes in the dry stage, as you can see on the diagram, and then is mixed very close to the nozzle. So it's depending on how long you are mixing. It's maybe 30 seconds or 60 or 90 seconds. And then your print quality will also change. So there's the research around that, and how you are going to mix and how efficient you have to mix and what's the duration of mixing, and all need to be understood. On your right, you can see the system we have developed on the near nozzles mixing, and this is all the literature you can see and what has been done, and how we can improve these near nozzle mixing approaches. And the second one is, it's most probably few of you know about 2K system that's bring very fluid level concrete and easy to pump, and then you put an accelerator very close to the nozzle and then get it done, and then extrude at the nozzles. And the good thing we have noticed, and very fine complex shape can be printed through a 2K system. and the Vertigo is the one provide this facility and develop the system, and then we have printed different two-stat columns and all, and without any issues and no collapse and all. So the third one I would like to highlight here is the flexible digitally controlled mold or the system, where you can see some of the, this video, I think it's not playing at the bottom. So we have actuator array system that actuators can move in different displacement and different rates. You can control those. So it has a mat, flexible mat, as you can see on the middle figure. So the material plays on the top of that, and then you can create different curvature sections and all. So you can see different section has been created and joined together to make the net type structure. Or if you see very on the corner of the third picture, that the dome shape structure, which we have discretized into so many different sections and printed over this flexible dynamically controlled mold system, and then you can join together to make the full structure. So it's very flexible. So these are the technology side or the process type, process site development we have done over the years on these to adapt these different printing processes. So the next one is integration of reinforcement. This is the one under the adaptation of 3D concrete printing in the real application, and you have there's a lot of delay on integrating these reinforcement properly into that. So there are so many different ways to explore to adapt these classical reinforcement into 3D printed structures. So then there's a point, and everyone thinks, and okay, let's print the formwork with 3D printing approach, and then you just drop the gauge reinforcement into that and then fill it with the normal concrete. So that's the way you can create complex columns, complex shape columns, but still it's with a classical structure. Or you just adapt the steel fiber reinforcement, or looking into that in-process reinforcements and all. So various approaches has been explored. Still few of them are in practice, but not much happening around that, or not much successful stories around the adaptation of classical reinforcement into 3D printed structures. As you can see on this side, it's like a formwork has been printed and then heavily reinforced over the structures to make it stable. And there's another issue, and I'll talk about why they are putting a lot of reinforcement into that on these type of structures. So this is some of the initial work we have done on integration of reinforcement. So it's printed structures, and maybe you can understand that it's a beam section has been printed in a modular fashion. So then we place the reinforcement, the interlayer reinforcements, and also then drill it through the layers to place the bars and then grout it. So this is very, very initial. It's like 7 years before we just trying to do these type of things. And then you can see different lapping length. And then on the two modules attached place, and we have placed the paste. And then we analyze and which one is more efficient and which is more stronger and all this different type of things. But it's not feasible, but it has been explored. And the second one is the textile reinforcement, so which is flexible, and so you can print different shapes. So we just developed the split nozzle, and which can hold the textile reinforcement in place, and then you can move it whichever the direction you want. So this one we just trying to see the structural capacity of textile reinforced section. So we printed the arch, and also we have done some facade elements and tested for impact loading. And all has been published, and you can find, and so we just explore different options how to integrate the reinforcement into 3D printed structures. Once that is successful, then now the question is how we can do the real structures on ground. So if we want to build a real structure, we should know what we are going to build. That's the first step. And then what's the structural capacity of printed elements? So it needs to be tested on the axial load, and it's depending on what type of load comes, and the outer plane or the in-plane loading of the wall elements, or any type of elements that support the lateral load and outer plane loadings. And also tested for the durability performance of printed structures. So if I go into the normal building, which probably you have seen in so many papers, and these are the 3D printed wall configuration is used currently and explored, and there are few structures has been built using these technologies. So you can see the multiple layer walls and single shell walls and all, but there are stability issues with the single shell, but the double shell is more stable. And then some has these ties, as you can see on your right hand side top, and to connect the double layer shells, and you have a ties, or maybe some places you can place the interlayer reinforcements. And also, if you want to make it more strengthened and anchored at the base, you can put a reinforcement and then grout it. And you have a webs and different webs, and to improve the stability, all different shapes has been explored to see and which one gives better performance and all. So the first thing comes in the compression load capacity of these printed wall elements. So that has been tested and then analyzed against the total load capacity of these, and with eccentricity and without eccentricities. And it's like a double shell wall, and in between the web side and the sinusoidal web has been checked. And then we have developed the analytical solution, and it has been published, and how we have to analyze. And it's not like the normal square section or the claw section. So you have to analyze the wall in between the webs as separately taken, and then analyze for the double bay bending section, and then you can calculate the capacity of the wall. So these all there on the respective papers, and you can see how we can estimate and how it performs with experimental data. And the recent one we have done on the outer plane bending of those walls. So all these tests has been done because there's not much guideline on how to assess the capacity of 3D printed structural elements. So I'll talk about the code developments and where we are on the follow-up slides. So whoever going to sign off these type of buildings, and they want some sort of comfort on how the elements are going to perform in the real life. So they ask for most of the testing, even though we may have a confidence on this, nothing going to happen for these type of walls, but then they just want to test it in the labs to see how it's going to, and then everyone is cleared for that. So it's basically like current practice, the performance-based solutions, or each applications need to be tested in the lab. So just coming back to this wall, it's a double shell again. So we have 6 meter long and 2.4 meter height. And it has been tested for the top restraint and not restraint. So I'll tell you why we have done the both cases, as you can see on the right side. So the first one is, say, while construction going on, so we won't put the roof truss on the top. So it's like until that, it should at least, according to Australian standard, at least it should carry the 0.5 kPa pressure for the outer plane. So that's the minimum requirement. So that's the reason, and we have done the test on top not supported, and then also the second one, as you can see, it's all past, the capacity is very high, and then it's always, as we know, that it's just rotate at the base, and then also there are a little bit of slips at the base, and so we had to have a lot of LVDTs placed and to monitor what's going on in the wall. And the second one is top restraint or supported. So you can see the vertical crack as marked on those figures because it's restrained, and then that control plot shows the deformation of the wall during the test. So it's gone up to 6 kPa, but the requirement is only 1.5 kPa because it's an exterior perimeter wall, so it should bear the wind pressure. So after all these tests, and there are a few more tests we have done on the in-plane loading and all, I don't want to discuss all those, and the fire tests need to be performed. So this house has been built and completed a few weeks back, and it's again the double shell wall, and also the ties are placed in between the walls. And there's the aerial view and everything, interior and exterior walls, all printed on site, and also it's 3D printed wall. So we just provided the R&D support, and then whatever the testing need to be done to clear up the certification. And once it's built, and this is the look of the house, and there are a lot of media coverage on these ones after building the first one in Ballarat. There are few more coming up after this, and we are optimizing the shapes, and this is in a way is slightly over designed than required because the first one and everyone is looking at and to get more confident on that, and we have put even the co-fill reinforcement and all to support every 3 meters along the wall. So once it's built, and the next issue comes is shrinkage cracking. So this is a major issue on the 3D concrete printing printed structures. So shrinkage control. But this particular house, and we have placed the moment joint, but we are looking into eliminate those to control the shrinkage crack. It's not like a brick masonry construction. These shrinkage cracks are more prominent and visible, and it's hard to fix it. So these, at the current level, most of the work on R&D side or even the industry side, and it's looking at to control the cracking on 3D printed structures. So that's the main thing to consider. And just to touch upon on these quality assurance and quality control of 3D printed structures, as I just slightly put on the map, and what's the process involved, say the material testing and mixed design and pre-qualification test, that's important. I'll talk about that a little bit. And the field Q&A testing, and then also finally the non-destructive testing of constructed structures. So we know what are the fresh properties and hardened properties we would like to test, and the mix up to mixed design is about extrudability and buildability and pumpability and all sort of things, and then comes into after printing, and then it's about compressive strength and flexural strength and also the interlayer bonding and so on and so forth. So then also we know what are the factors affecting those, and so how we are going to do this all these processes in the field or on-site or the off-site construction, the automation, if that's adapted in off-site construction, and then so we have to go through all this process and then monitor and then control. So in terms of properties, what we are going to do, what we need to monitor, it's also known, and then the problem for the conventional construction and 3D printed construction, that looking at these layer by layer construction, and the anisotropics plays a role because material is not homogeneous as we assume, and also where to sample and what to sample and what size of the sample to be tested. As you can see at the bottom, even for the compressive strength, there are different approaches has been proposed. Just take a cube as we normally do for the conventional concrete, or we just cut it as a different length along the 2 layers or 3 layers and test it. So this is the main concern, and engineers are not confident, and the researchers are going, and there is not much guidelines on what the test to be performed if you want to control properly. So if you look at what are the code of practice, or at least a guideline is available in the in worldwide, and few guidelines in UL 3401, it's US code, and also ISO is US, and then this just a guideline. It's mainly providing some sort of indicative testing process and quality control process based on the conventional construction method. So it's not much related to, if I put it in this way, it's like the modification from the conventional concrete part, but it's not particularly targeted on the 3D printed structures. Okay? So the rest of the T series and up to JC, it's all Chinese code. They talk about material testing and how to do how to perform the structural testing on 3D printed structures and all. But the more comprehensive one is the ICC one, the International Code Council one, but that's in the draft stage at the moment. So in that case, it's not very conclusive on what to do for engineers or the researchers or the builders once they started to use 3D concrete printing. So what I have done here, that just a summary on field pre-qualification test, because ICC is requesting and different shapes of the sample to be printed separately on site and then in a certain interval, and then sample it from those printed small section and then test it for different compressive strength or the flexural or bond capacities. So it's all in different size and the length, and they specify. So that's the pre-qualification test we have to do on site to make it this process more controlled. So in Australia, we have formed a team to work on these 3D printed process control and the design guideline, and then it has been supported by Standard Australia, and then there are builders, 3D printing companies, and also universities involved. And it's just at the initial stage and only 6 months old, and we are in the initial discussion on how to put and all these things, and then how we can take it to that. So we will invite the international experts also to comment on the final product, or at least the interim one. So finally, this is the Swinburne lab we have for 3D printing, 3D printed group, and then we have different country printers and also the vertical and robotic arms and 2K system and flexible mold and all sort of things, and it's well supported by the government and also university. We have graduated more than 30 PhDs on 3D concrete printing up to now. Sorry. Thank you, that's all from me.
Yeah, thank you, Professor Raju, for your detailed presentation, and it was highly informative and provided valuable insights. And as we are running out of time, maybe let us confine to 1 or 2 questions. Yeah.
Hi, Pat. That was a very interesting presentation. I basically come from the background of engineering and applications. The science and technology, what you guys do, my job is to ensure that it's implemented on site. My major challenge, what I found here is that EU should be as less intrusive as is possible in order to leverage the maximum benefit of 3D. When it showed that reinforcement, again coming inside the 3D printing cavities, I think that is something which I feel should be avoided. Of course, that's purely a structural decision that we need to take. And point 2 is that you did speak of structural challenges for stability of the structure. And that's where I think you came in with the concept of a reinforced cement concrete. When I say reinforced, I mean the conventional rebars. Can that be replaced by ultra-high performance fiber reinforced concrete? Of course, the very first question that will come to the mind is then, how do we manage the rheology, because that will be a major clogger, if I say, it will clog the printhead and things like that. But I think the way to go must be that. So I was a little bit surprised, or probably for the positive time, you did not present that. Have you tried out the fibers in that so that we can negate the steel? And from what I can find is that the second and last point is the fenestrations that we get, the windows and the doors that we get in any printed, there again we need to have a lintel beam. So we have not been able to crack it. You print right up to the whatever level, say about 2.1 meter level, and then we pause there, then there's an intrusive activity of an foreign element coming, like a precast lintel beam or a metal beam, and then you again operate. You pause the printer and then you continue the printer. So first thing about the fiber reinforced concrete, and second one is how are you going to manage and look at that fenestrations being supported by an external element? Can we negate that somehow? What is your thoughts on that?
Oh, thank you for the question. So that's That's a good one. So we explored the fiber reinforced concrete and ultra high performance concrete and printed staircases and all, and it has a good load bearing capacity. But coming back to the removal of reinforcement, so these the reinforcement can be removed. It's for the residential building. It's not that important, and we can anchor it. Okay, that's not a big issue. That's what we are working on now. But the problem is trying to convince the engineer who is going to certify the building. So they always want to anchor it down properly and then core it. And so this wall and 6 meter by 2.4 meters we have tested. Every 3 meters we have a core wall. That means it's the rebars, and then it's just filled with the normal concrete. Okay, so which is not necessary based on our analysis. So that's the next project we are planning to push, and removal of all these columns in between the wall, so wall can stay. So the removal of reinforcement is depending on the application. It's not that difficult, particularly for the residential building. And your third question is related. The lintels. So we either we just print it outside and then place it as a ring beam on the top, or you can use the steel plate just to negate the lintel. So that's all possible. But we won't print all 2.4 in a day. It may be a few days, and then when the lintel comes, either you can use. But here, this particular one, we use the ring beam on the top. So, but you can use the steel plates. That's all possible. Thank you.
I have a small question.
Yeah, sure.
In this 3D printing concrete, you use the term rheological properties of material. My first question is, like concrete, what type of material that would be used, and what would be rheological properties? Just as a layman, just please explain.
So the material is depending on the application first. Oh, sorry. Thank you. So the material we are going to use is depending also on the application, which application we are going to use. So the rheological side, we trying to control, which control in different location of the printing process. That means when it's ready to pump, and then we want to have more liquid type material, and then we add the accelerators at the end to make it a bit harder. So you can control the rheology, that's the classical way, and during pumping and extrusion time, and we trying to play with the rheology. That's what I have shown, that vibration induced rheology control, and there are so many different magnetic particles, and all has been explored on how we can control the rheology. So there are so many research papers available.
I think we are running short.
There are a few things, yes, but I think the technology is matured enough to adapt for normal construction. But the housing is the big issue, as you have seen, and if we tackle that, at least it's half of the problem is solved, and then the rest major infrastructure development maybe we can think about later.
Yeah, thank you, Professor Raju, once again
Thank you.
for your good presentation. Yeah, maybe we'll move to the next set of presentations. I think from our volunteers I'm hearing some of the presentations are not yet uploaded. Can you please do it meanwhile? And yeah, we have about 8 presentations in the next set. And the first presentation is by Spandana and from IIT Hyderabad, and she's going to talk about the influence of aggregate characteristics on the buildability of 3D printing concrete. Over to you, Spandana. Yeah, we will stick to the time, and the maximum time we have allowed each presentation is 7 minutes. Please try to wind up within the stipulated time.
Good afternoon, everyone. I am Spandana Paritala, under the supervision of Professor KVL Subramaniam sir at IIT Hyderabad. And I am going to present on the influence of aggregate characteristics on the buildability of 3D printed concrete. So, if you can see, the current research is majorly focusing on the introduction of innovative materials in this concrete printing technology. advanced cementitious materials like UHPC, geopolymer concrete, alkali activated concrete, recycled aggregate concrete, and bio-based and earthen materials like clay, hemp, etc., and as well as composites and hybrids including multi-materials. As well as there is a strong potential to go for the advanced applications like remote housing, army bunkers, and field fortifications, and bridges and infrastructure, and the customized designs using the potential of 3D concrete printing technology of design freedom as well as the topology optimization, etc. But to achieve this, to incorporate the innovative materials in the 3D concrete printing technology, we require efficient material design methods which eliminates the intensive trial and error methods. As well as for advanced applications, we still have to adopt the usage of local materials so that we can go for different types of terrains and for different types of remote applications. So basically, the design of 3D concrete printing majorly focus on three areas: extrudability, shape retention, and buildability. The ability of the material to flow through the nozzle smoothly and continuously, and the ability to retain its shape right after deposition, and the ability to carry the weight of the subsequent layers soon after its deposition. And these three things depend upon three major parameters: the material parameters, printer parameters, and process parameters. If we leave the process and printer parameters like speed of the nozzle, pressure, flow, velocity, etc., the material parameter itself governs the entire printing process majorly, which are majorly paste rheology, aggregate content, and aggregate characteristics. If we see the literature, there is a strong foundation already laid on relating the rheology of the paste and aggregate content, like how the flowability of the paste increment can help in the incorporation of higher amount of sand content in the printable mixtures, and how the increment in the dynamic yield stress of the paste requires higher amount of excess paste content to achieve the sufficient flowability for the printing, as well as how the volume of aggregates influence the rheology of the mortar composition itself, which further influences the 3D printing, as well as how much the paste is in demand and how much is available in the mixture, which governs the entire print quality. While this literature has clearly reported the influence of paste rheology and aggregate content, there is very limited research that has focused on the characteristics of the aggregates, like packing degree, gradation, surface area, and shape, which all together influence the requirement of the paste that is required to fill the voids between the aggregate matrix, as well as the paste required to coat the aggregate surface, and the cohesion and segregation, and the interlocking and friction that it has to overcome during flowability. So, in this research, focusing on these parameters, we have adapted three materials: the river sand, crushed sand, and a blend of these two sands, which is in the ratio of 0.4:0.6 of river sand and crushed sand, which gives the maximum packing degree. And this is the gradation of the three materials. If you can see the characteristics of the three materials we have incorporated, the packing density, of course, as we have discussed, is highest for the blended aggregate, and next the crushed aggregate and the river sand. Whereas the mean particle size are very, very low in the crushed sand. That means it has, of course, the higher specific surface area as well. Okay, so the methodology we have adapted is varying the paste rheology by varying the super plasticizer content in the each test matrix, and of course the aggregate content which is required to optimize the material for making it extrudable. So in each set we have varied the aggregate content and verified which matrix is actually extrudable and retaining its shape, and each such test matrix is considered for each rheology of the paste. So this is the summary of the test setup done. So the paste yield stress, if it increases, the amount of aggregate content as we expected decreases for making it printable. But if you can clearly see the peculiar thing in this, the amount of aggregate content that we can incorporate for a particular paste yield stress varies depending upon the aggregate type. So it is higher for the river sand, and next to the blended sand, least in the crushed aggregate sand. we have dug a little and understood which parameters of these types of materials are exactly affecting in this result. And we understood that it is the sphericity of the aggregate and next the surface area of the aggregate which is resulting in this phenomenon. So if you can see, the river sand particles are much rounded and have lesser surface area to the volume ratio, whereas crushed sand are elongated, angular and has higher surface area, which has definitely resulted in the interlocking and the friction and made the mixture difficult to flow at the lesser amount of paste requirement. So it required higher amount of paste, or at a given paste rheology, a lesser amount of aggregate content was printable. So, next, moving on to the next process, we have done a similar study for the buildability of the 3D printed mixtures as well. Now, along with this variation in the superplasticizer, in each mix we have also incorporated CMC and the bentonite clay for making them printable. And the similar study is carried, and in these mixtures, this time, we have considered the mixture which is buildable with higher number of main layers, giving good surface quality as optimal mixture, and the mixtures which fail due to plastic collapse, geometry issues, and as well as surface irregularities and cracking are eliminated. So, for each type of matrix, we have considered an optimal mix, and this is the summary of the tests conducted. Like in the extrudability and shape retention criteria, even for the buildable mixtures, a similar trend is followed for different types of aggregate particles. But if you can clearly see, the paste yield stress this time resulted is very high compared to the previous one. So for extrudability, a little amount of paste yield stress and the combination of aggregate content for that particular paste depending upon the aggregate type was sufficient. But the paste yield stress is higher in this because we have incorporated CMC and nanoclay. The CMC by its nature retains the water, and nanoclay promotes the flocculation of the particles by which the structuration happens within the paste required for the buildability. So immediately, even if it is given a 2 minutes of rest, for example, which is the 2 minutes rest in the test protocol we have followed in the rheology test here. So within 2 minutes of rest period also, the flocculation happens immediately, making the paste stiffer. And under extrusion, like when it goes through the auger and extrudes through the nozzle, because of the shearing, it immediately flows easily, making the mix flowable. So these are the fresh properties we have observed for this, and we need to develop a design relationship for different types of aggregate materials for making the 3D printing technology applicable for different types of terrains using locally available aggregates. And this attempt has been previously made, establishing a relationship for different types of materials, and the current focus now focuses on incorporating different parameters within the paste and aggregates as well, which result in the structuration and the granular skeleton within the layer itself, which all together results in the good quality of 3D printing. Thank you.
Thank you, Spandana. Any one question? It looks like there is no questions. Yeah, well, we'll move on to the next topic.
Thank you.
Spandana. The next topic is evaluation of mechanical performance of concrete with silica fume as a partial replacement. Yeah. What is your name? Okay. Yeah, by Ankamarao. Did you upload your presentation?
Yes, sir.
Okay, second presentation. Wait. Yeah, that you can. Yeah. Yes, you can start.
Good evening to all. Today our topic is evaluation of mechanical properties of concrete with pumice and silica fume as a partial replacement. Myself T. Ankamarao, research scholar in JNU Kakinada. Next, introduction. What is the main problem in that particular concept is high self-weight of the conventional concrete restrict the applications of certain areas, increasing the cost and complexity. Our solution is lightweight concrete with pumice offer the sustainable and cost-effective alternative with reducing the density. Next, why pumice is concrete? Pumice is a natural volcanic rock in ideal aggregate for lightweight concrete and unique properties. What are the properties of lightweight of pumice? Significantly reducing the overall weight of the concrete and good insulating properties and enhancing the thermal performance of the structures, and cost point of view, high cost, and next, sustainable, environmentally friendly. Next, and next other topic, other point, I am using the silica fume. Why I am using the silica fume means the microstructures of the silica fume is the significantly enhancing the microstructure of the cement matrix and leading the refined pores distribution and densification of the interfacial transition zone and accelerating the second hydration point of view. In this particular point of view, I am using the 0.4%, 8, 12 and 16 and 20%. Next, main objectives in that particular point of view, evaluation. Assess the mechanical properties of M30 grade of concrete using pumice with different percentages 10 to 60%, and next silica fume using optimum percentage of the silica fume you are find outing by using 0%, 4, 8, 12, 16, 20%, and after that compressive strength is analyze the compressive strength and split tensile strength and identify the best percentage of the pumice aggregate. And next, experimental setup point of view, M30 grade of concrete using 10% to 60% of the pumice and silica fume. And workability point of view, I am using the workability point of view, super plasticizer Conflex 430, SP Conflex 430 I am using. And materials, what are the materials I am using? 53 grade of concrete and 53 grade of cement, river sand and local sourced pumice aggregates and silica fume. And what are the tests I am done? Compressive strength and split tensile strength of this particular by using compression testing machine. And why I am using the pumice aggregate? The properties of pumice aggregate, specific gravity of pumice aggregate is 1.05 and water absorption is 50%, crushing strength 81% and impact test is 20%. Next, M30 grade of concrete, I am using the mixed proportions by using IS 456-2000 and in that particular some points, considerations and 360. These are the values 695 fine aggregate and coarse aggregate 1250 and next water 162 water to ratio, water to cement ratio 0.45 and super plastics I am using 1% of the super plastics, SP complex 430. Next, workability point of view, slump cone values and by using different percentage of the pumice 10, 20, 30, 40, 50, 60 and unit weight reducing particular point of view adding of super plasticizers. First one 0 conventional concrete 8.39 unit weight of the cube and next average unit weight of the cube and 10% is adding 7.85 and 20% is adding on pumice aggregate 6.79, 30% is 6.42. After that, the last column, percentage of the weight reduction, first conventional concrete and 10% of the pumice aggregate adding 6.43 and 20% of pumice aggregate adding 19.7 and 30% is 40, 50, drastically percentage is reduced, weight of percentage of cubes. And these are the compressive strength of the pumice aggregate in 7 days, 14 days, 28 days. After completion of the maximum value, optimum value is reached at 20% of this pumice percentage using. And next, compressive strength of pumice with optimum value. I am choosing optimum value of pumice 20% and adding silica fumes of different categories 4%, 8%, 12 and 16 and 20%. I am at the optimum value of silica fume is 12%. I am reaching the compressive strength of value. Next, split tensile strength of pumice aggregate 7 days, 14 days, 28 days. At optimum value is 20% I am reaching and next pumice plus silica fume. Optimum value is reaching 8% in split tensile strength point of view. Next, expected outcomes. Workability point of view, slump cone is decreases by the 100 mm to 70 mm by the percentage of the pumice adding 0 to 60%. And compressive strength point of view, increasing the pumice percentage automatically after 20% drastically decreasing because of the self weight of the pumice aggregate is very less to compare to the conventional aggregate. Next, split tensile strength also similarly decreasing the showing that reducing the tensile strength with a high percentage of the pumice. And next, last conclusion, the study in that particular point of view, silica fume and pumice aggregate are significantly influencing on mechanical and physical properties. In silica fume, optimum value, compressive strength and split tensile strength refining the pure structure and densifying the cement matrix and enhancing the interfacial transition zone between the aggregate and paste. And pumice aggregate, effectively reducing the overall density of the concrete and making it suitable for lightweight structural applications, is maintaining satisfactory and moderate replacements up to 20% only. Next, combination of 20% of pumice aggregate and 12% of silica fume is achieving optimum values. And next, SP Conflex 430. Why I am using the SP Conflex 430 super plasticizer? In water absorption of the pumice aggregate is very high, to 50% of the absorption. That's why I am using the super plasticizer for this workability point of view, to increasing the workability. Thank you, sir.
Yeah. Thank you, Ankamarao. I think you are on time. Any questions? Have any question? Yeah. Okay. Yeah, I think if you don't have any questions, maybe let's move to the next topic.
Thank you, sir.
Thank you, Ankamarao. The next topic is estimating deterioration in calcine clay based alkali activated mortar using image analysis by A. Sharif. Yeah, please stick to the time, Sharif. It's
Okay, good afternoon everyone. My name is Ahmed Sharif. I am a research scholar from NIT Warangal. My presentation is on estimating deterioration in calcine clay based alkali activated mortars using image analysis. So this is the outline of my presentation. So we all know that cement concrete has poor durability in acidic and sulfate rich environments, basically due to its alkaline nature and decalcification of hydration products. So alkali activated binders can offer a sustainable solution, sustainable alternative which can offer comparable strength at enhanced durability. But alkali activated binders are mostly developed using industrial byproducts such as fly ash and GGBS, or natural resources such as metakaolin produced with high purity kaolinite. So there is a necessity to identify such alternatives which can meet the demand of cement at a large scale. One such alternative is low-grade kaolinite clay cements. So this study explores the durability of alkali activated binders developed using calcined clays from low-grade kaolinite clays. So as far as durability assessment is concerned, image analysis can offer a objective and non-destructive technique to assess the durability in chemical attacks, because the change in surface color and texture are strongly correlated with the loss in durability of materials. As you can see, due to like H2SO4 attack, the deterioration is clearly visible, so we can correlate it to the loss of durability. So in that direction, this study also utilizes HSI color space model to correlate between the image parameters to the durability parameters of calcined clay binders. So coming to what is color space models. So any image is basically stored in a raw 8-bit RGB values, which is that each pixel is identified by red, green and blue values. But the problem with this kind of color space model is it mixes brightness and color, which is not easy for human eye visualization. So HSI color space model is a model which actually transforms mathematically RGB values into hue, saturation and intensity, where hue represents the color of the pixel, saturation represents the purity or vividness of that particular pixel, followed by intensity representing the brightness of that pixel. So these RGB values can be transformed mathematically using these equations. And the hue value is represented from 0 to 360 degrees, with 0 degree representing red, 120 degree representing green, and 240 degrees representing blue. And the saturation is varies from 0 to 1, with 0 being grayscale and 1 being pure color, whereas intensity varies from 0 to 255, with the 255 being completely bright to 0 being the darkest version of the color. So coming to the materials that I have used in this study, we have sourced low-grade kyanite clays from Telangana, and this is the chemical composition of that particular material. It consists of silicates and moderate amounts of aluminates and iron oxides. So if you look at the morphology of that material, it consists of typical clay material with large impurities of quartz in it. That's what defines low-grade kyanite clay. If you look at XRD, kyanite is identified as the major clay mineral. It can also be validated from TGA studies, which shows mass loss from 400 to 600 degrees Celsius due to dehydroxylation of kyanite. Now we have produced this calcined clay at a laboratory level by oven drying, grinding, sieving, and then calcining it at 700 degrees Celsius. By that 700 degrees Celsius, we have done a calcination regime study as well. Now the quality of calcination is actually validated by XRD and TGA again. If we look at the XRD of calcined clay, we can see that the kyanite peaks are completely eliminated, and same is validated from TGA studies. So this is the methodology that I have followed. We have used calcined clay and GGBS as precursors for alkali activated mortars, cured it for 28 days, subjected it to different exposure conditions, and then evaluated its durability by using physical tests as well as image analysis at different exposure durations, which is 3, 7, 14 and 28 days, and then we have correlated its values. Physical assessment is done by mass loss, volume loss or dimension loss, and strength loss. So coming to the results, this represents the evolution of hue, saturation and intensity values with exposure duration. So for H2SO4 exposure, the hue values increases with exposure duration, whereas saturation values decreases with exposure durations, indicating that the orange-red color of calcined clay binders eventually loses its color, resulting into yellow tint with loss of true color in H2SO4 exposure. Similar observations could be made from MgSO4 exposure, but the results are not so indicative as H2SO4 due to because H2SO4 is acid, it aggravates the durability. The loss of durability is too high in that. Then coming to the relation between residual strength and HSI, similar is the case that the increase in hue value and decrease in saturation value of H2SO4 exposure are strongly correlated with the loss of strength. But the HCl correlation is not very evident. This is mainly due to this is an experimental anomaly which we had faced, that the surface of the samples spalled off during the procedure at 7 to 14 days, resulting in revealing the internal structure of those specimens which are subjected to HCl. Hence the correlation was very poor in case of HCl exposure, but it is very strong in case of H2SO4 and MgSO4. Then when we look at the physical assessment, so the total durability loss was very high for HCl exposure as compared to H2SO4 exposure, and there was a mass gain that was observed in MgSO4 exposure because this test was done only for 28 days of exposure. The mass loss generally would be visible in an MgSO4 exposure for a longer duration. Coming to the conclusions, the hue, saturation and intensity values evolve with a definite trend when it is subjected to chemical exposure. So definitely these hue values and saturation values can be used to predict the durability loss in H2SO4 and MgSO4 exposure conditions. As far as durability is concerned, HCl exposure resulted in large durability loss for calcined clay based alkali activated mortars, possibly due to formation of soluble precipitates such as calcium chloride, and this resulted in spalling off of material which could not which hindered the correlation of HSI values in case of HCl exposure. So image analysis can be a potential and potential non-destructive and rapid assessment tool for deterioration assessment of alkali activated binders. Thank you.
Yeah, thank you, Sharif. And any questions? No question.
Yes, sir. Okay, sir. Yes, sir. So actually, that study, one of our
You can just meet to Sir and then you can discuss. Maybe we are just. Let's move to the next presentation. And the topic is effect of steam curing on high strength concrete, evaluation using NDT methods by Arif Khan? Yeah, Khan, okay. Sorry. Yeah, over to you.
Hello everyone. My name is Ahsanullah Khan. I am research scholar at IIT Kanpur. This is the extended part of the study of the project sponsored by the Indian Railway. This is the Dr. K.V. Harish and the Professor Sudeep Kumar Misra is the PI of this project. In the project, the initial part of the study is the forensic investigation of the premature failure of the pre-stressed concrete sleepers. And the second part of the study, after that the study, there is possible causes given to the Indian Railway. They come up with the idea of their requirement. Their study, in this part, their study is the design mix of the concrete that can be used the pre-stressed concrete sleepers, and they developing that the framework to evaluation using NDT methods. And this is my presentation outline. There is steam curing early stage effect, steam curing later stage effect, application and advantage of steam curing, motivation of the study, objective, material and methods, result and discussion, and conclusion. Steam curing process for the pre-stressed concrete sleeper. The concrete frame is installed. Louder. Water. Okay, sorry. Okay. For the pre-stressed concrete sleepers, their frame is installed and there is concrete is poured into the framework, and after some pre-steaming period, their steam curing supply is applied, and after steam curing, that is demolded and the connection and other thing expected. For the steam curing process, there are several stages involved. In that, the pre-steaming period, it will allow 2 to 6 hours depending upon the requirement, and no heat applied in this duration. And the heating period, the temperature that is showing the upside where gradually increase at control higher rate, heating period. And the steaming period is the temperature reaches 70 to 80 degrees Celsius, constant temperature is applied at that stage. And the cooling period, they varies from the heating period. We gradually decrease the temperature with the controlled heating rate. And the subsequent curing and storage will be applied after steaming temperature is completed, steam cycle is completed. In the steam curing, there is, when we supply heat, in the early ages, the degree of hydration increases. And it depends upon the temperature. Sometimes degree of hydration 4 to 5 times increases depending upon the temperature. And in this initial stage, there are tricalcium silicate, tricalcium aluminate, tetra-aluminate take a part into the hydration process, and C2S did not take much part in the hydration process. And the hydration product is formed due to the steam supply. There is surface water is evaporated, but the continuous humidity is supplied from externally, so that it will maintain that the water is sufficient maintained to the system, and that enhance the early ages hydration product formation. That study in the literature is observed that with the steam curing, that the density of the CSH gel formation is increased, that improve the strength as well as durability properties due to the steam curing. And due to this increase the degree of hydration, in place of CSH gel, some aluminum will occupy space in between the silica, and that CSH gel, some spaces, some locations, there calcium silicate aluminate hydrate reaction also formed. Due to the steam curing, there are several studies already done, and there is on the basis of cement content water binder ratio and steam curing cycle regime, there is strength of the gain observed with the strength depending upon the variable parameters. at the later stage, due to the early ages steam curing, there are lot of effect happen that can cause the damage to the concrete in the later stage. In one of the heat damage of the steam cured concrete is observed because due to the temperature, high temperature, there is hydration also release the temperature, heat of hydration, and the heat is applied on the curing stage so that thermal stresses is developed and it is not developed enough strength into the concrete, and that surface cracks is observed at the concrete surface. That coarsening of pores is observed that can expand and connect it, then cause the surface crack on the surface of the concrete. Another is the DF damage that will be not looking earlier stages. It will affect on the longer age of the pre-stress concrete sleepers in the specimen also, that the monosulfate form at the early ages that get converted into the tringite at the later stage, that is expansion, that is volumetric expansion nature. They can cause cracks and durability problem in the future. And along with that, there is a volumetric change also observed. There is different kind of expansion will observe in the normal concrete, but here there is a shrinkage observed in the normal concrete, but in thermal steam curing, there is expansion behavior is observed because thermal stress is much high as in the normal concrete, and it is not developed yet by to diminish the shrinkage to the normal concrete. That's why there is expansion behavior of the shrinkage is observed in the volumetric deformation observed in the steam curing. So application and advantage of the self-steam cure concrete, and the application of steam cure concrete is the precast beam and girders and column can be used. Staircase and landings is used. There are a lot of application of the steam cure concrete, and there is also application advantage there. Rapid strength development compared to conventional curing, faster demolding and turnaround time, increased production efficiency in precast plants, better control over curing temperature and moisture, reduced dependence on the ambient weather conditions. So motivation of this study is depend upon this is the one is the rising urbanization, increased demand for prefabricated concrete construction. Prefabrication offers higher quality, reduced construction time and improved sustainability. Steam curing accelerates hydration but improper regime can cause cracking, delayed tangent formation and durability issues. Need for reliable evaluation and tools for quality assurance. Pre-steaming period affect the strength development. The objective of this study is the primary objective to evaluate the influence of pre-steaming delay on the mechanical performance of steam cured high strength concrete, to analyze how curing parameters affect strength development, microstructure integrity and durability indicators. Methodological objective is there to integrate non-destructive testing, UPV, rebound hammer resistivity with conventional mechanical test for comprehensive evaluation, to compare entity results with destructive test, establish correlation for practical quantity control in precast production. Outcome-oriented objective is to identify an optimal pre-steaming delay period that maximizes strength gain and minimize early age cracking, to propose a reliable evaluation framework for assessing steam cured concrete prefabrication sleepers, to contribute towards improving the performance, safety and durability of steam cured precast elements. So in this specification is given by there's some requirement is by the railway. There is the cement content should be 450 to 480. There no additional mineral enrichment can be used, and the strength should be 1 day strength should be 40 MPa more than after steam curing, and the 14-day strength should be greater than M55 grade. So on that basis, trial basis, mixed design come up, and this is the material properties. What here we curing regime use for this in this are delaying period of 1.5 hour, 2.5 hour, 3.5 hour, and the 5.5 hour. This is the strength assessment and durability assessment testing is there, and this is the methods. In the observed result, strength assessment, it is observed that the 1 day strength is normal curing 30 MPa, 28 days, 75 strength is observed, but steam curing it is multiplied, double the strength gain is observed, and in the rebound hammer test, in the no load condition, is the lower strength is observed, but under the 10% load condition will correlate with the destructive test strength measurement. In the durability assessment, the surface resistivity increased from 7 to 28 days, and the indicated continued hydration and pore refinement. A similar result is observed on the bulk resistivity also. Both the tests applied for the comprehensive overall resistivity assessment of the concrete. And the quality assessment were done on the 1 day, 14 and 28 days, so that we can assess that the development of the concrete throughout the period, and that observed that the 14 days all mixes exceed 4.4, that is requirement for the range for the quality control, and in the deuterium like 3.5 hour delay period achieve the highest UPV values, and D3 is the reduction due to localized drying and delayed drainage formation on the basis of literature reported. And this is the conclusion. What we observed that the 3.5 hour pre-steaming slate hydration refines the microstructure and enhances both early ages and long-term performance. And the strong correlation between CTM and rebound hammer is confirmed that the rebound testing under 10% preload is reliable innovative method for in situ strength estimation. Electrical resistivity also shows that the optimized curing reduces transport, improved durability through pore refinement. And UPV constantly increases with curing age and correlates with the compressive strength resistivity, validating it's an indicator of internal density and concrete quality.
All right, Khan, maybe we can quickly wind up. Thank you. Any questions? Yeah.
See, you have used the steam curing for durability and strength improvement.
Yeah.
See, if we, what would be its performance in the hot climate like Rajasthan, where the humidity is zero, and we work in temperature more than 45 degrees Celsius.
Steam curing happen in the controlled environment. That will be 24 hours, will be done in the controlled environment. Humidity is supplied internally with 90% relative humidity and temperature is gaining. So it is not open environment. It's done.
It's not in open environment.
No. That is complete public prefabrication process inside. That test also done in the humidity chamber.
I see railways only using OPC cement for the whatever the casting they do. Why can't they implement composites like blended cement or SCMs?
One of the reasons that the steam curing in that process, the technical process is that there is, if you add any mineral reaction, that react on the after some certain time, reaction is there. So early ages, hydration process has to be increased. The cement is the early phases that increase the hydration process.
No, we know, but even precast people are now started.
Problem, in this case, we did not study it. One of the reasons because the requirement by the railway.
I know,
this is not the research problem. This is a specification given by the railway, their requirement.
You have to change their mindset.
Yeah, I understand that. For the research purpose, we can do.
Have you measured, hello, excuse me. Hello, sir. Have you measured any shrinkage signs? Shrinkage signs.
Yeah.
Shrinkage signs, have you any measurement is there?
In this study, I did not do. Here, whatever so, I did not.
Yeah, well, I think we will stop it here. Thank you, Khan, for your presentation. Now let's move to the next presentation by Ninovat, and the topic is development of ternary blended low molar geopolymer mortar from industrial waste, a sustainable solution. Please try to complete within the time.
Good evening, everyone. Myself, Ashok. I am research scholar of NIT Warangal, working under the guidance of Professor P. Ratish Kumar. Here are my contents. And coming to introduction, we know cement is, concrete is the second most used material on earth after water, and cement contributes 7 to 8% of CO2 emissions, global CO2 emissions, which is a bigger challenge nowadays. We required about 5 million tons of cement by 2030. On one hand, we required more cement, and on other side, industrial wastes are being produced at large scale, and India produces more than 230 millions of thermal ashes every year, which is very harm to environment. Most of the fly ash will be used in many construction applications, and pond ash or bottom ash remains same due to its nature. Improper disposal of these ashes may leads to pollution in land, water and air leads to these three pollutions. And like gypsum is also having with same problem. And utilization of these kind of waste will leads to will support United Nations Sustainable Development Goals 9, 10 and 11. And like we use the material used for our study are pond ash, which is sieved through 90 microns, and industrial gypsum, GGBS, alkali activator with lower molar solution, 4 molar, and like 1:2.5 ratio of sodium hydroxide to sodium silicate, and like fine aggregate of zone 2. The methodology we have followed were same, characterizing the material, collecting the raw material, characterization of raw material, and initial mix design was formulated to 1:3, like 1 is binder and 3 is fine aggregate. And like the systematic variation of pond ash from like we have took large, we have set up a goal to dispose huge pond ash. So we have come from large to small, like we have took from 80 to 50% of pond ash, and like and GGBS we have took 15 to 45%. Variation in 10% increment, and like in pond ash we have decreased, for every mix we have decreased 10% decrease, and like we kept constant 5% of gypsum for all mixes, and we have done all the fresh properties, and we have calculated, we have cured at ambient temperature, not at any elevated temperature, and we have evaluated life cycle assessment of all mixes. And the chemical composition of raw material like pond ash, GGBS and gypsum. And here downside is the mixed design of all the mixes, like 80% pond ash, 70% pond ash, 60% pond ash, 50% pond ash. Like alkaline solution we have took for alkaline to binder ratio, not alkaline to solid ratio. That is from like 35 to 42%. And that results, coming to results, for like normal consistency and initial setting time and final setting time, we got results like due to increment in pond ash content, like due to porous nature of that pond ash, it demands more liquid content. And coming to compressive strength, like when pond ash is increasing, the strength got decreased drastically. Here XRD result demonstrate the same. Here it demonstrate that only CASH gel is getting decreased from 50% to 80%, and like no NaSH gel is formed at like 2 theta at around 62 theta angle. And FTIR results demonstrate the same. And coming to LCA part, for 50% pond ash, 45% GGBS, and 5% gypsum, we got highest results, in CO2 emissions and embodied energy emissions. Like we got reduction of 85.9% reduction in embodied energy, and around 48% of reduction emission in CO2 emissions. Coming to conclusion, as we discussed, due to porous nature of pond ash, initial setting time, final setting and normal consistency got decreased, and mixed with 50 to 60% of pond ash, we can adapt those mixes to structural motors, which is which whose strength is from 20 to 27 MPa for mix of 80% and 70%. We can use it for making bricks. And thank you.
Yeah, thank you, Ninawat. And any questions from the audience? Yeah, well, no questions. Let's move to the next topic. Next topic is role of SCMs in structural grade foam concrete by Abhinay.
Hello. Good evening to one and all. My name is Abhinay Rakam. I am a scholar from SR University, Warangal. Today's my topic of presentation is on role of supplementary cementitious materials in structural graded foam concrete. The reason behind this topic selection is everyone is saying that certain amount of carbon emission is being done when a cement production is being liberated. So the equal amount of carbon emission is equal amount of the cement production is done. So many materials like the different types of concretes, either it may be a geopolymer concrete, ultra high performance concrete, or many other different types of concrete are going to use a supplementary cementitious material. The reason behind this thought is why not the supplementary cementitious materials can be induced in the foam concrete, which is a lightweight material. So the content of the topics are introduction followed with the objective and scope of the work, materials and methodology, results, conclusions, and references. The history or the background of the foam concrete is not a new invention. So it was being invented in 3000 BCs, where the ancients used animal blood or some of the protein-based substances for developing the surfactants. So from 3000 BC, there was not an drastic, no significant was being observed in development of the foam concrete. Bayer, who was found initially in 1923, was made an attempt for development of foam concrete by using different kinds of the surfactants. So after 1990 or 1923, there was a significant improvement in foam concrete production technology, where the first building was being constructed with a density of 700 kg per meter cube as a roof insulation material in New Delhi. So foam, as I said, a foam concrete is a lightweight concrete where a major amount of the foaming agent are being used in order to make a bubble inside the concrete. So the density of the foam concrete may vary from client requirement that I will be showing in the next slide. The major advantages of the foam concrete are obviously the reduction of the dead load, then faster building construction, easily handle transportation charges, decrease the density permits to construction of the larger spans, and better thermal insulation and better fire protections as well as the sound insulation. The classification of the foam concrete was being obtained from the lightweight concrete. So where the lightweight concrete was broadly divided into lightweight aggregate concrete, where the lightweight aggregates will be going to use, and a cellular concrete and a no fines concrete, where no fine aggregate will be going to use in no fines concrete. So in cellular concrete, again the concrete has been broadly classified into two types, aerated concrete as well as a micro-perforated concrete. Micro-perforated concrete is nothing but where we will be going to use a maximum aluminum powder in order to develop the concrete. So in aerated concrete, again a gas concrete as well as a foam concrete. Gas concrete is a type of a lightweight foam concrete where hydrogen peroxide is being used, where the volume of the concrete can be going to increase drastically. So foam concrete is my topic. So depending upon the requirements of the strength, like it may go from different strength, different density properties. It may start with the 250 kg per meter cube, and even it may go for the 2000 kg per meter cube, depending upon the type of the usage. So the major ingredients of the foam concrete are obviously the cement binder, which is nothing but a binder, water, and pulverized sand, and the major ingredient is a foam. So in order to develop these particular foam, there are two different types of methods, which is nothing but a pre-foam method and a mixed foam method. So if we look into this particular picture, pre-foam method, the name itself is being indicating or identifying that a pre-foam, where the surfactant is combined with the water and they prepare 24 hours before the usage or preparation of the foam concrete. Then the surfactant solution which have been prepared will be induced into the foam generator by a Lawrence tube, and from the Lawrence tube the foam will be going to generated to the house out, in which it was being going to induce into a slurry of a mixture. The mixed foam method of the concrete is a combination of the both at an instant of time with respect to the liquid as well as the ingredients mixed at a time as well as our normal method. The drawback of this mixed foam method is there is a no consistency maintenance of the bubble has been appeared. So as I said, a foam concrete, the major challenging issue is to stabilization of the foam. So if you see, the foam consists of a lamellar layer as well as the air content. The major part is maintaining this particular lamellar layer thickness is a very much crucial in foam concrete production. So that is the reason there is a big challenge and a big research gap has been still in a point of era for stabilizing this particular lamellar layer thickness. So when I start saying about the foam, obviously the foam is generated by different surfactants. So this is somewhat a chemistry part. If I go on adding, I can give an example like when we keep on adding a surf excel to wash our clothes, obviously certain limit of surf excel is sufficient to remove our particular dirt. Then after, if you keep on adding the excess of surf excel or whatever the surfactant which you are going to remove this particular dirt, there is a no use. So as the graph itself is indicating that whenever the surfactant concentration is optimum at CMC concentration, when you add more surfactant concentration also, there is a no use, where the particular amphibic formation will be like critical missile formations. So these are the basic classifications of the surfactants or foaming agents, natural and synthetic. So this is a comparison between the natural foaming agent and the synthetic foaming agent. Usually natural foaming agents are basically from protein-based foaming agents, and synthetic foaming agents are the commercially available, which depends upon the different charges like anionic, cationic and non-ionic. So in my work, the motivation of the work is to induce a supplementary cementitious material in order to reduce the usage of the cement content. So these are the objectives of the work. These are the basic objectives which have been preliminary doing in the laboratory scale level. So these are all the materials which have been used for preparation of this concrete. So this is a methodology. So in order to satisfy foam concrete, in order to satisfy fresh state properties, obviously a foam concrete should satisfy according to ASTMC 796. So ASTMC 796 indicates that if you are targeting a density of 1500 or 1800 kg per meter cube, it should be plus or minus 50. So if it is satisfying within a plus or minus 50 range, then you can consider this particular foam concrete for the large scale production as the next experimental work. So these are all few compressive strength and values where different densities by using of 5 to 20% of supplementary cementitious materials of silica fume as well as the GGBS. This is a water absorption results which have been primarily done. These are all the pore size distribution. So even we did a pore size distribution by cutting, taking a cube and cutting the cube into different 6 phases like parallel to parallel, perpendicular to perpendicular, perpendicular to the parallel with making some thickness. So we done with by using microscopy analysis, optical microscopy analysis, from where the images software is used in order to identify the pore structure of this, from which circularity or the frequency of the diameter of each and every pores with and without SEMs have been calculated. So this is a proper microstructure, and the results indicates that 10% of silica fume in comparison with the GGBS had got strength better, higher, that is 19 MPa than compared with the other mixes. So generally normal foam concrete may not be going strength which is more than 20 to 30 MPa. So that is the reason the foam concrete is not coming to picture for using in the structurally loaded, structurally beared material. So still a lack of research is being in order to maintain or make the foam concrete as a structural graded concrete. Thank you. If any questions.
Yeah, thank you, Abhinay. I think next we'll we'll move to the next topic. We are running short of time. The next presentation by Shinde, his topic is study on graphene oxide and hybrid fibers in enhancing recycled aggregate concrete properties.
Nagaratna Swami sir. The topic is the study of graphene oxide and the hybrid fiber in the enhancing the recycle aggregate concrete properties. The presentation is followed by the introduction, materials and methods, result and discussion, and conclusion part. The pollution is nothing but the resources we are not harvesting, and we are allow them to disperse because we have been ignored about their values. Next, introduction. The nanomaterial, particularly carbon-based derivatives, are the most demanding in the cement-based compositions. Now, in my research area, I have selected the graphene oxide as a nanomaterials. The graphene oxide, it is derived from the oxidations of the graphite, and if restoration is happened, then it will form the graphene, and its reduction is there, then it will form the reduced graphene oxide. Now in research area, I have used the graphene oxide as a nanomaterial. The graphene oxides and the hybrid fibers in the enhancing the recycle aggregate concrete properties. The before use the recycle aggregate, already it is a very challenge to again use the recycle aggregate, because the water absorption in the recycle aggregate is very more. That's why we have used these materials. Initially, we have taken the concrete without graphene oxide, and we have compared that concrete with the graphene oxide. And mostly we have focused on the two grade of the concrete. First one is the M50 and M70 grade. These are the compositions for the OPC cement, and microsilica also we have used. For the recycle aggregate, as I have discussed about the recycle aggregate, the water absorptions is the most challenge. That is the 3.84% water absorption is there. Then next is the mineral graphene oxide properties. The specific gravity of the graphene oxide is 1.67. Then surface area is very more in case of the graphene oxide, because it is a very nanomaterial. These are the some SEM images of first SEM image is cement, next one is the microsilica, and third one is the graphene oxide. In the graphene oxide, we can observe the flaky structures of particles of the graphene oxides, and it will allow the more surface area for the bonding. In the concrete, we have decided a two grade. Earlier, I have stated here, the two grade we have discussed, that is the M70 and M50. For the comparison, initially we have taken one control sample with a recycle aggregate without graphene oxide. Then we have decided the M70 mix design with the graphene oxide. Then again to study the different types of the fiber in the enhancing the property, we have added one polyvinyl alcohol fiber, that is the PVA fiber we have added. Then basalt fiber, individually we have added the PVA and the basalt fiber. Then again two mixed fibers we have added, that is the basalt fiber and PVA fiber. Then second composition we have prepared for the M50. M50 same control sample fibers we have added. But before adding the graphene oxide, it is very essential it is very essential to optimize the graphene oxide. That's why initially we have optimized the graphene oxide on the basis of the mortar sample. Initially we have used the AM1 to AM4. This sample we have used in the 1:1 proportion. Then BM1 to BM4, this sample we have used in 1:3 proportions. And with the help of this, we have also changed the percentage of the graphene oxide. Initially we have used the 0.025. In first case, that is AM0, we don't have the graphene oxide. Then in AM1, we have added 0.025% of graphene oxide. Then gradually we have increased till the 0.1% of the graphene oxide. Similarly, in BM1 to BM4 also we have gradually increased the percentage of the graphene oxide. And it is observed that, in the result it is observed that AM2, that is the graphene percentage is 0.05% is the optimum percent. In compressive strength also we are getting the maximum compressive strength in the optimum percentage of the graphene oxide. In this way we have optimized the graphene oxide. Directly we have used the optimized percentage of the graphene oxide in the concrete. And we have prepared the concrete like this. For the M70 we got the result. ACO is a control sample, then AGR plus PVA, AGR plus BF, AGR plus BF plus PVA. And according to this, we have prepared the mix design. And finally, we got, these are the mix design for the M50 also. The test we have conducted here, the compressive strength and the split tensile strength. These are the results we are obtained here. In every cases, if we are adding the optimum percentage of the graphene oxide, we are drastically increase the compressive strength. In every cases, we are increasing the compressive strength. But maximum compressive strength we can get in the both the fiber. These are the result of the split tensile strength fiber. The conclusion, these are the conclusions we have derived. That is the optimum percentage of 0.05% graphene oxide is increase the compressive strength as well as the split tensile strength. Thank you.
Yeah, thank you,
Yes,
Shinde. Any questions from the audience?
Sir, in one of your table, you have shown that the concrete without graphene oxide has no plasticity.
Yes, sir.
So means workability is not concerned. You have not maintained same workability.
Water is considered.
If you can just see the slide, you have shown the plasticity as 0. Yeah, before that. Yeah. Here you have dash. You have shown the dash. That's what actually plasticity is not there.
In which case, sir?
The first one, BC0.
Here.
So here you have maintained water same 187. You may
Yes,
be
sir.
having flowability maybe less, what I feel. Because you have done a comparison with the Geo and
Yes, sir.
without Geo.
Sir, first case we are not considering the geo.
Okay.
This first combination is without geo, and later the G stands for the geo percentage we have added here.
That's right. But in case without Geo, the
Yes, sir.
water content is same.
No, sir. Water content we have changed. Water is 187.
187 and
But
187.
here, in case of if we are using the geo, then we require the more water. That's why we have used the plasticizer in that case.
So but-
PCA-based plasticizer we have
But in
used.
control concrete, you have not used any admixture. Why?
No, sir. Because we don't require the plasticizer there.
Okay.
We have kept the water constant, but we have increased the plasticizer in the geo. If we are adding the geo, then we require the more amount of water. That
In case we reduce water also and then use, I think we can get more strength.
okay. But in that case, we have to add the more plasticizer
That's right.
to maintain the
I think,
workability.
maybe we can stop it here. You can have a discussion with sir maybe of some time. Maybe
Thank you, sir.
we'll
Thank
just
you,
go
sir.
to the last presentation. And last presentation by Venkatramana, and his topic is graphene driven nano engineering for next generation cementitious system. Yeah.
Good evening to all. I'm honored to be here. Yeah, recent times, our concrete industry is suffering with new challenges because of the raw material fluctuation in raw material quality and consistency, and at the same time, high performance expectations. And the conventional materials are reaching their limits. So we need a new technologies that can act at concrete microstructure level, and nanomaterials offers this ability by influencing hydration and filling and as well as bonding at nanoscale. At nanospan, we are bringing SpanoCore, a graphene technology platform which can improve your concrete performance predictable way and controlled manner. I am Venkatramana Gedala, CTO and co-founder of Nanospan. So understand further about SpanoCore, we can understand why nanomaterials matter. You can see this graph. If you want to improve your concrete performance, you should particle size and surface area of your materials plays a vital role. So these nanomaterials can fill microvoids, and it influence your hydration, and it bring more binding at cement matrix. But at the same time, selection of the nanomaterial, converting them into practical, compatible, and cost-effective way still remains a challenge. So that's where we want to exactly bringing this SpanoCore technology to how it influences your microstructure and how it behaves at real-time concrete applications. So we realized that just mixing graphene into your cement doesn't give your expected results. You know, what really matters is how it reacts with your cement matrix, how it nucleates, and how it fills, and how we can bring that one into cost-effective way, right? So we are bringing these three engineered mechanisms. Through these mechanisms, these synergetic effects even make it more powerful. So now let's see how we are bringing graphene as our core nanomaterial as a meaningful platform. So the nano seeding is our first effect. So this is our main effect. So with this nano seeding effect, we are bringing uniform hydration, and as well as minimizing your thermal stress while pushing your hydration uniformly, and also it is bringing crack resistance. That's why, because of this nano seeding, our SpanoCore based products are doing very good in concrete, particularly in early strength concrete applications. So this is the microstructure. You can clearly see the difference between regular concrete and the concrete without additive. You can see the differentiation. So in a regular, the hydrated particles are randomly oriented, and it agglomerated and is loosely packed. Because of the growth, there is no guiding growth. Coming to the nano or additive based one, these are the graphene nano sheets. This brings the nucleation effect, and it guided the hydrates in a particular manner. You can see all hydrated particles oriented perfectly and in a perfect shape. So this more crystalline. This brings the more denser microstructure, and this also brings more packing density to your concrete grade. And now another mechanism is how we tackle with low reactive or slow reactive materials like SCMs, where you want to make more sustainable concrete practices. So if you want to increase your SCMs in your concrete grade, but the reactivity plays major role, right? So here the mechanism is nano activation. You can see the 7-day hydration thing. So you can see the regular concrete only 60 to 65% hydrated, whereas in our additive it is 90 to 95% hydration happened. Because of this nano activation mechanism, we are bringing more nucleation CHS gel formation in early stage, and that too without affecting the thermal stresses. Okay, next we will see with our another and key mechanism is nano filling. Right? If you see clearly the difference between the regular concrete versus our additive based concrete, in a regular concrete, these are all micro voids presented in our matrix. Because of the size of the my material, graphene sheets fill these micro voids, and also it is bringing threefold important properties to your this one. First one is these nano sheets, because of the sheet-like structure, it oriented in the micro void, and it remains same during your hydration. And these sheets act as a heterogeneous nucleation sites and minimizing your thermal stress during early stage of your hydration. And the second thing, because of this layered structure, it acts as a micro reinforcement effect with, to mitigating your micro crack propagation. You can clearly see this micro crack propagate up to this level, and our sheets act as a load bearing at micro level. So with this filling, we are bringing more packing density and thermal resistance, and as well as improved durability. All these three mechanisms, if you combine, the synergistic effect is more powerful. You can see this. With this one platform, we are bringing a controlled hydration. That's why it less thermal stress, and your microstructure is more densified. So that's why your porosity is reducing, and also it improves the durability. And the third, at crystalline level, it became more stable, which resistant the shrinkage and thermal cracks. And also we observed strong ITZ bonding with our platform, so that you will bring the more structural integrity and also durability to your grade. So based on these principles, how we formulated our products is, for example, in a three critical challenges, if you want to make a blended mixes, that means your SCM content, if you want to push toward the higher level, so the reactivity is the problem. So here we are bringing nano activation is a lead and supported by nano seeding and nano filling, so that we are making your more activation and as well as acceleration to your grade to get your early strength without trade-offs. The second, in the HPC and UHPC cases, nano filling leads supported by nano seeding and as well as nano activation, so that we are eliminating micro voids and bringing more packing density, and also improve the early strength as well as long run strength. And with the crack mitigation, we will bring all together as a synergistic way. So these are the practical applications based on that principles. How we are bringing this one, I will give you three examples. One is the Mahindra & Mahindra test track project, Chennai. So the baseline is fixed. They want to improve the flexural as well as compressive strength. We are bringing that compressive strength improvement with reduction of steel fiber by 20% of that. So in the case of early strength, that in the Rajasthan side, so the fluctuation in the temperature recent times drastically hit their production. At 24 hours, they got only 14 MPa with M40 grade. With our Spanner Quick, we bring 24 MPa in 16 hours, and in 24 hours, it is around 40 MPa. Though the temperatures are low at Rajasthan right now. And the second one, steam curing. The steam curing based the piles. So they got 75 MPa with microsilica 46. We are eliminating microfibers, microsilica, and we got 80 in 24 hours. So like that, with this platform, we are bringing early strength without any thermal stress and without any durability effects. Thank you.
Yeah, thank you, Dr. Venkatramana. Any questions? Yeah.
Wonderful presentation. My small question is the durability part of this, and then reduction of this carbon footprint.
Yes, sir. So these are the technologies we need to adapt to make it sustainable and more durable, because these factors are place your microstructure. That's where the real behavior starts.
How much will add to durability, and how much carbon dioxide
Use case to use case, sir. Mixed design to mixed design vary, but 10 to 20% is we are improving the durability.
The effect would be there. Thank you.
No, sir, it is different. The microsilica mechanism is different, graphene mechanism is different. Again, based on your mixed design and water to cement ratio, what you are maintaining. Again, so that's where. So it is again additive. So ours also water reducer. You need to balance with 60-40 ratio. So 40% you can reduce your admixture and 60% is ours. For example, if you are using 1% admixture in your mix design, simply you can mix 60% of my product and 40% of your regular admixture.
Okay, thank you.
Yeah, I think we will stop here, and I would like once again I would like to thank all the speakers for your valuable presentations. Now, over to you, sir.
Thanks to all the speakers and research scholars, and most importantly the session chair, Professor Bhagat Singh. Thank you for that very articulate holding of the session. May I request you to please come on to the stage, sir. And may I request Dr. Koka Narasimharaju Garu, the chairman of the Raja Mahendravaram Indian Concrete Institute Center, to please preside. I also request Mr. Vijay Ranjanji, our GC member, to please come on to that stage to do the honors on to the erudite session chair on behalf of the Indian Concrete Institute. Please move on to the Yes, ladies and gentlemen, now you can applaud the session chair. Thank you so very much. Thank you, Dr. Bhagat Singh. Please remain on the stage, sir. Now may I request Dr. Pat G, which you fondly call, kindly come, sir, onto the stage. I also request Professor KVL Subramaniam, sir, to join us to honor Dr. Pat. Thank you, sir. Dr. Pat Rajiv Garu, your presentation was very engrossing and interesting, like all the other presentations. Thank you for that. Thank you, sir. Now for the photo op. Thank you, Dr. Pat. Thank you, Vijay Ranjanji. Thank you, Dr. Kokaji, and Professor KVL Subramanian, sir. Thank you so very much. And ladies and gentlemen, now we have at another very, very interesting session, chaired by a very senior professional who has come all the way from Delhi, Engineer Pradeep Garji, the Chief Engineer from CPWD. I request Pradeep Gar, sir, to please come over, take the stage, and conduct the next session's proceedings, which you will see one of the most senior, most professionals making their presentations. There will be 3 presentations, and we'll do it swiftly. Thank you. Over to you, sir.
Thank you, Girish ji. I think all of you can see we are almost running 1 hour late. But I'm lucky enough that I have 3 very experienced speakers. So they know the value of time also, and they will cooperate with us. So we have 3 excellent presentations. The first one is from very reputed, I'll call it the chemical man or the construction chemical man, Mr. Nilotkar Kars from Sika. He's MD, and he's going to speak on low carbon high performance concrete from lab to reality. Second presentation we are going to have from Engineer Florian Crane on large NATM cross section of urban infrastructure, very interesting topic. And then we have Mr. Mrinal Mitra, who is going to take us future belongs to living structures. So since we have an award, IC award function, All India award function also, which is supposed to take off from 6:30. So I request all the 3 speakers to use all your expertise to be very brief and take around 15 minutes time each. 12 minutes plus 3 minutes, sir. We'll give you an alarm at around 12 minutes, then 3 minutes for you to conclude, sir, and kindly take the stage. So first of all, I request Nilotkar sir to please take the stage and take us through your talk. Thank you.
So 900 seconds, huh? So I'll try to finish whatever I can. It's always a challenge. Yeah. So we're talking about low carbon, high performance concrete. So I'll just, what it really means when we talk about that, and some reference projects as well. So it summarizes the 3E, which is basically economic and ergonomic, less vibration, less human intervention, and obviously high amount of supplementary materials. But what is very important is it's self-consolidating in nature. What do admixtures do? To push this low carbon high performance concrete. So between technology, between the speed at which you can complete the concrete placement, including complexity of reinforcement and where you need to pour the concrete, and also efficiency, which is lower carbon footprint. Market needs, everybody knows, challenges of sand, skilled labor, traffic conditions, long slump retention. These are very, very challenging as well. Yeah. And we're basically trying to contemplate between giving long service life and high performance. And high performance does not necessarily mean just strength. So if you look at this, in terms of permeability, in terms of diffusion, in terms of resistivity and corrosion, high performance generally should meet all these requirements. So it's the optimum water binder ratio we are talking about, and basically trying to fulfill lot of properties fresh and in hardened state. Yeah. And the famous, the coefficient of permeability versus porosity, which is always to be kept in mind if you need to keep your structures durable over a longer period of time. So how do you do low carbon high performance concrete? Is basically you work on the water binder ratio. So between the CaO, SiO2 and your Al2 or 3, that's how you basically try to fix up your supplementary materials with your cement. And this is basically obviously to give more gel, because more gel means less porosity, and you have all the 4 different properties required for high performance concrete. Also, it's very important for the aggregate fracture, the bond between the cement paste and the aggregate is very important. And this is also one of the key factors of high performance concrete. Now, if you look at all the high rises, from left, and also you look at the infra projects, whether it's the bullet train, whether it's the RVNL up in the north, or the coastal roadways, all these have demonstrated something which is impossible in terms of what you need to actually achieve in terms of durability. I will skip the video for interest of time, but everybody should know that there is a very important aspect of tailor-made admixtures. Because if you don't have tailor-made admixtures for high performance concrete, then you're not going to achieve the properties which is required by FNARC in self-compacting concrete or self-consolidating concrete in terms of passing ability, flowing ability, and segregation resistance. So it's always the play of the fishbone structure of the admixture, which is the main trunk, and the polymers. Yeah. So these are different formats, whether you want to increase the chain length, whether you want to redesign the polymer, and that is how you get. If you see the dark structure, that's the cement, and this is how admixtures play in terms of dispersion and slump retention and rheology, which is very important. Now rheology is simple, is between honey and water without segregation. So you need to have flowing characteristics like water, but at the same time prevent segregation and bleeding. So, if we talk about traditional concrete, it's very cost effective, slump, and you talk about the classical concrete, you're trying to design self-compacting concrete for 30 MPa or 40 MPa. By default, you get 60 MPa. Now that's over-designed. So what you try to do with low carbon is you keep the cementitious content same. You might increase the supplementary materials, play around with the water binder ratio, and have a tailor-make admixture to basically ensure that there is cost effectivity as well as flowability. And when we talk about flowability, I know there is a very loose term used in the Indian construction industry, that flowable is equal to self-compacting, which is not the case. Self-compacting follows FNARC and IS guidelines, which is passing ability, flowability, and you need to use the J-ring, because if you do only the L-box and you don't do the V-funnel and J-ring, then you don't have SCC. and you loosely talk about flowable concrete. And that is where I think the BIS needs to take a lot of attention, yeah, to actually specify these tests, which are very practical and done all over the world. And in specific sites in India as well, I have seen. So these are basically various properties of the L-box, V-funnel, as well as the segregation resistance, how you measure it. This is an example. You can see both having equal flow, but again, what is the V-funnel? The outflow time, which is very important, half of it. And that is what actually defines SCC or self-compacting. And when you talk about low carbon, which includes optimizing water binder ratio, optimizing cementitious content. This is again another identical mix design. And then you have the rate of flow, which is very important, the L-box. And the most important thing is you can see and you can visualize this in this small video clip taken from one of the major projects in India. As I said, from lab to reality, it's about the mix, the cohesivity of the mix, then the test, which is basically again the T500, the rate of flow of the concrete on a flat panel with the slum cone and how fast it crosses the 500 mark. Then you will see the next one, which is also very important, which is again, you can see the L box. It is how you open the orifice and how it flows. Then you have the V funnel as well. Is very important for people who are very much interested in having durable structures, which is all about the J-ring. So this is the V funnel. This is the J-ring. You can see the rebars simulated almost to the reinforcement. It can be 38, it can be 57 millimeter, and you measure the height inside and outside the ring, and that is what qualifies. And we try to avoid these tests, and that does not qualify for an SCC mix. We call it loosely flowable. So just to summarize, tailor-made admixtures which can actually impact in terms of flowability, rheology, performance-based, and also give you the 4 critical properties of durability, whether it's a rapid chloride, ion diffusion, coefficient of permeability, ISAT, and water absorption. So if you look at low carbon SCC, and I will just give you what is the overall savings as done with independent consultants, it's almost 1.5% in terms of saving of construction cost. And this has been proved in many projects within India and overseas. But I will only keep Indian references because people generally have a tendency, to snigger when it is overseas projects. So if you talk about a value curve in terms of comparing traditional concrete, TVC versus low carbon, you can see across the different properties how you get enhancement. So just a few, start with the very basic project of M20 grade, Bangalore Development Authority. This is a slum rehab project which was done with M20 where you had modular formwork and the project was 6 months behind, actually was delivered right on time. And you can understand when slum rehab projects are done, it has to be done very efficiently. Sometimes the finish is so smooth you can see your face on the concrete, and that is what you require. Some projects again where pump operating pressures are reduced by about 30%, so there is a saving there. Cut carbon footprint because you require less fuel to burn when you have to pump at a higher pressure versus lower pressure. Again, World 1, M95 concrete, very easy pump operating pressure up to 100 meters. And this is where you need to see what is the piston delivering, what is the number of strokes for the piston to pump the concrete. And there are various other parameters which go along with it. Pashmina Waterfront in Bangalore is also another ideal project where this has been executed. And when we talk about infra projects, Sange hydroelectric project, pumping 2.1 kilometer for a 25 MPa concrete. This was unique, single stage pumping. And this is all delivered with low fines, low carbon, high performance concrete. I'll show you another one, which is Sikkim, 2.4 kilometer decline at almost 3 to 4 degrees. And pumping and decline is always a challenge because it can choke the pump. This is again another high performance concrete using bottom ash, where 50% of the sand is replaced with bottom ash to give you a 5% or 10% concrete cost reduction. In fact, there is a stretch which will be actually laid. It's about 500 kilometers in Maharashtra, which will be using bottom ash for the first time. Of course, the conditions are that your project site or wherever, it has to be in close proximity to the thermal power station to use the bottom ash. And bottom ash also has some strength development properties. So this is a patented technology from Jadavpur University, working with a consultant, and of course with an admixture supply, because it requires tailor-made admixtures. Last but not least, because I have 45 seconds and I will honor time, IIT Tirupati, again landmark project, where again low carbon SCC was used for 40 MPa concrete using the typical properties required. And you can see the pictures, these are not photoshopped. These are giving you fair face concrete to the best of its ability without or minimizing blowholes, honeycombs, etc. You can see the structure as it has been erected. Even the height or the lift of each SCC level was almost at the level of 4 to 5 meters without segregation. Yeah. This is a data center where 22% CO2 emissions, and you can calculate from cradle to gate actually, in terms of the transportation, in terms of the placement, in terms of no vibration, etc., what it delivered from converting a double blend to a triple blend. So I will end here. There are more other exciting things, but anyway, we will respect the audience time. But if there are any questions, definitely, yeah, we have to hurry through sometimes for the honor of time. But it's pleasure to present to an august audience, and thank you very much for your kind attention. Thank you.
One quick question, sir.
Question.
One question.
Yes, please.
We are using different plasticizers of the super plasticizers. We are using different super plasticizers for different types of cements. Is there any compatibility issues when we are using different type of cements for the different super plasticizers?
Yeah, you were talking about the cement and admixture compatibility.
Yeah,
you do carry out that. And of course, you're understanding the cement characteristics is not just the blends, but it's also the different properties when you look at the certificate and you do some quick tests on a mini slum cone. So that is how it is done. And these are available over 2 hours or 1 hour, and to establish it over a period. And it's not only cement, it's this binder content. Because different binders have different properties. Now, I don't want to make it into a highly technical thing, but it's always trying to fit that famous triangle of supplementary cementitious material.
Thank you.
Sir, we'll take one more question.
Yes, sir.
Yeah, I'm Srinivas Reddy. In fact, we work together.
Yeah.
I come from the industry of CC, and now today I use this on day in and day out in waterproofing and structural repairs. So, in fact, this reminds, and immediately I Googled, I got my paper which I made it in 2006 and 7 when I came and became an entrepreneur. So it is construction chemical industry and issues and challenges. It's a very good, the technology has been coming, we came from ligno, naphtha, then melamine, I think PC, now we are talking about self-compacting and self-leveling and all these things. But how we do translate this, the case studies what we have shown is all infra or mega projects, where there is a quality control, quality assurance, and there is a big like engineers like CPWD or somebody will be there. But a common man, my worry is we have to immediately, when the technology is there, especially in CC, why it is not growing is because still we stuck between, probably you are the CCMA current chairman or something like that.
No, I have got no affiliations at present times. Yeah, please go ahead.
We have overcome.
Yeah, please tell me your question. Your question, please.
See, the technology we are getting, but it has to be commoditized the challenge is, one is general issues, fine, we have to have an association, things like that. Second is the financial issues, the economic part, whether when we do it, like 53 grade cement, when we got it, now today it is a commodity and something like that. Second is about the human resource issues, which you have highlighted. That is exactly the problem is. In a mechanization, there is no problem. Mechanization, there is no problem. But in the usage, if there is any problem with the dosage...
Yeah, so I'll just take your question quickly. So if you talk about the bottom of the pyramid project,
yes.
I showed you a slum rehab project. Yes. And there have been many projects which obviously have been highlighted in different forums.
My closing remark or suggestion to you is that we should have creating knowledge to the consumers, end users is must. So maybe we can have an ecosystem where this technology should not be kept in the lab, as you rightly said, lab to field. But in the field, it should be a big cricket ground, not a small backyard or a few high individuals who has the luxury to use these products. Thank you very much.
Very good. Thank you very much for your comments.
Thank you, sir. And you have been saving us money by your technology, and you saved the time also. So we are doubly grateful to you, sir. Now I will invite the next speaker, Mr. Minal Mitraji. So first we'll have Mr. Minal, then we'll have Mr. Florian. Mr. Minal, please come forward. He is going to talk about the future belongs to living structures. Sir, you have 15 minutes, 12 plus 3. Thank you.
Just before Mr. Miral takes over, let me remind you that today evening we will have the awards function of ICI. We request all of you, we invite all of you to this award function which will be held here. It will be very brief, that will be followed by dinner. So please be seated in this auditorium. Please be part of this award program and join us for dinner after today's session. Thank you. What do you say?
You have to put up the presentation. Have you loaded your presentation, sir?
Good evening. As time is the essence, my good friend was saying me very courteously. So let me start it. Let the presentation come. So, good evening all and everyone here. I believe and hope after all these 2 days of continuous presentations and knowledge transfer, you are all doing very, very well. Congrats. I will try to make this session a little more lively and make us more alive. Let me try it. Let me see. So, as we stand today in this ever-changing construction industry or ever-changing industry which is fast and furious, mastered with AI, construction industry is following the same. It is not far behind at all. Fortunately, our structures are also not far behind. They are right now lively. Lively in the sense how? Self-healing concretes are a reality. Integral crystallines are there, were there. Sustaining our fact that yes, our structures are becoming alive, or rather lively. Now let us try to understand what is better? Do you want to keep your structures live or lively, or do you want them to make alive? Actually, if you think a little deep, you will find that structures or our concrete industry became lively is actually a reactive mechanism. So reactive mechanism, how? Reactive mechanism means once the damage has already set in, the healing process begins. Or once the damage is already there, you are trying to heal. It's a reaction, not a response. So that's the reason why we are still dealing with this reactive mechanism. Is it okay? Is it still not on? Yeah. So what we are doing is this reactive healing. Is it not better that we change ourselves from reactive healing to proactive health? What do we mean by that? What is proactive health? Proactive health gives us insight to make our structures self-sustainable, and that is the challenge. How? How do we make our structures self-sustainable? We make our structures self-sustainable by making it or building or imparting immunity to that structures. By how? By giving them the ability to resist all the changes, resist the attacks, by allowing them to regulate the internal and the external environment, regulate what is coming inside, to maintain the equilibrium all want to have this sustainability what we want to achieve in our structures, to make them self-sustainable and alive. Over this period, we will understand that building immunity is not a single step process, but it's a culmination of many steps, of which one of the building block is to give or attain breathability to your structures. Breathability, as we say, is the engine of equilibrium. Breathability, how? Breathability allows your structure not to suffocate, but to breathe, to allow the entrapped moisture or water vapor in the surface, in the structures, to diffuse out into the system, in turn making the structure attain the internal equilibrium, relaxing its internal pressure so that it can be permeable and also in the process becomes breathable. Breathability is making it alive. We are all alive today, sitting here, kicking, because we can breathe. So making our structures also breathable keeps it or makes it closer to attain self-sustainability. But it is not the singular term which will allow us to attain this. The next one is dryness. Dryness is the mandate for structural health, we say. As we have gone through enough presentations, I think you will agree with me that moisture or excess moisture is the singular capillary action or catalytic action for the cascade of distraction which affects your structure over a period of time. Moisture, or rather excess moisture, enables ASR, accelerates corrosion, changes freeze-thaw resistance, also imbibes and excludes chemical attacks. Thereby, in the process, the structure is rotting away over a period of time. But by enabling breathability, and then adding it up with dryness, you are enabling your structure to allow the diffusion of the moisture or the water vapor which is entrapped, and to attain that equilibrium it wants, to make it dry. In the process, it becomes self-sustainable and also becomes alive. So let me introduce to you all today our deep dry technology, which is a mineral-based active envelope system, the technology of immunity which gives our structures better health and in the process makes it sustainable as well as alive. But what is this deep dry technology? It is not an admixture or a liquid admixture or an additive mixed with the concrete, neither a coating or a layer which is either peeled off or degraded over a period of time. It is a simple 100% mineral active envelope system applied as a render or mortar to your buildings, which is 100% mineral, which is safe, which is eco-safe, which is non-toxic, potable water as well as food grade. So now, if we just dwell a little deeper, let us try to understand the science behind this deep dry technology. If you just see, it is remarkable that the science was always there. Science is still there. It is only the difference in the mindset and the thinking, aligning to what our structure needs, what is the need of the hour. This technology was developed. It is just a difference between pore blocking and pore lining. Any of our conventional waterproofing systems are actually working with this pore blocking mechanism. They are blocking the pores by which they are resisting the water ingress. Yes, purpose achieved, 100%. But unknowingly, by achieving this purpose and by blocking the pores, we are also blocking the passage of water vapor or entrapped moisture into it, thereby choking our structures, thereby generating the cascading effects of corrosion, of micro cracking, of peeling off, of efflorations, and thereby making our structures rot over a period of time, slowly but steadily. What our deep dry technology does, it is a hydrophobic pore lining mechanism or methodology, wherein we simply play with the surface tension, making the angle more than 90 degrees, thereby achieving 100% water repellency and not blocking the pores but lining the pores in such a way that diffusion of water vapors or entrapped moisture as the pore remains open happens in a controlled manner, in a singular movement way, ultimately attaining the breathability and the dryness for the structure, which is the structure crying for, giving its sustainability, and at the end of the day, making it alive. So, this active moisture flux control, what we say, is very important lining, or rather part of this mechanism, wherein this active moisture inflow is preferably connected and interconnected in such a way that it is a singular way of movement, wherein water vapor or entrapped moisture from inside diffuses out to the outside, thereby the structure maintaining the equilibrium it is asking for. Just giving you another picture. Like we breathe, let us structures also breathe. Our deep dry technology is behaving like a lungs to your structure, wherein it is aligning already the micro pores of your structures in a calibrated manner, networking in a manner wherein this controlled singular flow can be possible, and the water vapor or the moisture entrapped is moving out of the system, giving it the desired sustainability and making it alive every single day, day in, day out. So now, if you just calibrate what we have discussed for the last 7-8 minutes, a fine picture will be there in your mind, wherein you will just be amazed to see that one system is actually giving you a dual action immunity, wherein one part is giving you 100% hydrophobic water repellency, wherein thereby the water ingress is completely restricted, thereby wherein also simultaneously the pores are already activated, it is not blocked, it is making the structure more breathable, the entrapped moisture and water vapor is being passed out, the structure can diffuse out, that can attain the internal equilibrium they are asking for, at the end of the day making the structure more breathable and more alive. So actually this system is 2-in-1, wherein you have not asked for the second one, but that second asking is the ask for the hour, rather than only the priority of making the structure completely waterproof. So there lies the advantage of our deep dive technology. Now, any process is not a process, remains a hypothesis until and unless it is calibrated with codes. So, in front of all you august peoples and members, let me just corroborate with the codes where it is already there, or the standards. The standards for water permeability, EN 12390, part 8, says that or deep dye technology is impermeable with 1 bar under 1 bar pressure. The permeability or breathability as per EN 1015 part 19 says that the mu is less than 8, which makes it highly permeable. The compressive strength as per EN 1015 part 11 gives greater than 10 Newton per meter square. The addition to the substrate as per EN 1015-12 says it is greater than 1.5 Newton per meter square. So all these structures, or all these slides, or all this story put together, it is only very remarkable to understand today that in today's world, which is ever changing, simple thoughts like us in ECMAS, capitulated with a strong and aligned vision, curbed with proper execution and thoughtfulness, can give extraordinary, remarkable results in terms of our technology, which is deep dry technology. Let us all forge together, put our step together to attain a structure, our structure with a self-sustainability, aliveness, wherein they will be permanent, to attain ultimately a bigger, bolder and brighter future. Thank you all. Thank you.
Thank you, Minaldi, for an excellent presentation, and in fact making a presentation which is a mix of technical talk as well as what I call a managerial call, or a MBA kind of call, which I actually learned when I was doing MBA. Last presentation for the day, we invite Mr. Florin Crane. He's already here. The topic he's going to present is large NATM cross sections in urban infrastructure. Sir, as I said, you got 15 minutes, 12 plus 3. Thank you.
I'll try to be fast. Good evening, ladies and gentlemen, and thank you very much for the invitation. My topic today has to do with things which are already constructed, and it's basically what happened in Metro Pune. And I will skip a few slides which are more of general nature to keep up with the time. So just the short introduction. You may know, I'll make it very fast. In India we have 8 metro cities and they demand underground metro for the transportation. And the challenge is always in urban areas that we have space constraints. That means we cannot go with cut and cover as usual. We have to go with mined methods. So a brief overview of Metro Pune, phase 1, which is already operational. We have in this corridor about 5.1 kilometers of underground works. And there is 2 packages, package UGC 1 and UGC 02. I will take examples from UGC 02. We had 3 underground stations, Budwapet, Manda and Swargate, and the first 2 stations had NATM parts. In Swargate we have an NATM crossover for operations. Now, something very brief, and when I presented this in Europe, people were a little bit awestruck. The award happened in February 2019. I'm speaking, so to say, as member of the detailed design consultant for the contractor, that's TCPL and GeoConsult in joint venture. The TBM tunneling started practically 10 months after award, which is very fast. The final breakthrough we had basically 1.5 years after the first machine started. The first leg of the operations went operational in August 23, so a bit more than 4 years, and the commercial operations of the full stretch started in 2024. Now coming to the NATM in metro tunneling in India. So NATM is the new Austrian tunneling method, basically mining by using the strength of the ground. The first stint was Delhi Metro Phase 1 in 2002. There was a space constraint in Chavri Bazaar station, so it had to be done with 2 shafts and NATM for the platform tunnels in between. Then in Delhi Metro Phase 2, in the airport metro link, that's 2008 to 2010, there were environmental reasons because the Central Ridge Reserve Forest cut and cover was not possible. But the cut and cover was then converted to a double-track NATM tunnel, which is already slightly larger than just a platform tunnel. And we had here rock and soil drives. And then what I would say is then the landmark project that was Mumbai Line 3. NATM was here included from the very beginning in the whole project. So the option to have mine tunnels was always there. Remember in phase 1 and phase 2 this was an alternative to be taken because of other constraints. And I think one thing has to be pointed out. In Metro Mumbai we also had an additional NATM structure that was the crossover in UGC 6 because operations required another crossover and it had to be done like this. And when you go then, so to say, the development of the size of the cross sections and what is being used, in Delhi Metro Phase 1 we had platform tunnels single track, Phase 2 double track, it's slightly larger. In Metro Ahmedabad we had a very short single track NATM running tunnel stretch. In Metro Mumbai Line 3 we had already twin track crossover tunnels and the center-center distance of the tracks was about 11 meters. The crossover solution in UGC6 was very special because there, due to the track alignment, we had 20 meters center-center. So it was a complete special solution, not a single cross-section. And in Metro Pune, we have a maximum track distance of about 15.3 meters. So now this is basically a very small NATM cross-section, which is slightly larger than a mine tunnel with a TBM. And the Mumbai UGC6 crossover, what you can see here, is basically what the machines did before we opened this large cross-section. That is already fully operational and worked actually quite well. There was a few other innovations in that year. We were in the beginning not allowed to design with sprayed concrete lining, so this is a normal RCC lining, and later on the contractor made a package of alternative works where they put in also a sprayed concrete lining to avoid the changes in formwork. Now coming back to Pune, we had very good boundary conditions because we have Deccan basalt, we had an intact rock strength of 80 MPa, so basically we were blasting out rock and replaced it with concrete. Rock had different levels of weathering, but wherever we did the excavations, we were in fresh and moderately weathered rock mass. Soil was not present, luckily. Groundwater levels were relatively high, and the design groundwater level was at surface level, so that was a bit of a challenge. I'm coming to that later. And seismicity was zone 3. So now, to give these examples what happened, we have here the Budvastedt station layout, and the machines were coming from that side and from the other side. This was an open cut and cover box, and you can see here on the concourse level it was all cut and cover, but this part here was done by mining. Monday station, also very complex situation. Monday was a drive-through station. So again, we had boxes for the cut and cover and also for the access. And then we had the mine sections, which were done later on. And this is now the cross-section of such a station. And please, that is approximately 25 meters what we have in span for the excavations, which is quite extraordinary in an urban environment because our cover was not more than our span was. And you see all the equipments and all the facilities for a metro station had to be brought into this cross-section. Now the last one, what I wanted to mention is the Swagat crossover. So we have here the Swagat station, which was done in cut and cover. And then the contractor had to drive this tunnel, and it's marked here. The TBMs were launched here inside the tunnel. So this was a challenge in itself, because you had to bring everything from here to here. All the excavations were done before the TBMs could start. And what is also worthwhile noting, here we have a flyover, and you can see here the pillars of the flyover. The distance was, I'm not sure whether you can see that, approximately 5 meters from the pile foundations to our excavation line. But we had no movement, nothing. There was a lot of instrumentation done and a careful driving here also. This is now in detail how far we went or how close we went to the pile foundations of the flyover. Now this is the cross section for the start, and you can see here we had to widen it slightly to get the cradles in for the TBMs to be launched. Now the excavation sequences were slightly different. When we did, so to say, a new NATM drive, we went with 3 headings, so one after the other, staggered, because of logistics. And in Budapest and Monday, in the areas where we had a drive-through, you can see this here, the TBM tunnels were already done. So basically we widened the TBM section, and at the end we took out the middle pillar. And now, to stay in time, some impressions. I mean, this is the people and this is the cross-section. I think here you can see it even better. One person, the 2 TBM tunnels, and that's the head wall in Budapest station, it must be. And when you look in the other direction, outside, you can see here the excavator. They are preparing the invert with the waterproofing membrane already, and these were then finally done in RCC. And the work will continue. Recently, SAM India or ITD has been awarded with the extension, and if the timelines are the same, then in Q3 2026 the TBMs will start again in Pune. I think I stayed in time. Thank you very much.
Thank you, sir, for taking us through a really complex geometry and the way you are executing it. You will take only one question and we will find out.
Sir, probably you are aware in Telangana, in state of Telangana, there is a Srisailam left bank canal. It's a 52-kilometer tunneling work, which has started about 20 years back. Recently, there was a collapse and 8 fellows died, workers. Now, of course, I don't want to name the company, but it is bankrupt. The government of Telangana is looking for either they want to replace the contractor or something like that. If you have any interest, it is a challenging work. 10 more kilometers has to be done. You can Google
I
SLB.
have to say one thing. We are consultants. Professor Tandon is sitting here. He is our joint venture partner since more than 10 years. We are not executing. We did the design for that. The executing agency was Tata Projects and Gülamark in Pune, both packages.
Because it's a highly challenged, and the government is looking for any technology provider for that matter from worldwide.
Thank you, sir. Thank you, pleasure. Yeah. So I will hand it over to our organizers, Girish. You please take over, and we can proceed further. Thank you.
Sir, please remain on the stage, sir. Thanks to Pradeep Garg, sir. Thanks to Mr. Nilotpal Kar. Thanks to Engineer Florian Kren, and thanks to Mr. Mrinal Mitraji for all that exciting yet brief presentation. Now may I call upon the seniors and the mentors of our organization, Dr. Anil Joseph, Professor Anurag Mishra, sir, Professor Niharika, and do we have Mr. Suresh Kumar GB? Okay, Dr. Nagendra, sir. Dr. Nagendra, sir, can you kindly come out to the stage to do the honors on behalf of Indian Concrete Institute? So please. Dr. Niharika, madam, can you come out to the stage, please, to do the honors on behalf of the Indian Concrete Institute, please. Sir, onto the center stage. May I request Mr. Nilotpal Kar to please come out to the stage to receive the honors from us. Thank you, sir. Please stay on the. Please stay. Ladies and gentlemen, please give them a big hand, please. Thank you very much. That's a very eco-friendly bouquet, sir. You have been speaking. You are always fond of being, cradle to gate. So please remain on the stage. Now may I call Mr. Mrinal Mitraji to please come over and receive the honors from us. So please be on the dais. Please come, sir. Please give them a loud applause, ladies and gentlemen. Thank you. Thank you. Now may I request Mr. Engineer Florian Crane to please come over to the dais so that we can do the honors onto you. So that's Engineer Florian Crane from Geo Consult India Private Limited. Thank you. Yes, it's embossed with the ICI logo. So whenever you feel warm, you know that it's from Indian Concrete Institute. Thanks to all the esteemed dignitaries. Thank you, sir, for doing the honors as well. So, ladies and gentlemen, though we have come to the end of today's session, we begin at another very important session, that is identifying and awarding some of the coveted awards in our country. That will be followed very shortly. But before I close this session, may I remind you that Indian Concrete Institute has got excellent publications which can be seen on its website on almost 7 subjects, like industrial flooring being one of them. I request each one of you to visit our website, which is indianconcreteinstitute.org, and these publications are available for purchase online. Thank you, and please be seated while I hand over the stage to our headquarters. Thank you all. The program will be followed by dinner. I request all of you to join us for the program, and I would like to take this opportunity to thank Novoco for sponsoring the dinner tonight. Thank you. Over to you, Dr. Radhakrishnan, sir. And we have a lucky draw for the lucky delegate. Let's see who it is. It is Dr. Manju Prasad from Bengaluru. Dr. Manju Prasad, sir. Dr. Manju Prasad. Do we have him here? Okay. We have Dr. Shubham Raj. Dr. Shubham Raj. And we have Mr. Arshad. Mr. Arshad, yes. Do we have him here? No, he's not there. We have Mr. M. Varaprasad. Is he there? Okay. The next lucky delegate is Dr. Y. Amarnath. Is this artificial intelligence that we are picking those who are not there? Thank you. Okay, we have Mr. Tarun Gupta. Do we have him in the hall? Oh yes, ultimately. Please come. Please come, sir. Please come on to the dais. Yeah, we have 2 more lucky delegates. Let's see who they are. Mr. S. Ravi Verma. Mr. S. Ravi Verma. Mr. KRC Reddy. Do we have him here? Mr. KRC Reddy. Yeah, please come. Please come. Please come onto the stage. And we have Mr. Alex Livingston Raja. Mr. Alex Livingston Raja. Okay, please come. Yeah, yeah. Go ahead, go ahead. May you always be in light. That's why they're giving you flashlight.
Madam,
Now may I request our Secretary General, Engineer Radhakrishna sir, to please take over the dais. Thank you. Do we have, Mr. John, do you have ICI presentation, corporate video? Can it be staged now? Okay, fine, over to you.
Over the centuries, civilizations have prospered because mankind has taken gigantic leaps to harness technologies to create infrastructure, the backbone of all the economies. The binder at the core of infrastructure development has been concrete. Spearheading advances in concrete and concrete construction in India is the Indian Concrete Institute, one of the leading professional bodies catering to the professional needs of individuals and organizations involved with concrete. As a non-profit organization, ICI is dedicated to the knowledge and addressing constant research needs in the field of concrete, as well as to promote concrete technology and quality in construction. In 1982, SERC Chennai and Anna University jointly conducted an international seminar on modern concrete construction practices. The delegates of the seminar resolved to form an organization to spread knowledge so that developments in concrete could be shared with many Indian engineers. Thus, the Indian Concrete Institute was formed. From just around 500 members from 5 regional centers in 1982, ICI has grown today to be a strong professional body having more than 14,000 enrollments from 46 regional centers spread across the country. Of these, more than 400 are organizational members. Today, ICI is a binding force, creating synergy between all segments of people, namely practicing engineers, consultants, designers, manufacturers, research scholars, academicians, and students. ICI, through its regional centers, conducts varieties of programs like seminars, workshops, conferences, exhibitions and training program, webinars and more, each providing the participants platforms for learning and sharing at national and international level. Each ICI event is a great opportunity to listen to and to interact with all segments of people in the concrete industry and get updated on the latest materials, technologies and practices. ICI's program Deminar is a unique event combining demonstration and seminar. Here products are demonstrated outside and they are live streamed into the seminar hall. Thus the participants can observe the demonstration while it is being explained by the speaker. ICI events, among other things, are focused on sustainability through the use of innovative materials and techniques. The response to such programs from government bodies is overwhelming. The objectives of ICI are clearly defined. Every action of ICI focuses on a tangible output for the benefit of practitioners, end users and society at large. On 7 September every year, Concrete Day is celebrated as an annual event at all centers in a big way to commemorate the day of formation of ICI. Working in close coordination with central and state government bodies like CPWD, PWDs, CBRI, CRRI, SERC, IITs, municipal corporations and more. ICI helps these bodies to adopt latest technologies and practices in infrastructure building. ICI members also participate actively in several committees of BIS focused towards advocating standardization in construction practices. ICI is participating actively in the Asian Concrete Federation, a group of professional bodies of more than 10 Asian countries. ICI has signed MOUs with many other peer concrete institutes around the world for exchange of technological information, technical documents, and to organize programs jointly. Keeping the ever-changing future in perspective, ICI reaches to budding civil engineers through its students' chapters. There are more than 300 students' chapters all over the country and the numbers are constantly increasing. Each chapter is focused on enabling industry-academia interaction aimed at bridging the gap between basic theoretical knowledge and professional practice. This imparting of requisite knowledge to budding engineers enhances their outlook and employability. ICI identifies, recognizes and awards the experts in the field of concrete for their contributions to the development of concrete technology and concrete construction. Every year, 16 such awards are presented at the time of AGM. To demystify concrete, the Technical Board of ICI brings out valuable technical documents on topics of importance for the benefit of practicing technocrats through its technical committees consisting of subject experts from different disciplines. ICI conducts need-based training programs at its technology centers as well as customer sites for the benefit of practicing engineers and students. ICI Journal is of national repute today. Very soon, a journal of international standards will be brought out in collaboration with a world-renowned publisher. Every dawn at ICI summons a new approach and new initiatives to create milestones in the journey of concrete construction in India. ICI has enabled the multifaceted and rapid development of concrete construction in a well-planned manner. It stands proud today with a distinguished reputation as a forerunner and a binding force in civil engineering industry in India. Come, join and strengthen ICI. Let us make our concrete structures sustainable, durable and best in the world.
Thank you for that commercial presentation of Indian Concrete Institute and giving us a brief insight. Ladies and gentlemen, as we start this awards program, the annual awards program of the Indian Concrete Institute, we will begin with a very nostalgic moment. We have an octogenarian with us in Mr. Sunil Bajaj, who despite being an octogenarian has been with us right through this ACECON 2025. And as a token of gratitude and more as a salute to his enthusiasm despite his age, we would like to honor him, and may I request Mr. Sunil Bajaj to kindly come over, sir, so that we can do the honors on you. Thank you so very much. I request the President Dr. V. Ramchandra, the Chairman of Indian Concrete Institute Dr. Venkat, the President-elect Engineer Manoj Kavalkarji and the Secretary General Engineer Radhakrishnan to please join to honor Mr. Sunil Bajaj of the legendary Bajaj family. And we are really thankful to you, sir. You are a great motivation to most of us because you have been right through every hour through this ACECON International Conference. Thank you. Thank you. May we request Mr. Suresh sir, we have Mr. Suresh sir also, please join sir. And may we also request Mr. Hegde sir, please join in honoring this legendary octogenarian, Mr. Sunil Bajaj, the Managing Director of Bajaj Reinforcements Private Limited from Nagpur.
In fact, he has supported our event, ACECON event, and from all the way from Nagpur he has attended, and he is a brother of Rahul Bajaj, Bajaj family. Thank you, sir. Thank you very much. Thank you. Thank you. Thank you.
Good evening, esteemed delegates. It is our privilege to welcome you all for the Indian Concrete Institute National Awards. Your presence enriches this gathering celebration, and we are honored to host these distinguished awardees and guests tonight. We are truly grateful to have you all with us as we came to celebrate together ICI National Awards. Today we are delighted to have you all at this momentous moment. Now I welcome Secretary General R. Radhakrishna Sir to address the gathering.
Ladies and gentlemen, esteemed guests, and distinguished members of civil engineering community, good evening to you all. It is my distinct honor and privilege to stand before you today as we gather here to celebrate the exceptional achievements and contributions of the civil engineering professionals in our midst. Welcome to this prestigious awards function, where we come together to recognize and applaud the remarkable individuals who have played a pivotal role in shaping the landscape of this country. Concrete, often regarded as the backbone of modern infrastructure, stands as a testament to the innovation, resilience, and dedication of the professionals we are here to honor. The structures they design and build not only shape our cities, but also contribute significantly to the progress and development of societies around the globe. Today, we have the opportunity to acknowledge and celebrate the visionaries, the trailblazers, and the unsung heroes who have pushed the boundaries of excellence in concrete civil engineering. These individuals have demonstrated an unwavering commitment to advancing the field, whether through groundbreaking research, cutting-edge design, or the successful execution of projects. As we embark on this journey of recognition, let us reflect on the transformative power of concrete and its role in shaping the world we live in. It is not about mixing cement, aggregate, and water. It is about forging connections, building communities, and leaving a lasting legacy for generations to come. The awards we present today are not just tokens of appreciation. They are symbols of inspiration and encouragement for the future. They serve us as a reminder that each achievement, no matter how small, contributes to the collective progress of our country. To all the nominees, I extend my heartfelt congratulations. Your dedication and passion have set standards of excellence that inspires us all. Today, we celebrate not only your achievements, but also the spirit of collaboration and innovation that defines the concrete civil engineering community. As we move forward with the ceremony, let us come together to honor these outstanding individuals and their indelible contributions to our field. Thank you all for being a part of this momentous occasion, and may the spirit of excellence continue to guide our journey in the world of concrete. Thank you all once again. With this, I hand it over to Sridevi to continue the program.
Now, let us have a look at the jury members. The first category of award is for the lifetime achievement. We are honoring 4 eminent experts today. Under this category of award, who have made exemplary contributions to the construction industry. We invite ICI President Dr. Ramchandra Sir to the dais to honor the awardee. To announce the award and honor the awardee, we invite Professor Mahesh Tandon.
Very good evening to all of you, ladies and gentlemen. It's my pleasure and privilege to announce the first award, ICI Awards 2025 for Lifetime Achievement. And this first award is sponsored by Messrs. L&T Construction. And this award goes to Mr. V. Suresh.
We invite ER V. Suresh to the dais. Let's watch a brief AV on ER V. Suresh. Ladies and gentlemen, please put your hands together and extend a thunderous applause to our esteemed delegate. John sir, please play the PPT of Suresh sir. And I request ER Viresh sir to share his thoughts.
A very happy good evening, ladies and gentlemen. It's a great honor, pleasure and privilege to stand before you, all you distinguished civil engineers and people in the concrete sector for bestowing this honor of lifetime achievement. Well, it's been 60 years ever since I got out of the portals of the oldest engineering college, not only in India but all of Asia, college in Guindy, 1960-65 batch. And over the last 60 years time period has been working in the sector of building construction in a and not only building but also infrastructure construction of a large way. And the role concrete plays in the sector is phenomenal, as it has become a euphemism to wherever you talk over there, be it a politician or a bureaucrat or whatever, they say don't talk loosely, come with a concrete solution. So concrete has become a euphemism for something permanent, something very important, durable and things like that. So, and we ourselves have seen in the last 60 years time the phenomenal amount of progress that has been made in this particular sector of concrete to be increasing. At one point of time, when in the early 60s and all, if strength was the most important component that was, but now durability has come as a very important issue of how strong it can be there. And today when I'm talking in front of you, I'm very happy. It's also a very momentous time period because IS 456, which is the code for concrete, which is by the Bureau of Indian Standard, and 1343 for pre-stressed concrete, and IS 456 for reinforced concrete. They are both being brought under a unified document called the Structural Concrete Code there, and that's now come on wide circulation. It's gone all over not only within the country but also all over the world. The document has gone on wide circulation. It's one of the finest documents which really crystallizes all that, and is also getting reflected in the latest version of the National Building Code of India 2025. And Jose Kurian sir, one of your earlier president, is the chairman of the concrete code, were having worked on this. And my own area, whether working in the Bureau of Indian Standards earlier or the Housing and Urban Development Cooperative for 22 odd years, and subsequently with the private sector development Hiranandani group, it has been a great opportunity to work in the sector, and I'm deeply honored. In fact, I'm actually short of words to convey my words, really speaking. Deeply touched and honored by this, and Indian Concrete Institute has really played a very, very important role in promoting the use of concrete, not only within the country, but the international type. I was just telling to Hegde sir, the type of linkage that you have been able to have from ICA in the center with all concrete institutes in different parts of the world. There was a great honor once again to get this award, and I accept it in all humility. Thank you very much.
I request the President to remain on the dais to present the remaining awardees too. Let us move on to the second award in this category. To announce the second award, the honor, we invite Dr. Mr. Kalgal.
Good evening, ladies and gentlemen. It gives me great pleasure to announce the another Lifetime Achievement Award of 2025, and this is sponsored by ACECON Group, and the award goes to our close friend Samir Surlekar.
We invite E.R. Samir Surlekar to the dais along with Sika people. Let us watch an AV on E.R. Samir Surlekar, sir.
I request his son, Sunny Surlekar, also to join on this dais here, please. Sunny.
all to please applaud our honorable awardee. I request Samir sir to say a few words.
Good evening, ladies and gentlemen, concrete enthusiasts and lovers of concrete. I don't know what to say. I had taken my speech out from the AI, but I don't think I'm in a condition to say it. I am at loss of words. I'm very happy awards. It's always a pleasure to receive awards. And it is nice and nicer still when it is from our fraternity. I thank Indian Concrete Institute, especially the jury, President Dr. Ramchandra, President-elect Mr. Manoj, all 4 vice presidents, members of GC, as well as I thank our dear Secretary General Mr. Radhakrishna, who is a rock-solid support for the growth of ICI. I think Mr. Suresh has already talked about the concrete, so I think I will, and my biodata was a little bit too big. It made me remember when I was really looking good when I was young. And from what they showed, it looked to me that all my time I spent in receiving awards only. So I did some work with concrete. My association with ICI is directly since its inception, that is 1982. So I'm one of the oldest members in 1982. I was passing by in India. I was in Germany at that time. At that time, I became a member when it was formed. It was also a platform for me because they received all my ideas. And I'm from a field of construction chemicals. It was not known. I'll just take 1 or 2 more minutes. My relation with concrete came when I was in college in 1974. For us, it was only 15 marks. Just we could leave it for choice. My interaction became more when I joined my master's degree. Then it was half a subject. But my real interaction came when I started teaching in the college and they told me to teach concrete technology to final year students. So that was quite difficult. I never learned concrete myself. I learned for maybe 5-6 hours and they told me to teach for 30 hours. That's the first time I visited the library and read from the A.M. Neville and F.M. Lee's book. So this is what happens. What you don't study in college, you have to teach. And teaching makes you really stronger. So I think when I receive this award, I'll not take it as a closure of my contributions or working further. I will prefer I'll rededicate myself with a commitment to concrete, sustainable concrete now that we know new concretes. I would like to spend my time, join my hands with institutes as well as ICI to develop the skills of the new generation. I think that is what is most important. I think what is happening while the think tank knows all about sustainable concrete, ultra-high performance concrete, what is desired and designed by us does not get translated on the site. There are a lot of failures. I think ICI should help us to fill that gap. To do it, I am at your service. Thank you. Thank you.
Thank you, sir. The third award in this category has gone to Dr. Prem Sundar of New Delhi. He he is not able to make it to this award function as his flight was not cancelled. Anyway, we will watch a audio AV on Dr. Prem Sundar. To please play the AV of Prem Sundar, please. I request Dr. Achal Mittal to come and receive the awards on his behalf and hand it over to him, sir.
Good evening, friends, and my senior. I am happy to receive award on behalf of my professor, Professor Prem Krishna. Indigo has made it happen that I am here in his behalf. We will, as a Vice President North, we will try to organize an event in North, and I will request the President to promise that he will come, and we will, and President-elect also, so that we can honor him personally. Again, I'll give this honorable things to him, I will deliver. So, and whosoever can come, and I thank on his behalf to all of you, to ICI, and all the members of the jury and the organizing committee. Thank you very much.
Thank you, sir. It is time to know the fourth awardee under Lifetime Achievement category. We invite E.R. Vinay Gupta, sir, to announce this award and honor the awardee.
Vinay Gupta sir, you have been invited to announce the awardee.
I request Vinay Gupta, sir, to address the show.
Good evening, everybody. What a momentous awards, and this is one of the highest category awards. This is ICI Awards 2025 for Lifetime Achievement, is sponsored by Messrs. Bureau Veritas India Private Limited, and this award goes to Pathasarthi Sen Gupta. Mr. Sen Gupta, congratulations. Please come on the stage.
I invite Pathasarthi Sen Gupta, sir, to come onto the dais. Let's watch an AV on Pathasarthi Sen Gupta, sir. AV, please. Now I request Pathasarthi Sen Gupta, sir, to share his thoughts.
first of all, I must thank ICI and along with the executive committee members who has given this honor to me. Throughout my life, after graduating from IIT Kharagpur, last so many years, 79, 81, I have done my post-graduation. And since then, I'm worked with a construction company. I have seen wide change in the concrete technology, right from the mixing procedure, the transportation procedure, and the placing of the concrete. All these things are important actually, otherwise we will not get the quality. Another thing, as I have worked in a construction company, most important is also to not to forget about the cost part of it. You can make some very rich concrete which is not required, so it should be very cost effective. Workability, it should be construction friendly. So this is another aspect. Most of the structures during my career, it was with marine structures. It is a very typical structures actually. The concrete placing is very important there. You don't know what is happening inside, under the water, unlike the shuttered concrete we see everywhere. Last 40 years, I have seen wide change in the concrete technology. Say, big companies, they used to carry the concrete in dumpers, tilting dumpers, with a chute behind, and they used to place the concrete like that. The batching plants were very crude type. Nowadays, what you are finding actually, you can get ready-mix concrete in the township area, very good concrete. Transportation is widely changed, transit mixtures and pumps, etc. But in marine structures, that problems remains actually. During concreting, you have to take care the quality control in a very tedious way, otherwise will not achieve the required quantity. In future, there will be a lot of changes, and I'll be watching it. Right. Thanks again to the organizers and especially the committee members who have given this honor to me. Thank you.
Thank you, sir. The next award is for Outstanding Concrete Technologist. To announce the recipient of the award, we invite Professor S.P. Shah, sir, to come on to the dais.
Good evening, everybody. It's my pleasure to announce ICI 2025 Outstanding Concrete Technology. And I'm sorry, the award is sponsored by Fosrock Chemicals Private Limited. And it's my pleasure to announce that the award recipient is Dr. Keshav Chandrakant Teyade.
We invite Dr. Keshav Chandrakant Teyade to come on to the dais.
I can go.
Now let us look at the profile of Dr. Keshav Chandrakant Teyade, sir. I request Chandrakant Tayade sir's family member to come on to the dais. Away women behind Kesav sir victory. Please give your awardee. Please give our awardee a big, well-deserved round of applause. Now I request Kesav Chandrakant Tayade sir to say a few words.
Good evening to you all, respected dignitaries, distinguished members of the Indian Concrete Institute, esteemed guests, colleagues, family and friends. As I stand before you to deliver my acceptance speech on getting this coveted award, I thought of reading my speech instead of speaking extempore to save on time and to make it all-inclusive. Receiving the Outstanding Concrete Technologist Award from the Indian Concrete Institute is a profound honor, one that fills me with immense gratitude and pride. I extend my sincere thanks to the Indian Concrete Institute for selecting me for this prestigious national award. To be acknowledged by such an esteemed body is truly humbling. I am deeply grateful to the President, Dr. Ramchandra, Secretary General, Engineer Radhakrishnan, and the Governing Council of ICI for this honor. My heartfelt thanks goes to Engineer Manoj Kavalkar, President-elect, Dr. Pandey sir, Dr. O.N. Mukherjee, Engineer P.S. Patankar, and Engineer P.P. Deshpande, the Chairman of ICI Nagpur Center, for proposing my name. Their support, along with the efforts of the entire local management committee of Nagpur Center, has played a crucial role in making this recognition possible. In my journey of 40 years in the profession, I got opportunity to design, execute, and monitor about 30 lakh cubic meters of concrete in metro rail and water resources projects. The award is not just a personal achievement, but it's a celebration of collective effort with dedication and resilience, which helped transform ideas into reality. Our passions, patience, and commitment forms the true foundation of the accomplishment. Concrete may be a material, but for us it is also an art, a science, and a responsibility that supports the progress of our nation. I am thankful to my Managing Director, my Director Project, Director Works, and all the other directors of Mahametro and my mentors whose guidance shaped my professional path. I am also immensely thankful to my family, my parents, wife and sons for their continuous support. Their understanding made it possible for me to devote myself wholeheartedly to the work. Their support is my strength. My speech will not be complete without expressing special thanks to my friend, Engineer Sanjay Tambe and his wife who came and who traveled with us all the way from Nagpur to attend this program. I am also thankful to our industrialist Sunil Bajaj from Nagpur and my friend Mr. Atul Kale, the consultant. This award motivates me to keep exploring new technologies, sustainable practices, and higher standards of excellence by adopting the Kaizen method in quality. Thank you for your encouragement and presence today. Jai Hind.
Thank you, sir. The next award is for Outstanding Concrete Structure. We received 20 nominations this year. Jury members had to sweat a lot to evaluate the nominations. Let us look at the nominations first. The nominations are Now I invite Engineer Manoj Kawalkar to announce the award-winning structure and honor the awardee.
Thank you, madam. Lot many entries were there. Do you have any guesses for the award? Outstanding concrete technologies. It's my pleasure to announce IC Award 2025 for Outstanding Concrete Structure, sponsored by Messrs. MC Bauchemi India Private Limited, goes to the project Rajasthan Atomic Power Plant 7 and 8 project.
I invite the representatives of the following organizations to the dais: the Nuclear Power Corporation of India Limited, the owners of the project, L&T Constructions Chennai and MS JMTC Constructions, Rawat Bhat, the principal contractors. Ladies and gentlemen, a big round of applause for our extraordinary awardees. Now I request the representative to speak a few words addressing our show. Thank you, sir. Jury for the Outstanding Concrete Structure Award found another deserving project to present their appreciation award. We invite Dr. Anil Joseph to announce the award-winning structure and honor the awardee. We invite the representatives of the following organization to the dais. The Prestige Estates, Mumbai, the owners, MS L&T Constructions, Mumbai, the principal contractors, and MS JW Consultant, Mumbai, principal consultant of the project. Let us watch a brief presentation on the award-winning structure. Thank you, sir. The next one is the award for Outstanding Pre-Stressed Concrete Structure. Let us look at the nominations. I invite Engineer Pradeep Garg to announce the award-winning structure and honor the awardee. Engineer Pradeep, sir.
It's a pleasure to declare the Outstanding Priestess Concrete Award 2025, sponsored by BBR India Limited. The award goes to DMRC Delhi, Mojpur Link.
We invite the representatives of the following organizations to the dais: Delhi Metro Rail Corporation, DMRC, the owners, Long Gain, KEC JV Delhi, the principal contractors, and Pedico India Private Limited, Mumbai, the principal consultant of the project. Let's have a brief presentation on the structure. Please give a big round of applause to the awardees. Thunderous applause, everyone. Thank you all. The next one is Jury Appreciation Award for the same category, Outstanding Pre-Stressed Concrete Structure. We invite Dr. Venkateshwara Garu and PP Deshpande sir to announce the award-winning structure and honoring the awardees.
Outstanding Pre-Stressed Concrete Structure, ICA Award 2025, Jury Appreciation Award for Outstanding Pre-Stressed Concrete Structure goes to the project 330 meters span cantilever and pre-stressed concrete box girder type bridge at Bhagchal.
I invite the representatives of the following organizations to the dais: the Public Works Department, Himachal Pradesh, the owners, and MS, Gammon Engineers and Contractors Private Limited, Mumbai, the principal contractors of the project. Let's have a brief presentation on the structure. Kindly put your hands together to appreciate their excellence.
So I'd like to, thank Mr. Kulkarni as well as our friend for, being so gracious to call me to the stage to receive this award along with them, because this particular project was conceived as well as executed. Later it was completed by Mr. Kulkarni as a total in charge. I was completed in Gammon Engineers and Contractors Limited. So I'm really grateful to them for being so gracious to call me on the stage to receive this award along with them. It was one of the very complex projects, very complex because it took almost around, there was a stoppage of work for 8 years because of the geotechnical surprise which was encountered during the execution. And this was to be done in a very treacherous, because the foundation you can see, it was in a backwater basically. Always the standing water was there. The working period was only 3 months, and the duration of the contract was 24 months. That was the kind of situation. It's a longest 185 meter span cantilever girder bridge in India as on date. It's a record in India. In fact, congratulations to Gammon Engineers and Contractors Private Limited. They have done a wonderful job here. Thank you.
Thank you for giving this award. Thank you to ICAI.
Thank you all for your presence. Is the award for sustainability in concrete construction. Let us look at the nominations first. We invite HR Girish sir and LR Manjunathan from JSW Cements to announce the award-winning project and honor the awardee.
The ICAI Awards 2025 for Sustainability in Concrete Construction, sponsored by
JSW Cement Limited,
goes to the project Navi Mumbai International Airport, Mumbai.
I invite the representatives of the following organizations to the dais. MS Navi Mumbai International Airport Private Limited, Mumbai the owners, MS Larsen and Turbro Limited, Mumbai, and MS Nagarjuna Constructions Company Limited, the principal contractors, and MS L&T, EDRC, PTB and Building, Jacobs Airfield, the principal consultants of the project. Presentation, please. A big round of applause to the awardees, please.
Thank you very much. Thank you ICA for the award, and thank you jury members, and thank you everybody.
The next one of the award for Best Project with Precast Concrete. Let us look at the nominations first. Now I invite Dr. Nagendra, Vice President, South, to announce the award-winning structure and join us in honoring the awardee.
Good evening, ladies and gentlemen. ICA Awards 2025 for Dr. A. Ramakrishna Award for Best Project with Precast Concrete goes to the project Willow Warehouse, Pune.
I invite the representatives of the following organizations to the dais. Willow Mathur and Platt Pumps Private Limited, Pune, the owners. Precast India Infrastructures Private Limited, Pune, the principal contractors, and Fourth Dimension Group, Pune, the principal consultants of the project. I request the representatives again. Willow Mathur, Platt Pumps Private Limited, Pune. Presentation, please. Let's treat them with a wonderful round of applause. Thank you all. The next one is the award for innovative applications of special concretes. Let us look at the nominations. Now I request Engineer R. Ravishankar sir from Ultratech to announce the award-winning structure and join us in honoring the awardee. Ravishankar sir, please come onto the dais.
Good evening, ladies and gentlemen. Gives me pleasure in announcing Indian Concrete Institute Awards 2025 for innovative applications of special concretes, sponsored by Mrs. Ultratech Cements Limited. Goes to the project construction of permanent campus phase A for IIT Tirupati. Hearty congratulations.
I
to
invite the
IIT
representatives of the following organizations to the dais. The Indian Institute of Technology, Tirupati, the owners, Kalpataru Projects International Limited, Bangalore, the principal contractors, and Bureau Veritas Private Limited, Bangalore, the principal consultants of the project.
I personally visited IIT Tirupati twice. I know how beautiful it is. Thank you.
Let's have a brief presentation on their projects.
Ladies and gentlemen, first of all, thanks to ICI for giving this award to IIT Tirupati. But one thing surprising I want to share with you, my chief engineer, BS Reddy, who is responsible for his execution, for supervision, he is an electrical engineer, and for 15 months he was doing 3 major projects, IIT Tirupati, ICET Tirupati and Nasin Palasamudram. And I was always confused, is electrical engineer or civil engineer? But he knows more civil engineering than electrical engineering.
Thanks a lot for this award, sir. Thanks a lot. In fact, time is short. Thank you very much for everybody.
It is time to honor the best center. This award is given for the center for its outstanding contributions in fulfilling the objectives of ICI, promoting ICI by fulfilling its objectives, knowledge dissemination through quality programs, strengthening the center from time to time, nurturing students, chapters, compliance to ICI ethics are some of the parameters on which this award is decided. To announce the award and to honor the awardee, let us invite Dr. Ramchandra sir.
This is the award for the best center of ICI. Maybe I'll not even open this. I'll go by whatever all of you say. Who should get this award? I have not even opened it. Therefore, what we'll do is, whatever the name that has come, we will give the award. I welcome Nagpur Center to come to the dais, please.
I invite the chairman, Engineer P.P. Deshpande, for the center and his team to receive the award. Ladies and gentlemen, please put your hands together. Congratulations, sir.
I request Dr. Abhay Bambole and Amit Haridas. Amit, please join.
Wow, how beautiful it is to look. Ladies and gentlemen, a big round of applause. Congratulations to all the members. The next award is for Young Scientist. This award has been instituted by Professor V. Ramakrishnan. To announce and honor the awardee, we invite Professor Abhay Bambole.
See, this award is instituted by Professor Ramakrishnan, who is now 94 years and who stays in Coimbatore. And even at this age, his memory is very green and bright. He did inquire with me when I met him about 2 months back in Coimbatore. He did inquire me whether this award is continuing to be given. I said, yes, every year we give this award in your name.
So it's my pleasure to, as a teacher, always to award the young scientist. ICI Awards 2025 for young scientist, sponsored by Professor V. Ramakrishnan, goes to Mr. Dr. Bijili Balkrishnan from IIT Tirupati.
I invite Dr. Bijli Balakrishnan to receive the award. Ladies and gentlemen, big round of applause. I request ma'am to say a few words. Let's celebrate the victory of women here.
That's always celebrated, I hope. Thank you all the men and women here. So, because she wants to celebrate the women here, I would like to thank all the men behind the women and all the men behind the men, all the women also. This is an honor to be here, and thank you very much all. Without your contribution, we would have not standing here as well. So thanks to the teachers, thanks to the gurus, all of us, thank you very much.
Thank you, ma'am. The next award is for the best paper on construction techniques published in ICI Journal. This award has been instituted by ICI Uttarakhand Center. To announce the award-winning paper, we invite Dr. Achal Mittal sir to come on to the dais.
ICI Awards 2025 for the best paper on construction techniques published in ICI Journal, sponsored by ICI Uttarakhand Center, goes to the paper on white topping overlay insights from an experimental stretch by Dr. Vishal Ramesh Tombre.
I invite the author, Dr. Vishal Ramesh Tombre, to receive the award. A big round of applause for the gentleman. Congratulations, sir.
Namaskar. Good evening, one and all. I am really thankful to ICI headquarters, all the jury members, my professor, IIT professor, Professor Krishna Rao and Professor Jangid, who has helped me from day one. The journey of white topping started way back in 1999, and the code came in the year 2008, IRC code, Indian Road Congress. So since this technology was very new in India, so we did lots of experiments in mixed design, construction practice, and finally we managed to have a methodology for white topping in India. And in Mumbai, we had constructed different stretches in M60 grade of concrete, because Mumbai is very, all you know that is heavy, traffic is very high, we can't close the road. So we started using M60 grade of concrete. The purpose for using high grade of concrete to open for traffic at early stage. So even after 72 hours, we had opened the traffic in Mumbai. I am really happy this technology is used all over India, and thank you to Mr. Dr. Ramchandra. He has helped me at various stages. I will also thank Mr. V.R. Kulkarni, because he has also helped me right from day one. Mr. Bongirwar, Mr. Surlekar, Samir Surlekar sir, Sunny Surlekar, and all my seniors, my friends and my office colleague. Last but not the least, I am thankful for my parents and my own Mumbai Municipal Corporation, Brihan Mumbai Municipal Corporation, who has given me chance for doing all this project. Thank you one and all. Thank you so much.
Thank you, sir. The next award is for Best PhD Thesis in Concrete. This award has been instituted by late Mr. K.P. Pradeep of the East Vale MB Publishers Private Limited. To announce the award-winning thesis and honor the awardee, we invite Professor Mahesh Tandon, past President ICI.
So I am glad to announce the ICI Awards 2025 for Best PhD Thesis in Concrete in memory of K.P. Pradeep. And this award goes to, firstly, the subject I must read, Behavior of RC Exterior Beam Column Joint with Alternative Ductile Detailing under Reverse Cyclic Loading. And it goes to Dr. Bilkis Banu of Anna University, Chennai.
I invite Dr. Bilkis Banu sir to come onto the dais to receive the award. Banu ma'am. I request ma'am to share the dais.
Good evening, ladies and gentlemen. First of all, I'd like to thank the Almighty, and I would like to thank the ICI jury members, and I would like to thank my supervisor, my well-wisher, Dr. K.P. Jaya ma'am from College of Engineering, India, Anna University, and I'd like to thank my husband, Mr. Mahmood Hassan, and I'd like to thank my friends and family for their continuous support. Thank you so much. Thank you, everyone.
Thank you, ma'am. Now we move on to the next award for Best ICI Students Chapter. ICI encourages educational institutions to start ICI students chapters with an objective to connect them to the industries, to get exposure on the practical aspects and the latest technologies and practices in the field, which enhances their employability. The selection is based on the evaluation of the activities of the students' chapters as per the set criteria. To announce and honor the awardee, we invite Professor Anurag Mishra sir to come on to the dais.
Good evening, everyone. The ICI Award for 2025 for Best ICI Student Chapter is sponsored by Mrs. Sikka Group, goes to KDK College of Engineering, Nagpur.
I invite the representatives from KDK College of Engineering, Nagpur to receive the award.
I request our mentor and supporter, Engineer Manoj Kavalkar, to join the dais, please. Engineer P.P. Deshpande, sir, please.
Today Nagpur is leading the show. Congratulations, you people. Thank you all. The next award is for the Emerging Student Chapter. To announce and honor the awardee, we invite Engineer Amit Haridas to come onto the stage. We invite the representatives also.
See, ICI has so many student chapters now, more than 400. Very established institutes, they get this award. Therefore, to encourage the new institutions also to grow in the same way, this award as Emerging Student Chapter Award.
Thank you. The award for Emerging ICS Students Chapter goes to Purnima College of Engineering, Jaipur. Congratulations.
I invite the representatives from Purnima College of Engineering, Jaipur to receive the award. Let's congratulate the young minds with a big round of applause, please. Now I request our Secretary General, sir, to take over.
Arranged how well it is organized and in a grand manner. So I would like to honor the Hyderabad Center for hosting this award function. I invite Dr. Venkateshwara Rao to the dais to receive a memento from the headquarters.
I request all our Hyderabad, IC Hyderabad Center EC members, please come on to the dais.
I request Anjuri sir to come onto the dais.
Next, I would like to call our headquarters staff who prepared day and night for this award function. First, I invite to the dais. She's the senior most staff in our headquarters. She's the one who used to call nominations for these awards and also send it to the juries, collect it back, and she works tirelessly to get all the nominations scrutinized and completed. And she also corresponds with the centers. Now I invite G. Chitra from headquarters, who looks after finance. I also invite R. John, who is a multi-talented person in headquarters, who maintains the database and who also good in I also invite A. Gopika, the youngest member of my team, who prepared all these PowerPoints. Take a picture. I would also like to invite Sri Devi for conducting this program very efficiently.
On behalf of ICI, it is my privilege and honor to extend my heartfelt thanks to all who have participated and graced our occasion. My sincere thanks to the organizing committee and host center, ICI Hyderabad. It is my privilege and honor to extend thanks to all who have contributed to the success of this ICI National Awards. Thank you all. I request everybody to join dinner. To the backyard. We have arranged the dinner for all the ladies and gentlemen. Please join us.